Good morning.
Morning, sir.
Good morning, Prashant.
Morning, sir. I think we will probably in a minute or two we'll start.
Okay.
It's closing 8:15.
Yeah.
What is the count on the participants?
Named on the wall.
Also, this is the same link everybody will come, right, Chengappa? Or there is a separate link for the audience?
No, this this would be the same link, Ashok sir. Yeah.
Good morning, all. It's 8:15. So we'll commence with the proceedings of today because we have a very packed schedule and we want to get started on time. So with that note, good morning to all participants, speakers, and guests. Welcome to the second edition of IEEE Bangalore Technology Conclave. I am Prashant Mishra. I am a IEEE volunteer and I'm the organizing chair for this edition of IEEE Bangalore Technology Conclave. I'm also the current treasurer of the section. So on behalf of the organizing committee of BTC and IEEE Bangalore Section, I extend my warm greetings to all. Now, IEEE Technology Conclave has a tradition. It is essentially a flagship event of the industry relations program of the section, where every year we invite technology leaders, innovators, entrepreneurs, thought leaders to address pressing problems and share their vision on futuristic technologies that may impact our way of living and working. So this edition of IEEE Bangalore Technology Conclave is organized by the section in collaboration with its two affinity groups, namely Women in Engineering and Young Professionals. Based along these lines, this edition of BTC 2021 is based on the theme of clean technologies for a sustainable world. There are 5 sessions spread across 2 days. So day 1 is the smart tech track and includes sessions 1 and 2. It will focus on sustainable transportation, renewable energy storage, energy generation, and ICT for clean tech. We also have session 3 towards the evening of today, which is the YP, which is the Young Professionals Global Meet, that will feature an exclusive fireside chat with IEEE Bangalore Tech Icons. Moving on to day 2, which is the Women in Engineering Global Leadership Summit. It will include sessions 4 and 5, which will focus on clean production and clean materials, as well as sustainable agriculture, looking at the entire value chain from farm to fork, and as well as waste management. We have received immense response for BTC 2.0. We have close to 45 speakers and panelists who will be interacting with over 400 participants over these 2 days. We have received immense support from our partners in BTC 2021, namely Nokia and Cisco, who have supported this conference as pattern sponsors. Finally, the organizing team has worked very hard to put this program together, and we hope that each one of us will be able to take back something new and will cherish happy memories of this edition of the conference. Let me close here and welcome the chairman of IEEE Bangalore Section, Shri B.S. Bindu Madhava, to open IEEE Bangalore Technology Conclave 2021 with his opening remarks. Over to you, sir.
Good morning, ladies and gentlemen. I would like to welcome all the participants to this very important and most discussed topic worldwide because clean technologies for sustainable world. So there are two things. One is clean technologies and sustainable world. So this particular thing, like Dr. Prashant was mentioning, is a combination of the smart tech earlier what we were doing, plus the WIE Global Summit and the YP Global Summit, which are co-located for 2 days. That's already it was mentioned. And this particular edition 2 of BTC is being spearheaded by the industry committee of IEEE Bangalore Section. So I just thought that some small start or pointers, because two words were there. One is the clean technology, the other one is the sustainable world. I thought that for sustainable world, the main aim will be to maximize the probability of achieving sustainable development. That is one of the main, and minimizing the changes of environmental degradation. So these are the main aim of the sustainable world or sustainable development, which is defined in the UN SDGs, which are of 17 goals, of which we are trying to address in this particular thing, goal number 6, 7, goal number 11, and 13. So I think the organizing committee has put up a very good program aligning to this thing, especially goal number 7, 11, and 6, 7, and 11, and 13. So these were some of the things. And the four major component which is sort of linked or emphasized is the climate change, nutrient cycles, hydrological cycles, and biodiversity. So these are the main aims of the so-called clean tech, in short, or clean technologies, whatever the things which have been sort of looked at. And basically, clean technology covers a broad range of technologies, but there is more focus on recycling, renewable energy, information technology. So that's what in this particular BTC also there is an emphasis given on renewables, information technology, green transport. Of course, there is something on green chemistry, lighting, and grey water. And as far as the application is concerned, I think when there is a change in the climate, there is a disaster, and the disaster leads to the health, mainly impacts the health conditions, and also there will be an impact on the agriculture. So even in India, the more emphasis is on today on the agriculture as well as the health, including education. So whatever the technologies goes into this particular thing. And there is some new thing which is called as environment finance, which is happening, like venture finance. Environment finance is what is being sort of spoken about. And these are not currencies, they are talking about carbon credits. So these are some of the important things which are happening. And I think all these goals are trying to be achieved in India also by having something called as, I mean, this is a common thing which is happening worldwide. In India also it is picking up by using the corporate social responsibility funds. So there is a lot of emphasis which is being trying to address in this particular space. So I think in short, I just wanted to tell that this is 2 days totally a technical feast which has been organized by the organizing committee, where many people have logged in, and we should make sure that the stakeholders should get the best benefit out of this particular thing. So with this particular thing, I'm happy to declare BTC 2.0 open. Thank you.
Thank you, sir. Now I invite Dr. Ashok Das, General Chair of IEEE BTC 2021, to brief us about the conference and the core idea that motivated us to organize this edition on the theme of clean tech and sustainability. Over to you, sir.
Thank you. Thank you, Prashant, and thank you, Bindu sir, for a good welcome address. You have mostly covered what is being done and what needs to be done. And when we started this discussion 6 months ago, There were a couple of many ideas, and if we looked at what the IPCC report says, what our NASA report says. Like 2020 was the warmest year in the history of recorded temperature by NASA. So we are there, and it was almost, we have reached 1.07 degrees. 1.5 was our goal target. We hope we will be able to achieve that, but we need to really accelerate our effort in order to achieve that. And if we look at the generation of GHGs, it's primarily the energy sector that accounts for almost 70% of the GHG emissions. So energy definitely is one major area of focus that has been there. So that's how we have a full session on renewable energy, a full session of ICT on reduction or energy efficiency, reduction in energy. And and to achieve all of this, we really need new materials. We need products, we need solutions that themselves are less GHG emitting. So clean production, many production methods have to change, materials have to change. So that is addressed in the third session, and third session tomorrow. And if we look at the contribution of GHG, and agriculture almost accounts for 18% of GHG. So that is another key sector that we needed to discuss, and we have a full session on agriculture to discuss the various ways to reduce the water footprint, the energy footprint, and sustainability of the agriculture sector. So with those, of course, we cannot address all the areas of climate change and clean tech in any conference. So these were the primary focus and the key focus that the world is working around. And I hope the conference will give you certain thoughts, give you food for thought, that how can you contribute, how can you work towards achieving a sustainable world and address the climate change and the changing temperature and the climate scenarios, because that impacts all of us. All of us are impacted, and especially the bottom, the lower, underprivileged community gets impacted even more. So we need to keep thinking about all the SDGs, even though there are a few SDGs are being addressed, but by addressing these few SDGs, you are also indirectly addressing the other SDGs, that how do we tackle those. So keep that in mind, and let's hope, let's move ahead and have a stimulating session over the next 2 years. Thank you. Over to you, Prashant.
Thank you, sir. So I think we are all set to start the proceedings of the day. The session chair for the keynote and session one will again be Dr. Ashok Das, and the volunteers and people who will be steering the session would be Ms. Dikshita and Mr. Atish. So over to you, Dikshita and Atish, to take it from here. Would you please introduce Dr. Rahul Dhongi and the session follows from there?
Thank you, sir. So our first speaker for today is Dr. Rahul Dhongi. Rahul Dhongi is a senior fellow at Center for Social and Economic Harnessing Technology for Sustainable Development. Rahul Dhongi is interested in harnessing technology for sustainable development with domain focus on energy, power, and telecom IT. He enjoys working on interdisciplinary problems at all scales, combining technology, policy, economics, regulation, incentives, etc. He has also led the design and implementation of a number of projects spanning networking, smart grids, energy, RE, education, etc. He had the privilege to work with global leaders on issues of technology and sustainable development. A warm welcome to you, sir.
Thank you. Good morning, everyone.
I request all the speakers to kindly make a note of this. Your session will be for 30 minutes. The first 25 minutes will be your talk and last 5 minutes will be Q&A. So please stick to the timeline. Thank you. Over to you, sir.
Wonderful. May I get rights to share my screen?
You are having it, sir. You have the presenter.
Okay, great.
Can you see
So,
the slides? If you go
yes,
to
I'm just
slideshow mode.
attempting to go into full screen mode. Yes. Is
Wonderful.
this full screen now?
Yes, yes.
Excellent. So, good morning, everyone. I'm Rahul Dhongi, a scholar, professor, troublemaker on issues of technology and policy. And sometimes we academics end up just trying to understand the problem. So that's why I'm delighted to be here with folks who are actually trying to solve the problem. What does smart mean? What does sustainable mean? Are things I'm going to just give a different vignette on and really focus on the why aren't we here yet? And what should we be doing? Now, we heard, this already in the setup. Ashok and others had sort of talked about these global challenges that are well understood: sustainability, climate change, specifically inequality. I really like the point that you brought up on vulnerability and the poor. I'm not going to focus on the market scope or the opportunity or the importance, the need for improvements, which can be technology driven, is undisputed. I'm going to really put things or try to put things together and in context. And here I'll start with the usual disclaimer that these are my personal views. I do not speak for my institute as a nonprofit, a think tank. This CSEP was originally established as Brookings India. Uh, I do not speak for the other stakeholders that I am affiliated with. I'm an adjunct professor at Carnegie Mellon University. I was the founding advisor of the Government of India Smart Grid Task Force and remain I was the technical advisor of the task force and remain founding advisor of the India Smart Grid Forum. So the first sort of thing we have to recognize is this space is not black and white or binary. It's a continuum, and it's actually a moving target. Everything is getting smarter. Well, maybe not everything or everyone, but in general, we know much more about the world. Is there a threshold to being called smart? No one wants to be said I'm dumb or clean is what everyone aspires to. So we're not just saying that do you use ML or AI. We have to be a little cautious about buzzwords and hype and blockchain, for example. Windsurf has a very beautiful flow diagram where he shows, do I need blockchain? No. And the point that he and others make is blockchain, as an example, is very, very good at solving one class of problems. That is not the class of problems that most issues have. So, for example, today, there is now a draft or even implementation from several states in India that they will allow rooftop solar to operate on blockchain. Now, that's interesting. Is that going to change the game? Not really, because what's really going on are two things. One is, what does it cost? So the capital costs are really what drive the system costs. And that's a different story that 90% of our solar panels are imported from China. The second thing that really controls or drives this space is the regulatory framework, which means how am I pricing it? What is it worth to me? For example, when I feed in solar power. So figuring out better metering standards, better accounting standards, things with granularity. That's one of the things that's missing today in the policy framework, which is for example, in electricity, we've historically treated all electricity virtually the same, whether it was at 5 a.m. or 5 p.m. But we know that demand varies, of course, at different times of day. But more than that, the supply is going to vary. So in the future, when solar power is not just ubiquitous and plentiful, but so much that we will be throwing it away or curtailing it in the middle of the day. And that's okay. It's so cheap. But we have a surplus in the middle of the day. We have not re-engineered our systems to reflect these realities. I need more smart. So many utilities, discoms, have said, well, I just need a smart meter and then I can achieve X. The question is, are you harnessing the data that you already have? That is the key sort of flip side that companies, that entities really need to talk about. And the last point I want to make here is that clean isn't just carbon, even though global change, climate change and global warming are almost existential threats. But for a country like India, local air pollution is a very strong challenge with more immediate impacts, not to say that climate change doesn't have impacts. The other issue now facing this space is we know a lot of the trends, we know the direction, but nobody really knows the details. If someone says, oh, I will install this smart grid that will solve all your problems, and at this certain price point, well, they're either kidding themselves, lying, or trying to sell you something. Even though we know sort of exactly where we want to go, we have less clarity on how we get there. What are the changes? What are the winners and losers? Technology is such a moving target. So how do we address that? Now, obviously, it's not appropriate or enough to just say, I'll wait, because otherwise you'd never buy a computer or a mobile phone. Next year, there'll be something else. So we need to have predictability. We'll need to have interoperability. And maybe we also need a certain amount of standards. I was talking to one of the leading electric vehicle charging infrastructure solutions providers, and he said, in addition to range anxiety, which is there, charging head anxiety is another thing, because in India, the norms were notified with something like 5 or 6 different charging standards: CCS, CHAdeMO, AC, DC, then now the Bharat standard, which is very similar to the GBT Chinese standard, actually, with plus with some tweaks. And now, of course, when Tesla comes into town, they may have their own proprietary standard. We should actually ask them that they open up their charging stations. You keep your proprietary, but keep it interoperable, that the same infrastructure could be utilized with just a different head and some software tweaks to fast charge others. So these issues of standards are actually a commercial fight. They're not just a technological fight that is one standard superior to another. We have to resolve such sort of issues. So, of course, when people ask, why don't we have more EVs in India? The common answer is, oh, I need more charging infra. But the reality is, a good chunk of users will charge overnight, and they'll charge at home or in a dedicated charging place like a depot, like a bus depot. Because in the middle of the day, they're going to be mobile. I posit that one of the big bottlenecks is there's a lack of cost viable models available for the consumer. There is a premium, and that premium is still high enough. And what we're trying to do is plug that gap through support mechanisms. You could actually call it subsidies. So you have waivers of registration charges, you have lower GST rate. These are all great to give impetus to a fledgling or nascent domain. But you have to ask yourself, am I subsidizing the rich? That's not good public policy. Will we end up just importing? If not the vehicles, then the battery packs. That's something the government is trying to address. And then you've also got the carbon implication. I talked about this granularity and time of day. If you charge overnight, then electric vehicles in not just today, but the visible short term, they will have higher carbon emissions than a good, efficient, especially hybrid electric internal combustion engine. Because at night, your solar output is zero. There are also fiscal implications that we have to figure out to really get this space kick-started. Today, state budgets are solvent often due to two liquids. One goes in your petrol tank, one sort of can go somewhere else. And if you now get rid of petrol and diesel, or at least a large chunk of it, what happens? Are you attempting to say that I will tax electricity? We have the contrast today where electric vehicles are given discounted or at least relatively discounted, in some cases absolute discount from the true cost of electricity to the utility. It is sold at a lower rate. Why don't we have more smart, sustainable solutions? This is an ecosystem problem. The government, unfortunately, in the past had looked like this, like a procurement problem. So why don't I just aggregate demand like we did very successfully with LED light bulbs? That was a great solution, but that was also a manufacturing, a supply side improvement where the costs of LED fell. Now, obviously, standardization of bidding documents, bulk procurement are great. They're necessary, but not sufficient. At an ecosystem level, if you think EVs, if you think smart meters, that's much, much harder. Association of Home Appliance Manufacturers, AHAM, has a very nice white paper on what it would take to have smart meters integrate well. The first thing they pointed out is they should be easy, interoperable, relatively plug and play. Now, plug and play is for the consumer. For the utility, they still have to integrate this into their billing systems, into their asset systems, databases, GIS-based systems. That takes effort. It's not that you can just swap out a meter and put in a smart meter and you're done. Now, one of the bottlenecks on the utility side has been communications. How do you talk to meters? It's not so easy to say I'll just use IoT, one of those buzzwords. Such infra is not scaled yet, and it is not available, contrary to popular belief, for the wide area network. For a consumer, though, it should be interoperable. It shouldn't be that to get a smart AC or a smart fridge, a Samsung, just to pick an example, I need a Samsung brand meter or home gateway. Second thing consumers need is incentive. So let's assume I've got smart appliances and there is a grid congestion. So therefore, I want to shift my peak load to an off-peak period. That's efficiency. But do I have an incentive? Am I getting paid to do that? I could get paid through differential pricing, time of day pricing, or I could get paid through specialized payments under demand response, where now you treat loss of demand equivalent to adding supply. That's like a virtual power plant. That's not there yet. And the third thing we need is really consumer choice and control. I don't want the utility or the government to tell me, please take a bath at this time because that's best for the system. I would like hot water when I want it or need it. I want control, security, privacy, and that has to be baked into the design of our systems. Security is a huge challenge as we embed smarts. So think about why security is difficult, privacy being a subset of that. If we talk about sensors, these are lightweight devices where power, electricity is a challenge. These are cases where embedded software has to run. How do we update them so easily? How do we patch them? How do we manage them so easily? Those are enormous challenges for a lot of the hardware that's starting to be deployed across this space. People have said, data is the new oil. I really hate that phrase. Data should be a byproduct, not our objective function. Everyone wants to be the next Facebook. Oh, sorry, no, not Facebook, the next Meta, the next Alphabet. Well, not everything can or should be that way. It's a completely separate discussion how we should regulate our platforms. I keep coming back to this adage that IT taught me: cheaper, faster, better. Pick any two. We obviously want things cheaper. We want them to be faster or higher scale. But we also want things to be more sustainable, more robust, more choices, more secure, more jobs, and we can have trade-offs between these. So smart isn't just taking the old system and making analog into digital. These are ecosystems. And we should take lessons from a lot of e-governance programs where it's not just about increased velocity, increased volume, speed, but transformations across who are the stakeholders, what are their incentives, and how do they interact. So rooftop solar should actually lead to more backflow from the edge instead of just large centralized power plants. Electric vehicles can actually become vehicle to grid, V to G, so that now you've got a semi-free battery. Well, it's free in terms of incremental cost because it's already sitting there. But the challenge is, why should I as an end user take up one more cycle of charge discharge, which and that would lower my lifespan of the battery? And in some cases, if you do certain uses out of a battery, you may void your warranty. So how much of that is technical? How much of that is commercial marketing speak? These have to be figured out. A smart grid, as an example, leads us to efficiency. I talked about shifting demand, but it's much more. Theft reduction is an obvious low-hanging fruit that people talk about in a smart world. We get new choices, new suppliers, new technologies, green energy. I can now get green energy as my electricity if I'm especially willing to pay that premium today. It should be more resilient and robust. And it's very premature to think of what's possible. Traffic lights, when they went to LED, today LEDs are a no-brainer for new traffic lights. But when technology was maturing, people said, well, it's too expensive to throw away my LED bulb, my regular bulb in the traffic light and put in an LED. That retrofit cost is expensive. Until people figured out, for example, in New York, where they said, oh, if it's an LED, the power consumption is so low that I can actually now put a battery on these traffic lights and now not run them, not just when you have a power outage. New York didn't think about load shedding and power outages so much, but during emergencies, I could still have traffic lights on a cycle or even intercommunicating with a battery, which was impossible to do in a traditional non-LED sort of a system. The general computing mantra that a lot of systems deal with is sense, think, act. Sensing is relatively easy. What do I do with that information is a lot harder, and a lot of that may need to be at the cloud level or at the network level, because these devices, A, may not be smart enough at the edge, and B, you need network visibility. It's not just about what I do, but what the system needs. How do you detect theft in smart meters if that theft is occurring before your meter? It's not that after the meter you're going to do a shunt or do some sort of tricks. It could be elsewhere. So if we use just the straw man of a smart geyser, I really need a time of day incentive to have my geyser turn on in advance before the morning peak kicks in at a grid level. But it's more than just TOD pricing. I also would want some things that are easy to install, high efficiency and lifespan. A lot of India deals with borewell water, which is hard water. How do I handle that so that the lifespan is there? Should I think about rooftop solar thermal, not just photovoltaic and PV? People are always going towards sexier solutions, sometimes more traditional plumbing equivalent, just nuts and bolts solutions are what we really need. That doesn't mean IT doesn't have a role. It can really help with systems planning, integration, measurements of improvement, but you don't need cutting edge, bleeding edge. for all problems that we face as a society. The old system was about saving energy, efficiency. In the new system, I want to save energy at the right time and at the right place. Uh, Minister had years ago talked about needing a 999 rupee smart meter. We'll get there. But I think we as a community of solutions providers, of consumers like utilities, need to think about value proposition. I am not a fan of this L1 as it's called in government bids, lowest cost. Remember, there's a trade-off. What we need to focus on is value proposition. A 999 rupee meter is too expensive if it doesn't give you value for 999 rupee. And a 2000 or 3000 rupee is cheap if it gives you sufficient value proposition. We need to start doing cost benefit analysis instead of just return on investment, which means societal. Some of those benefits could be to the end user and not the person who paid for the smart meter, the utility. So for example, could I avoid load shedding? This would get rid of diesel generators, cut down pollution. It would cut down the cost the end user has to pay for a battery and an inverter. We will need to commoditize a lot of the solutions. Think about Wi-Fi. Some of my colleagues were involved with its journey. And I remember them bringing prototypes that were big and they were capable of 2 Mbps and it was $1,000. Then we settled on 802.11 IEEE. It came into a 2 Mbps system, still $150, $259, I remember, at a starting point. Today, it's inbuilt into your mobile phone. You don't pay extra to get Wi-Fi, it's just part of the chips. And these are now capable of 100 plus Mbps, if not much more with new ones. So then if it's so cheap and it's a commodity, why will people produce such solutions? Where's the money? It's value added services that keep driving it. So the commodity is just an enabler for the whole host of other things we can do. In Wi-Fi's example, it's still relatively limited, but they're enterprise solutions where you add security, access control, seamless roaming, telephony. There's so many other things that people need and are willing to pay for. But in the smart solution space, from vehicular to smart homes, smart meters, etc., there's a huge range of value added proposition where we should be focusing on. That, of course, means we have to start with the metering side. Unfortunately, and this is my plea to technology providers, this stuff is complex. We have to simplify it. Its use, its integration into existing systems, its maintenance, and really asking ourselves, what is the problem that we are solving with it? I mean, I think almost all of us here in the room end up being help desk for our family when their Wi-Fi isn't working or when they're having trouble technologically. Cars are the gold standard. They're really complex beasts, but you just turn it on and drive. Now, of course, maybe when we have some of these smart cars, semi-autonomous, we're not quite at autonomous yet, they'll turn complex again. But they don't work that way. This is one of the reasons Apple has a premium and respect, is they really get the UI right so that ease of use is easy. Now, it's a different story on wall gardens and not, let's not go down that discussion. But complexity is a challenge we need to solve. And what are we using our technology for? How is it designed? If you have a hammer in your hand, everything starts to look like a nail. Technology doesn't operate in a vacuum. Silicon Valley's got this sort of mantra. Well, we can solve all these problems if only the government would get out of the damn way. Instead, can we synergize the policies, the regulations, the incentive structures so technology can really work together with the government instead of trying to bypass the government? What's holding us back? I've hinted at some of these things. We've got uncertainty, technology-wise, regulatory-wise. People had challenges in BS4 to BS6 for cars. Now there's uncertainty for manufacturers that what equipment do I need to build? There's a lot of jobs at stake if we're going to sunset internal combustions and systems. Technology changes rapidly. One of the phrases that I really like is plans are useless planning is priceless. Everything's going to change. We need to be ready for that. We need smart pricing, smart regulation. We need to move away from L1. Consumers are price sensitive, but I posit they are willing to pay for things that are better. Some may even pay a true premium, or they're paying for it elsewhere through healthcare costs, pollution costs, quality costs, equipment burnout, etc. We do have a challenge. How do we cross this chasm between price and volume? Maybe people talk about that I need standards. Yes, standards are important. They're not the solution. People have said, I want ISO. I want an ISO solution, the CMM solution. Well, I always remember, one of my former RAs had taken this picture. ISO 9001 certified astrologer. Yes, these exist. So in conclusion, if we talk about the future, if fear and greed are the only things that drive change, well, maybe we need to tap into them, or maybe we can get people to do it out of doing the right thing. We have global challenges. Smart is means to an end. It's not the biggest problem, but it's got a seat at the table. Every challenge is an opportunity. If you can solve sustainability, it will be with tech. You're going to be probably a centibillionaire or $1 trillion enterprise. India has a huge opportunity to do exports. And what we really need is not just a new product, a new solution. We need a solution end to end. We need new services and integrated. It's not just that I need a cheap widget or a cheap meter. We need to enhance what the things do. And I am amazed that the Apple Watch is now being regulated in some domains as a healthcare product. It's not just a hardware widget. We should start small, scale it up. We have to evolve, iterate, disrupt. And every time someone says, oh, this stuff is a niche, I'm reminded that a niche in India is bigger than countries in Europe. Thank you.
Thanks a lot, Rahul. Thank you for bringing the issues that are hardly discussed. Because, as you said, it's all driven from the economics, driven from the okay, I have a hammer, now let's start finding nails. And whether I need to nail it or not, it's immaterial. And that is where we need to start to think that what is really required and how can we really make the world sustainable? Because the consumerism is what is driving, what has brought us here. And that is what is continuing to drive. So how can we go back and how can we really achieve the goals that we have target for? You're saying something. Go ahead.
No, so I think the way to solve this is going to be multi-stakeholder communities. Technologists alone can't do it. Neither can end user or government. We have to sit together to figure out problem statements, objectives. We have to align on the objective. If my objective is to become a unicorn, that's a very different objective function than what society necessarily needs. Ideally, they should be together.
I agree. Any other questions from the audience? By the way, if you have any questions, keep typing in your chat.
Would someone read them to me, or is the chat
Yeah.
supposed to be visible to me?
I'm just looking at it. There is
Sure.
So far nothing much. You said that the one question that we worked out. You specifically pointed out the Silicon Valley government get out of my way. But isn't that also the situation everywhere else?
I mean, so that mantra was the Silicon Valley mantra in some ways. And it's not geographically limited to Silicon Valley. So in India, you've got the flip side. You've actually got not just a tendency of overregulation because the government is the patron, but it's also that in India, the government has a much larger role. The level of markets, the level of private sector participation is a lot lower. Think of electricity. Delhi, Mumbai, Kolkata, and a few pockets, now Odisha, are private sector government electricity supply, discoms, distribution companies. The rest are all government companies. They're corporatized, but they're still very similar to the erstwhile state electricity boards or SEBs. So you have to engage with the government even more in India than you do in other places, whether it's buses, road transport, whether it's, I mean, obvious water is still more governmental in much of the world, but you also have private sector. I think this debate over is electricity a public good or is it a commodity to let markets run is misleading. It's actually a bit of both. We need to regulate it as a public utility, which means figure out how you want to set up the incentives, how you want to price it, and how you want to maintain its quality. We get too bogged down in false dichotomies or red herrings.
Agreed. Agreed. Thanks a lot. Thank you for your insights. And if there are no more questions, we will move to the next session.
Thank you, and I'm looking forward to hearing much more on the solutions and what we're going to do.
Definitely. It will be great
Thank you
to
so
see
much.
that. Thanks a lot.
Thank you so
Thank you.
much
Thank
for
you,
the
Rahul, for
amazing
your.
session, sir.
Here is our virtual, you know, virtual thank you note and plaque. And really thank a lot for sparing some time with us. And we look forward to working with you in future as well. Thanks.
Thank you so much, sir.
Over to you, Chengappa. Let's go to the next speaker.
Our next speaker is Dr. John Hall. John Hall is embarking on his second career as a professor of mechanical and aerospace engineering. His research focuses on design techniques and the development of complex computer simulation models. He is the principal investigator in the Energy Systems Laboratory, where they develop technology related to energy production, storage, and consumption. He has practiced engineering professionally for 20 years before obtaining his graduate degrees. John Hall is assistant professor at University of Buffalo. He has academic experience at University of Texas at Austin and industrial experience as professional engineer. A warm welcome to you, sir. Over to you.
Thank you for the very nice introduction, Dikshita. And thank you for inviting me, Dr. Doss. Can everybody hear me okay?
Yes, yes, John. Good to see you.
Great, great. Okay, so yeah, I'm very glad to be here. And anyway, so today what I'm going to talk about is I'm going to first share my screen. I'm having a little bit of trouble reaching the share button. For some reason, it's off my screen and I can't get to it. Okay, there we go. Can everybody see my screen now? Okay.
Your screen is visible.
All right. So today I'm going to talk about some of the work that my research group at the University of Buffalo has been doing with adaptive wind turbine blades. And so I have a research group at the University of Buffalo. And so my work has been involved with renewable energy. I did some work with drivetrain simulation, and really a lot of the stuff that we found out was, all of the, problems, objectives for wind turbine design really can be impacted very much by the blades. And so this really, made my research group focus on the blades, specifically the design, and we began looking into morphing blades. So just in general, in the U.S., especially with this new administration, there's a lot of motivation right now and a lot of push to, for wind energy. There's, like a lot of other places, there's record growth here. I'm in the state of New York. New York is very supportive of wind energy, and we're seeing a lot of growth in this state as well. There's plans for offshore wind. The Biden administration's, announcing that. It's also people here are motivated for it because it creates a lot of jobs. There's also a lot of interest because of climate change. There's concern over that. But one of the things, interestingly enough, is this growth. There's because of it, it's actually challenging. Like a new type of blade design that's needed. A lot of the companies in the U.S. They get something called the production tax credit, and so right now, a lot of the industry realizes, there's going to be a need for a new blade, but they're really trying right now just to produce wind turbines and get them out there as quickly as they can before these incentives go away. And so we look at where the growth is. The total capacity as of the end of 2020 is 743 gigawatt. And in 2020 alone, that increased by 93 gigawatt. And so this is an example of what I'm talking about the growth is just increasing at a very high rate. If you look at how much is being removed in 1 year, where we're at now is the equivalent to the carbon production of South America. So, that's just one country. We really have a long ways to go. And you can see below here, I've also got some information about, where the, what countries are contributing the most to the added growth, which are U.S. and China. China's, way ahead of the United States, much higher, 3 times the growth that we have. And you see other countries where they're contributing right now. India's at 1.2%. And this is just really expected, though, to continue to grow in the coming years. Now, the other thing that's also growing is the systems themselves. One of the things that we've seen is here in the U.S., we're now, getting clearance, to put wind turbines at, 800 feet high. And we're actually starting to get now, like when it gets into airspace issues, and this growth is just expected to continue. Well, that also creates a need for a new type of blade design. The current design that they have, they've literally just scaled it up. And so what you can see over here in this red area, it's showing where we're going to start running into trouble. It's anticipated, if you go with these large, monolithic designs that they currently have, there's going to be a lot of wear and tear and, a lot of loading on the system. There's already a lot of problems with wear and tear on pitch motors. And so something's going to have to change in spite of, all the breaks that are, being realized right now. So in spite of this change, that we're seeing right now, it's still not enough. What's needed to actually meet our goal for climate change is right now, I just mentioned we're at 93 gigawatts, and that was last year. In order for us to meet our goals for climate change, that has to increase to 180 gigawatts, and that's every year. And then whenever we get up to 2030, it has to increase to 2080 so that we can beat net zero by 2050. And so the challenge is as we introduce more and more wind, which we need to do, wind is not like coal burning power plants. Coal burning power plants, we can turn those on whenever we need them. With wind, we can't do that. So it needs to be reliable. We need to be able to predict it. And what I mean by reliable is the systems need to be reliable. One of the things that we can do is we can build up, our fleet of wind energy systems, and we can basically, dispatch, wind where it's available as needed. But if the reliability gets in the way, which has been a problem in the past, that's another issue. And it's particularly an issue as we go to offshore wind, because those are hard to get to work on. So one of the issues that the current blades have is there's an inherent trade-off between reducing loads and energy production. So in other words, if you want to produce more energy, you're inherently going to create more loading on the system. Well, the reason for that is the blades that we currently have, they're optimized for like a narrow band of wind speed. And that's, maybe around the rated speed or just below it. And so what we're proposing is a blade that actually morphs. And the type of morphing that we're talking about, I'll show it in the next slide. It's the twist, which varies the angle of attack. And so by doing that, we're actually going to be able to increase the amount of energy that's produced. We're going to have more stable systems. That's really going to be important as we go to offshore and even floating wind turbines. We're going to be able to reduce loads. And also this problem that we're having with larger blades, we're going to be able to support, having larger blades and larger systems that are needed. And again, that's very important just due to the cost of, getting that levelized cost of energy down. This is the concept that we've been developing. And if you look at the picture on the right, what you can see is the blade, it actually twists. And so if you can imagine an axis that it twists about, extending from the hub to the tip of the blade, and then twisting about that, that's the type of morphing that we're dealing with in this problem. And so to get to that, we have to look at like an aerodynamic approach to understand the blade profile. We have to understand like how the blade might be manufactured, what's going to happen with those materials, and then how we're going to control this. And so this is, a pretty large project that we're undertaking. And we do have collaborators that we're working with on, materials and some of the control issues as well. What we've been doing in our lab is we've been looking at the aerodynamic design and how we might take that design and make it into something that's manufacturable. And then given that, is it feasible, to build this? Can we control it? So these are the sort of issues that are being looked at right now. And these basically come together in this embodiment that you can see. Our concept for this is to have something rigid in the blade, and we have a spar, and that goes through the center of the blade. And that would also enclose the axis where the twist occurs. And so what we can see is if we look at the bottom left image, we see how that's defined in terms of an axis system. And so what we've done is we've defined through our work a new parameter, and that's the twist angle distribution, and that's denoted in the bottom right in red. And what that distribution represents is it represents the angle of twist of the blade, the local angle of twist of the blade at the distance r as it moves out. And so basically it creates a vector of points, and by varying that vector of points, that's how we represent the varied twist angle distribution. So there's two different types of control that we're dealing with in this. Basically, the blade, whenever it's, whenever you don't have enough power to operate the wind turbine at full power, the goal is going to be to try and capture as much wind as possible. Wind turbines, whenever they actually reach a certain wind speed, they max out on the power that they can produce. And so at that point, the objective of the controller is to dissipate some of the power and to basically hold it at full power as well as it can. With the blade that we have, whenever you get into that higher wind region, you're going to have higher loads. And within that region, the active blade, what it can do is actually mitigate loads there. Now, we've found in our work that we're able in this full load region to reduce the loads by up to 72%, which is very significant. And what that means is in reducing those loads, we're also going to reduce the cost of the structure that's needed to support that. We also improve the stability, and that's more of a reduction in structural cost. And also we're going to improve the stability of the system mechanically, and in doing so, there are some benefits, that do convey through the power generation to the electrical stability as well. So our simulation framework to study this, we use this for both the design and the control problem that we're dealing with. And basically, it's split up into 3 different areas: aerodynamic design, and this is pretty much like the development plan, the mechanical design, and the control. And so these are our simulation modules that we're using for development. And so we use these for a couple of reasons. One is to prove our concept. We use these for some case studies that we're working on. And then the other one is basically to put some tools out there so that anybody who's interested in this work, so that they can pick up on those and engage in studies with us. So the aerodynamic design, what we're basically doing is we take the blade and we look at the different, we run through a discrete set of wind speed. So the wind speed that we look at in this particular problem is we're trying to maximize efficiency. And what we do there is we look at the range of wind speed where we want to maximize efficiency, which is below the rated speed. So on that point, we don't have enough power in the wind to produce full power. So we do everything we can with our controller to try and maximize the wind capture and the energy that's produced. And so the way that we work through this problem is we have an aerodynamic model of the blade, and what it gives us is it gives us the torque and it gives us the thrust loads. And we can vary the shape of that blade, the twist geometry that I was talking about. And what we look at is we try to find, the right TAD or shape, the right blade shape that's going to give us the highest amount of torque in relation to the thrust. So we want to try and maximize our power coefficient whenever we're in region 2. And then whenever we're in region 3, we also start to look at other issues like the thrust coefficient as well. And that was where we got our 72% from. And what we do for each one of these wind speeds is we go through, we look at different wind shape, we look at different twist configurations. It's a very highly computationally expensive problem. And we use a genetic algorithm that's coupled with our aerodynamic model, and it helps us find those shapes. Some of the work that we need to do on this is real-time modeling. This is how the blade is constructed. Basically, it has each one of these sections that you can see marked by an S. It has a different stiffness, and there's also blue zones on there. And what those are actuator locations. And through the combination of actuator locations and stiffness, we are able to create a family of shapes for all of the wind speed in region 2. So, for example, we would be varying the wind speed from, say, like 5 meters per second to around 13 meters per second. And in there, we're going to have a wide variety of shapes, and we're going to have to be able to have a design that can create the shape at each one of those speeds. So this problem is a little bit more complicated than some of the shape shifting problems, in that it just doesn't create 2 shapes at 2 endpoints. What it does is it creates a family of shapes. And so therein lies a lot of the issues for the computational efficiency. One of the things that we do at the end is once we have the shapes that we need, we want to find so basically this is an elastic structure, right? And so what we want to do at the end is, like a spring, is we want to find where it would be at its rest position. So we have different criteria that we could use for that. And, some of the criteria that we would use is like which shape minimizes the amount of energy that's used. Because one thing that does occur is whenever we actually run the actuators, we do consume some of the energy that we're capturing. We want to minimize that. Now, we have done some studies on that, and it is a small amount, and it appears to be justifiable in most cases. Whenever we do our free shape selection, what we do is the example I just gave. We're going to go through, we're going to look at different wind profiles where a system might be installed, and based on that, like a higher wind speed area, like maybe up in the mountains, versus something where you have lower wind speed, the twist where it would be at its rest position would be different from that in the for that at the low wind speed location. So we imagine, you know, there could be like 2 or 3 different types of, you know, different configurations that could be used for this. So some of the assumptions that we use for this is we go into this with an assumed design. For the study that we used here, it was the S809 model that's been used in a lot of the NREL National Renewable Energy Laboratory studies. We also assume that there's no actuation energy used whenever the system's, you know, not being changed. And we also looked at a semi-static process for our study. Generally, we have 4 control modes for this. We're only interested in region 2 and 3 that I spoke of earlier. And for our operation, what we did was we use a lookup table to tell the controller what shape the blade needs to be in. So right now, it's really pretty much open loop in the model that we used. You know, provisions, you know, will be added for closed loop control. And this is the much larger control problem that we're driving towards. We do have a dynamic model also that we've looked at for this, and we're looking at some of the settling time after correction. So what these results are showing us is it's telling us whenever we did the energy problem, how much energy would be dissipated in the you know, during the transitions. And by working through this problem with a case study, we were able to look at how much increase in efficiency that we had obtained. And what you can see on this is the increases were generally best at cut in and also at cut out. I'm sorry, at cut in and also at rated speed. And we figured that the design was probably for the S809 is probably for a 9 meter per second wind speed. So some of the other things that we did with this is we looked at like 20 years, 20 different sites of wind turbine data that we got from NREL, and we looked at how much of an increase there would be based on those wind profiles. And we found anywhere from like up to about 2%, and this is for the S809. Now the S809 didn't give us some of the best results that we would have liked to have seen. It's actually a stall regulated blade. We've used that blade for our test because it's been very well validated in some of the other in a lot of the work, and we have good data for that. And what we basically come out with from our study is we're able to tell the actuator location and also the stiffness for each one of those. We're also able to tell, like I was talking about earlier, where the actuators, how much movement they should be, and this is the information that is given to the controller. And so ultimately, in this one, we end up choosing the blade free shape. It's at 9 meters per second, and that is based on that, which reduces the amount of energy released. So something that we've been working on more recently is the experimental validation of this work. And so we have a scaled down model that we used. We actually have a wind tunnel where we tested this. And so our model that we're showing here, it's able to measure both torque and thrust, and we can vary the wind speed. And so we've run some wind tunnel tests. We've actually been doing that this month, and we do have some results for that. And the way that we do this is we can't actually on the model, you know, have a morphine blade. So we have different shapes at each wind speed. And by testing those different shapes, we're able to build a profile, basically looking at like what it would look like if it was morphine. So what we've done is we've been running t-tests, and we've been also parsing through the data. We've ran several different tests where we've looked at different you know, blade sizes, different speeds. And, we're basically putting profiles together of that right now. And there's a lot of post-processing with this, you know, especially it's very sensitive to like, you know, like any anomalies in the manufacturing process. And so we've had to go back and look at some of our blades and, take very close measurements. And so basically though, through that, long term, we think probably, a good way to approach this is by collecting data using machine learning to create that profile that we need for the controller. So overall, what we found is we're getting about a 3.8 increase in efficiency for the region 2, and that's whenever we use BEM. CFD results are telling us 5.7%, and we've done our wind tunnel experiment, and it's saying 6, and actually 6.5. Some of the wind speeds we're getting up to. So what we've done with this so far is our modeling capabilities. We've been able to identify a family of morphing shapes, and from that we're actually able to make those by varying the stiffness and with our actuator placement and mechanical design. And then we've also come up with a control design that's based on the optimal pre-selection. So we do have further reading available. We've had 5 papers published on this topic. The papers cover everything from the validation of the BEM work to the controller to the aerodynamic design that we did. We've also looked at more work where we could reduce the number of actuators. So we're looking for anybody that's interested in learning and working with us. Please feel free to reach out and contact me, and love to talk more.
Great.
Thank you.
Great. Thank you so much, John, to dive deep, dive deep into the technology and explaining what the challenges are. So, the blade is one key component of the wind turbine, and is your problem primarily addressed towards, does it have any significant impact on the offshore wind turbine?
Absolutely.
Or it is for general wind turbine as well?
No, that's a good question,
Because
Ashok.
you have 5 to 7% efficiency.
So the efficiency is where we started at. And the reason we started with the efficiency is that's really the easiest problem to tackle. And it's really important. And if we can demonstrate something there, then that's what brings people on board to that. We've worked with the industry and they seem to, be embracing this idea, for some of the reasons that I talked about. But as far as offshore goes, yeah, it really does. So I didn't get so much into that. I think I really talked about efficiency, but just any time you can improve, the control capability like we're doing with this blade, I mean, it has so much, higher capability by being able to morph them we're dealing with now. What that's going to do is it's going to improve stability. And that's really an important issue, whenever we start talking about floating wind turbines in particular. So I think that before, you can really go to like these large, floating wind turbines in particular, and even just the larger ones because of the blade size.
And I do see that you have some good traction on commercializing it. Right?
Yes.
So what is the status of commercialization? When can we see that we can get this? Someone can go and buy this technology.
Yeah, I mean very exciting. I'll be looking forward to that too. So we've got a patent that we have filed, and that was a couple of years ago, and that's moving through very well. And we've also adding to the patent at this point. Our earlier work, we delved into the aerodynamic problem and how we might manufacture it. And now we're actually getting into some of the higher control work for that. And so that's something, software for that I think, would probably be of commercial interest. And, just in the whole process of doing this, funny enough, I feel like, we're developing, there's a real need for, like cyber physical system-based control. And you know, in learning about that, it almost seems like you could take what's there and actually, you know, use that to benefit the current technology, you know, to make improvements. So, I mean, these are some more immediate, you know, things that can be realized, you know, through this work. So it doesn't just have benefits for, you know, the longer term, you know, blade design, but I think it has some immediate benefits too.
Great, great. Thanks a lot, and thank you especially for coming and attending this, you know, just after your surgery.
Thanks.
And really appreciate it.
Yeah.
Would like to give our token of thanks to you.
Thanks.
And appreciate it. Thanks a lot.
Wonderful. All right. Thank you for having me.
Thank you so much.
And it's too late now, so perhaps you need to go to sleep.
I will soon. Yeah, thank you.
Thanks a lot.
Thank you so much, sir, for your amazing talk. Here we have a small token of appreciation for you. It was a really great talk, sir. Thank you.
Oh, I thank you. Thank you so kindly.
Yeah. So we'll go to the next speaker.
Yes, sir. So our next speaker is Yuvraj Sarda. Yuvraj Sarda is a business professional specializing in new business development, market research, strategy development, and execution. He is adept at exploring new business opportunities and understanding their potential using market research. He is highly skilled at analyzing the opportunities for financial and operational viability and converting them into business for organizations. A warm welcome to you, sir.
Thank you so much. It's a pleasure to
welcome you, Raj.
Thank you, Dr. Ashok. It's a pleasure to be here, and I'm happy to dive directly into the content of my talk.
Yes.
Sure. So basically, let me know if you all can see my screen. I'll be just taking you all through a simple document on sun mobility, an introduction to sun mobility, our thought process, our philosophy, and a bit about our technology, if that works. So good morning to everyone. I'm representing Sun Mobility. We are an energy platform, and the whole idea about Sun Mobility is how do we enable masses to adopt electric mobility without having to compromise on cost or range. Globally, electric mobility has been now a really hot topic, and several governments are coming up and pushing this agenda and trying to enable more and more people to adopt electric mobility. However, we believe that this this sector needs a lot of innovation and not just in technology but also in business model to really accelerate this transition from where we are today to where we want to be in terms of sustainable mobility. Sun Mobility's business model is an attempt to do the same. Just to give you a quick background about Sun Mobility, we've spent 30 years. The founders of the company have spent 30 years in developing electric vehicles. Right from 1990s, we're trying to develop solar car as part of the university project and doing a run across the country to all the way launching India's first electric car and launching the same in 24 countries in Europe, and then basically working with large OEMs trying to integrate electric mobility technology into their existing platform back in 2010 when not many were talking about electric vehicles. So here is basically generation or decades that are committed to basically having electric mobilities as mass scale. Just to give you a quick background about Sun Mobility, it's a joint venture between Sun Group and Maini Group. Sun Group brings in expertise from transportation, new energy front, aerospace, electronics, and Maini Group, on the other hand, is a diversified engineering company and brings in the knowledge of precise engineering and electric mobility through its experience from REVA. Coming specifically to Sun Mobility, as I mentioned, the whole idea about Sun Mobility is to solve the key issues of electric mobility today, which are really high cost, charging time, and range anxiety, and create a platform that is scalable across the globe, and which is open architecture, which works with the ecosystem players to really create a co-create solution that can be affordable at the same time accessible to masses. Broadly, so what we do as a company, basically we call it battery subscription or battery as a service, where we have swappable batteries, swapping stations, and offer them together as a service where users can buy the vehicles without batteries. And now we've recently added another layer of services on it, which is vehicle as a service, where you can not just have battery but also have vehicle together bundled as mobility as a service. And as a user, you don't have to worry about the technology risk of the vehicle, because all you are doing is paying as per use. And if you really feel that as a user that solution doesn't work for you, you can basically opt out of that subscription and uh, be, and kind of either look for an alternate or go back to ICE vehicles. And we built a host of technological solutions under Smart Network, which is a software system that allows us to manage the operations of these two services remotely, as well as offer enhanced customer experience to our customers through digitally connected solutions that we have. So that's what Sun Mobility does. And uh, trying to get deeper into the issues today that electric vehicles face, cost is definitely a high issue. Although government has tried, government has taken a great initiative to reduce this cost for the first few million vehicles by offering generous incentives. State government and central government have offered generous incentives. But when you look at India as a market where we are nearly selling 20 million vehicles, and where the incentives are for the first 1 million vehicle, the idea is, how do we create solution as every year when these vehicles are sold, they are still affordable, right? Range anxiety today continues to remain a problem, as energy density of batteries is not as good as energy density of fossil fuels. And you cannot package batteries that can give you the equivalent range that today your competing petrol diesel vehicles give. And similarly, the time it takes to charge, even with the fastest charger today, it takes anywhere between 60 to 90 minutes. In two-wheelers, it is 30 minutes, versus what you are used to as a user. You are used to a 5-minute refueling. And of course, the last challenge that we see in electric mobility today is lack of infrastructure. Although as a country, we are connected with electricity almost 99%, what we don't have are those really dispensing points that can offer electricity in the form that batteries need, and and they are discoverable through easy process. So these are the key challenges that really inhibit, and I'm really talking about masses. Imagine the person who would never care about electric vehicle, or who would never care about vehicle in its own life or part of his business. And if he or she has to make a decision on buying an electric vehicle, which is purely either based on functionality or based on economics, how do we motivate that person to really buy and adopt electric mobility? So we are addressing these challenges through an approach called battery swapping, which allows us to achieve cost parity between electric and IC vehicles by really reducing the battery and charging from the equation. If you remove these components from the upfront cost of the vehicle, you can really bring down the upfront cost. And when you really use smaller swappable batteries, allow them to swap more frequently, and make a very efficient use of battery as an expensive resource, you can really bring down the cost of energy to be lower than cost of fossil fuels. And thanks to the government, that fossil fuels on the other end are rising. For the last few years, we are seeing a steep rise in the cost of fossil fuels, which is making this equation even more sweeter for electric vehicles. And what the end result is, you are able to get affordable EVs, and you are able to refuel EVs in a better, faster, and cheaper manner. And that's when masses start to consider migration from a petrol or diesel based vehicle to an electric vehicle. And I'll give you an example of a typical bus. A conventional electric bus, with a typical range of 250 kilometers, requires an overnight charging, and it costs almost 2 to 3 times that of a conventional bus. At the same time, it has a reduced passenger capacity because it has to carry a 3,500 kilogram battery pack. Uh, so the answer to that is, if 90% of the city bus trips are less than 50 kilometer, why do you need a 250 kilometer range battery, right? Why can't you design a highly optimized battery that can give you enough juice to cover your trip length, but at the same time allows you to cover the daily distance of 200 to 50 kilometers? And that's where swappable batteries come into play, where, with the help of robotic swap and doing a 3-minute interchange and using a smaller swappable battery, you can really reuse the same battery multiple times a day and increase the efficiency of the vehicle, and at the same time achieve cost parity for the bus. So here is, I think, the concept which I told you is being explained in a more graphical manner, where using a smaller battery instead of a larger pack allows you to take more passengers in the same bus or make the bus more efficient or lighter. And what it means is, you are able, if you really look at from economics point of view, if you really use longer life batteries with 1/4 the size, you can get much better asset economics. These are all expensive assets, and eventually you need to find what is the fastest way to get return on investment to be able to deploy these solutions for masses. And when it comes to infrastructure, what Sun Mobility has done is really created frugal engineering based swapping stations, which cost 1/10 of a typical robotic swap station, which requires less power and far less space. That allows us as a company to set up infrastructure in complicated regions. Today in country, we don't have much space. We don't have, dedicated parking lots for buses. So forget about putting charging stations. And of course there are a lot of pilots happening. Of course there are, buses being deployed. But when you really look at scale, when you look at city like Bangalore, which has 7,000 buses, and if you want to really convert them and have 7,000 parking lots to charge each bus overnight, do we have sufficient infrastructure as a city? And that's where, some of these solutions make more sense when it comes to buses. Here is a bit more detail into what we really offer. The pieces of technology include swappable battery, a swapping station that allows us to swap the batteries really quickly, a plug and play kit that allows us to work with OEMs, integrate these batteries with OEMs, and everything powered by a software system called Smart Network, basically an IoT based system which runs on cloud and connects with batteries and stations in real time. And eventual idea is to power everything by renewables, because there's no good you're doing by using coal-fired electricity and running electric vehicles in the country. So the eventual idea is to see how do we transition from fossil fuel based electricity generation to renewable energy based electricity generation, and using that electricity to power transportation of tomorrow. Here is a quick video that explains how battery swapping works. A typical user can basically walk up to a swapping station, use an RFID card and basically swap the battery automatically. The drain battery which has been put really charges it by itself, and within few minutes, your electric vehicle is refueled and ready to go. So the whole idea is to try and mimic the user's existing behavior of going to a fuel station and getting vehicles refueled within few minutes. And if you try and do that with technology and use digitally connected mechanisms, you can make it really more convenient and self-serviceable without having to have even an operator to run these stations of tomorrow. The whole idea of swapping is more relevant in commercial vehicle segments like three-wheelers or delivery vehicles or bike taxis, where you really don't know where you're going next. You really don't know whether that place will have a charging station, whether you will have sufficient time to charge your vehicle. So all you need is asset availability and the flexibility to do as many kilometers as you wish, and the ability to refuel within few minutes. And that's where swapping makes a lot of sense. And that's where Sun Mobility's focus has been as a company, where we are purely focused on commercial applications of two-wheelers, three-wheelers, and buses. Here is a short video of how battery swapping works in a larger platform like a bus, where you use robotic arm. Even though we call it a smaller swappable battery, it is still weighing 650 kgs. But it is smaller in that context that it is smaller than a 3000 kilogram battery that will go into a regular electric bus. And when you really want an electric, when you want an AC bus, then you really need even more battery pack, even bigger battery pack in that bus. So this is where we are on the bus battery swapping station. Some technical details on how we've implemented battery swapping as a concept. We've created smaller swappable batteries which are connected, smart. We've built in some intelligence in it. We've architected it in such a way that they can be upgraded as the battery cell technologies evolve. There is connectivity built in, telematics built in that allows us to connect with us, and the most important part is that it is modular, that allows us to put 1, 2, 3 batteries and offer flexibility of range, and the same battery pack can cater to different types of vehicle platforms by using multiple modules. That's what makes it interoperable. In terms of swapping station, the whole idea is to offer a device which can offer high throughput, and petrol pumps today offer high throughput. If you look at petrol pumps, they can dispense uh, anywhere between 10 to 15 cars, or anywhere between 20 to 30 two-wheelers an hour. Whereas when you look at electric vehicle charging station, today they are able to deliver 3 cars a day or 4 cars a day. So that's where, with the kind of population density that we have in our country, you really need high throughput machines. And that's where swapping station is all about, that it takes 2 minutes for you to perform your transaction, while the batteries continue to charge when you are not using the station. And we've built in connectivity, we've made it compatible with multiple platforms. In Indian tropical climate, you really need temperature conditioning of batteries. Today batteries, you've heard about incidents, watched WhatsApp videos of batteries catching fire because they're not thermally managed properly. A lot of batteries also have, we've seen in the past, some of these vehicles have got a lower range in high temperature cities like Nagpur. So you really need temperature management of lithium ion batteries to get the best out of batteries, and also to ensure safety of users. And that's where these stations have thermal management systems. And eventually, if you really want to scale this up, they need to be very quickly they need to enable us to install them very quickly, which this is how we've designed it. This is the kit, basically a dock, a plug and play kit, which goes into the vehicle and allows multiple batteries to perform within the vehicle. And the whole idea is, how do we as a company work with more and more vehicle manufacturers, allow them to integrate our batteries without having to do much changes in their design. We do respect the design of multiple OEMs, the way they think about their own vehicle platforms, and that these plug and play kits allow them the flexibility to package the battery in different ways. These batteries can be packaged in the front of the vehicle, at the back of the vehicle, below the seat, in an inclined position, or a horizontal position, or even vertical position, depending on how much space they have and where do they have that space to ensure a proper center of gravity. This is a fourth piece of technology that does a lot of things. It connects to all our assets, battery stations. It connects with customers through app. It gives us a view of what's happening outside with all our network, all our station. And it allows us to do a host of things. It allows us to support fleet operators and give them data. They don't have to have their own telematics. The battery data can be leveraged by OEMs, by fleet companies, by energy management companies. Pricing can be made really dynamic and can be made into effect very quickly. Uh, there is a lot of data that gets collected through these batteries, and there can be a lot of analytics done to eventually optimize operations, enhance customer experience. And we've built in all these or architected all of these as part of our solution to the customer so that we can make it really scalable. And the most important thing is safety, where the first risk on any of these assets is first notified to us through the system because of connectivity technology. Here are some app interfaces, how the users get to see. User can actually understand how much charge is left in the battery, where is the nearest swapping station, how many batteries does it have, can I pre-book these batteries and ensure that when I go to the swap station, I get the swappable batteries that I need. What are the payment mechanism, what has been my transaction. Everything is extremely transparent, digital, so there is no confusion or no question on the integrity of the solution. As a company, we've implemented this solution. It's been operating. We have today 800 vehicles on the road. A lot of these vehicles go up to as high as 130 kilometers per day, which has given us tremendous experience of operating these vehicles. We've covered more than 6 million kilometers, and we believe this is a truly scalable solution in the Indian context, with the masses and the expectation of people, plus the use case scenarios and the robustness requirements that we have in India. And the same technology can be taken to global markets, especially the emerging countries which cannot afford expensive EVs and are really looking for these low-cost solutions and don't have government subsidies. On buses, we did a pilot, a 12-month pilot, covered 650,000 kilometers across a fleet of 18 buses, and have a lot of learnings. And we are now working on improving that solution to make it really globally scalable and truly interoperable across multiple bus and truck platforms. On two-wheelers, again, we did a lot of pilots and applications like food delivery, grocery delivery, scooter rental companies are the ones who've used our solution and believe that this could be very relevant for their operations. We have been working with them now on deploying these scooters at large scale in the batch of 50s and 100s, and starting with certain cities. In terms of partnerships, as a company, we believe that this whole solution needs to be implemented through partnerships, and we've partnered across the value chain. On the technology side, we have Bosch as our mentor, working with us on developing and enhancing our technology and taking it to the next level of their investment in us. We are using Microsoft Azure platform for our IoT, and we are working with leading battery cell manufacturers to leverage their cell technology. In terms of OEMs, we have OEM partnerships in the likes of Piaggio, Ashok Leyland, and we are working with a host of startups who are looking to leverage swapping technology for their vehicle platforms. In terms of customers, we've tied up with a lot of fleet operators like Zip, Zingo, Uber, Smarty, who are keen to deploy electric vehicles at scale and, especially in commercial applications. And in terms of the distribution network, we've partnered with Indian Oil, which is one of the largest fuel company in the country, and they have the widest network of petrol pumps. The idea is to leverage their petrol pumps, set up infrastructure, swapping infrastructure at those petrol pumps, which makes access to this technology as convenient as it is for refueling today, with Indian Oil petrol pumps being there everywhere around the vicinity of people who are looking for refueling. And beyond Indian Oil, we are looking to partner with energy companies, discoms, who are also very keen to support private charging and swapping players by offering them their electricity infrastructure. So, as a company, I think I've talked about these partnerships. We've had really strategic level integration with these guys, and have got their leadership buy-in. so that these partnerships are scaled up to the level that they really are meant to be. Here is the last slide from my end, which just talks about that not just in India, but we as a company have been recognized by some of the global institutes, and been recognized in some of the global competition, competed against the best of the world. You know, this was in Saudi Arabia, in Singapore, in Monaco, and we've been recognized at that scale based on the technology that we've demonstrated and the actual usage that we've demonstrated here in India. So that's pretty much it from my end. I am open to any questions or any discussions from here. Thank you.
Thanks a lot, Vijay. It's a great perspective on the entire ecosystem of electric vehicles. So knowing Chetan and knowing all his vision, I know it has come out quite well, and I know it is going to go a long way. So, Yuvraj, if just to clarify the concept, your focus is primarily on the battery side and the charging station side, not on the vehicle side.
That's right.
So you work with the vehicle manufacturers to adapt to their design, or you help them design their vehicle as well?
So we basically focus on integrating. We do not really interfere into their design aspects. We are open to collaborate and give them any of our guidance on the design of their vehicle. But the idea is that we have certain battery, it has certain dimension, it requires certain physical space, and we help them to integrate these batteries as part of their design without them having to compromise on their design or consumer aesthetic aspects.
Okay. Now, who pays you?
So for us, I'll give you a very simple example here. Imagine an auto rickshaw driver deciding to go electric. So he has a choice. He goes to a Piaggio showroom. Either he can buy a 2 lakh rupee worth of auto rickshaw, which is running on petrol, diesel, or CNG, or he has a choice to buy a electric auto with a fixed battery, which will cost him 3.5 lakh rupees, and after subsidy around 3 lakh rupees. And then he gets operational saving, but he has to ensure he maintains batteries and he replaces batteries after 3 years, which is going to be a big cost. To the same user, there is an option that he goes to the same Piaggio showroom and buys a vehicle without batteries and opts for a battery subscription service from Sun Mobility, where every time the person swaps, he pays us only for the swap. So there are these auto rickshaw drivers who just buy the vehicles without battery from Piaggio, and they pay us on a everyday basis. Every day their job is to recharge their card and use that RFID card to swap our stations. It's a prepaid card. And every time they really want swappable battery service, they just recharge their card. We've also offered this service to corporates. There are a lot of fleet operators who buy a lot of 100 vehicles and use these vehicles for employee transportation or for goods transportation. And we offer them, a monthly service where across their fleet, they can use our battery swapping network. At the end of the month, we'll send them a bill. And for all the batteries used, all the energy used, they are paying us on a monthly basis. And they don't have to buy these batteries. They don't have to invest in infrastructure. All of that is managed. And for them, it's just a service that they are taking. In very simple terms, it's a refueling service for their electric vehicles. And with our additional offer of mobility as a service, they can take a complete package where they, for example, they'll pay 15,000 rupees and they get vehicle for 1 month, which is a 3-wheeler goods carrying vehicle, and they get unlimited swaps for 2000 kilometers. So for them, it's like without having to invest in an electric vehicle, which is expensive or which is risky in terms of technology, they just take everything as a service from us. So for us, the users are these individual drivers of auto rickshaws or the delivery boys or the bike rental companies or even the e-commerce fleet operators.
Oh, correct. Great. So and that is where your interoperability becomes very important, right? That
That's right.
how do you interface with all these kinds of batteries, vehicles?
Absolutely. So the idea is to have common infrastructure. In India, you cannot have different types of charging stations for different types of vehicles. You cannot really have it at scale. So when you are having, a city typically has 1 million, 2 million vehicles. If you really want to create energy infrastructure for these many vehicles, you really need to have some commonality. And that's where these swapping stations can cater to two-wheelers and three-wheelers together. And, even up to a micro truck like a Tata Ace. So all these kind of vehicles, in two-wheeler, you put one battery. In an e-rickshaw, you put two batteries. In an auto rickshaw, you put three batteries. The batteries are the same. They can be swapped at the same swap station. So you go to the same swap station, you swap one battery for a two-wheeler. Next time the auto rickshaw comes, he gets three batteries, and one of the battery could be the same battery that the two-wheeler guy has exchanged. So that way, using the same batteries, same standard modular batteries across the fleet of vehicles, not just the vehicle categories, but also with different OEMs, offers you a lot more flexibility and allows you to reach economies of scale much faster.
Agreed. Thanks a lot for your insights and a stimulating talk. Uh, Manisha, back to you.
Thank you so
Hello.
much.
Yeah,
Thank you
go
so
ahead.
much, sir. We have a small token of appreciation for you. Thank you for the
Thank
wonderful
you.
talk, sir.
Thank you. It's been a pleasure being here. Thank you so much.
Sir.
Thanks. So we'll move on to the next session, panel discussion.
Yes, sir. Moving on to the next segment, now we have a panel discussion on sustainable transportation strategies for India. Our first panelist is Aishwarya Raman. Aishwarya Raman is keen at observing, diagnosing, and advancing the interplay between technology and society. She has co-founded one of the South India's earliest and largest book and auto services, Auto Raja. Aishwarya Raman has conducted Tamil Nadu's first empirical study on the lives of auto rickshaw drivers with an emphasis on the economics of operating auto rickshaws. She mentors startups and conducts workshops on entrepreneurship. She also contributes to strengthening governance. A warm welcome to you, ma'am. Our next, our next panelist is Pavan Mulukutla. He is the Director of Clean Mobility and Energy Tech at WRI India, responsible for shaping WRI India's clean mobility program. He is in charge of the overall strategy and its implementation, partnerships, and engagement. He is leading a team of researchers and technical experts at WRI India on supporting government at both national and state level. Pawan's area of focus includes EV industrial evolution, hydrogen value chain, India's pathway to hydrogen economy, value chain system and skill development, energy storage, charging infrastructure planning framework, vehicle to grid integration, and EV asset financing. Pawan has 20 years of experience in city mobility working with various stakeholders. A warm welcome to you, sir. Our next panelist is Dr. Sudeen Rakowshik. Dr. Sudeen Rakowshik is a senior member of IEEE. He is a certified independent director and is a part of Exicom IEEE Bangalore. He is working as a director of internal and external innovation for OLU Group. He has been working with universities, startups, entrepreneurs, innovators, and smart tech. He has also given his TEDx talk on innovation. Dr. Sudeen Rakowshik has 24 years of international experience in product innovation and development. He has 20 plus patents in various stages. He has been awarded the Karnataka State Innovation Council Award for his phenomenal works. A warm welcome to you, sir. Our next panelist is Dr. Bharat B. Kale. Dr. Bharat is associated with the Center of Materials for Electronics Technology, Ministry of Information and Technology as a director and DG, head of nanocrystalline materials. He has obtained PhD from National Chemical Laboratory, Pune, postdoctoral at the University of Leeds, United Kingdom, and Brainpool scientist from Korean Research Institute of Chemical Technology, South Korea. He is a life member of the Material Research Society of India, is also the treasurer of MRSI Pune chapter. He is a fellow of Maharashtra Academy of Science and was nominated for Shanti Swarup Bhatnagar Award for the year 2008 and 9 and MRSI Gold Medal Award in 2010. A warm welcome to you, sir. Next, Ravikiran Annaswamy is going to be the moderator for today's session. So Ravikiran Annaswamy is the co-founder and CEO of Numocity Technologies. He's very passionate about clean mobility and is working towards accelerating electric mobility in India and world market. Strategy is on using IoT analytics and deep learning to accelerate adoption of electrical vehicles and innovate to new business models of energy as a service. He has over 25 years of experience as an entrepreneur and as a business leader at Nokia Siemens Networks and Siemens AG. He is on the global leadership team of IEEE 5G and contributes to the vision and strategy of future applications and services. He also has a great passion for photography and is a bibliophile. A warm welcome to you, sir. Over to you, sir.
Thank you, Diksha. Welcome to everybody. Wonderful to see all of you early in the morning, and also welcome to all the panelists. Welcome to Aishwarya, Pawan, Dr. Kale, Sudindra, everyone, and everybody also who's in the session today. I'm quite sure in the last couple of months, I would say 6 months, there is a lot of buzz thanks to Aishwarya and her company Ola and many other companies who are making a lot of buzz around electric mobility. So we all have got a kind of a fancy to what clean mobility is all about. In a common man, I'm talking about. Not in the industry, we've been talking about it for quite some time, but I've been in this space nearly for 5 years, and wherever now I go and talk to anyone, they're asking me, okay, what is happening in electric mobility? And they feel that I'm going to change something, which is not the case. Even 6 months back, nobody asked me what I'm doing, but now everybody is interested in what I'm doing, and they ask me what I'm doing. So that's a wonderful thing to know. It also can be a bubble, so we just have to be careful not to overstretch it. But at the same time, it is a topic which we all need to talk, discuss, and plan for future, because when we are talking about sustainable transportation, it's not about the fad of doing something right now. I think whatever we do now has to be very systemically done, keeping future in mind, and not do anything which is ad hoc, because any technology we deploy ad hoc, I mean, as Indians, we are very good at frugal innovations, which is very good strength of ours. But at the same time, we have to be careful that we don't create systems now which in 5 years we regret creating, saying, why did we do this? And talk about it 5 years from now. And as technologists, it's our responsibility to be kind of setting the direction and also ensuring that we all achieve what we set out to. So as everybody knows globally, when we talk about transportation now, we use the words case, or which says connected, autonomous, shared, and electric. I think that's what everybody talks about globally when it comes to transportation. But two topics which are extremely fascinating and to see how it can do things is one in India on shared mobility. I think in the last 5 years, we have seen the benefit of shared mobility. Not yet the multimodal mobility, which will probably take some more time before we get all the infrastructure in place. But shared mobility has been quite popular, and everybody understands, even a common man understands how to use a shared Ola or Uber, and then how to make that happen. Whereas electric, like I said, is starting to happen. But is electric the only way? I think I'm going to ask the panelists to say, is clean mobility defined only by electric, or are there alternate ways of doing it? Electric is now currently the way of doing it, but is that the cleanest way? Because when we talk about sustainable, we need to find the cleanest way of doing it or the green way of doing it. It's not only about the fastest way of doing it. So electric is definitely a way, But there are a lot of questions I get asked when I say electric, to say, where is the electricity coming from? You're burning coal anyway. So you're moving your pollution and your other things from an urban area to another industrialized area where the pollution is going to increase because you need more power. Of course, there is a counter argument to say there is more solar power coming in, renewables coming in, so maybe we balance it out. These are the questions I want to ask our panel as we go along, to say, are we in a true green way in India particularly? We will not have time to discuss every other country, but probably we should talk about India and the technology in India. So is it green? I mean, how green are we? Are we going towards that? And when we talk about sustainable mobility, it's not just about using vehicles. It's also about how we move from one place to another place. One year back, I think, or a year back before COVID, I was in Singapore in a conference and a meeting where Singapore government and couple of companies there were presenting how their sustainable transportation strategies look for. And that did not include electric at all to talk with. Electric was part of it, but their main story was about how they were layering their buildings, how they are reducing the commute time from home to office by bringing office closer to home, buildings closer to home. There was a lot of other topics which were done to reduce the time to travel and thereby reduce the needs for vehicle, which was their sustainable strategy. Electric was part of it. Fuel cell based vehicles were part of it. But main strategy was to say, how do we reduce movement of people and goods in a sustainable way, in a green way? I think that is another thing which probably I would like to ask Pawan as we go along to check what policies are being done in this fashion. I think Aishwarya also would be nice to hear from you. And when we talk about now electric, I think all our interest has been around two-wheelers, three-wheelers. I think we heard the previous speaker talk about how battery swapping can make a big difference. There are multiple ways of doing it. But also we should remember that a good amount of our highway traffic is also moving goods, not just people within the urban mobility. And can a clean mobility help us in that sector? Is where probably I want to pick Sudindra and talk about long haul transportation, the transportation in general, not just people movement, also from goods and long haul movement. How can we change the vehicles, and how is that going to make an impact to India particularly? Because can we see a difference there? All of that we are talking, and we are in electric vehicles. Battery is one of the key elements, and the way we are using the battery, different chemistries. Can there be alternate fuels which can be used for clean mobility? I think that is something which we will discuss also, and I would probably look at Dr. Kale to share his perspectives on all of that. Having said that, I've been, like I said, pretty excited in this space, not just by looking at what is happening, but also what can happen. Way back in 2017, I was part of several discussions which happened in India in terms of policy setting and others for clean mobility or electric mobility. A lot of people did not believe that many of them will happen. And I think 4 years later, I think we are starting to see many things to happen. And I'm quite happy about it. And the recent announcements by several large companies about their commitment in terms of getting electric mobility or clean mobility, I think is commendable. We will now probably get started. Like I said, I will start with Aishwarya. Aishwarya, you have been an entrepreneur. You have done a lot of work in this space, and at the same time, as part of Ola Mobility Institute, you have been working a lot in this space. So give us some perspective of what is the shared mobility or shared, I mean, one is shared and second is more sustainable transportation.
Of
How
course.
do you define it, and what do you think it is, so that everybody gets in a simpler terms? So next time when they use the word sustainable transportation, they know what they are referring to. Over to you.
Absolutely. Thank you, sir. Thanks to the organizers for having me. I'd like to quickly introduce Ola Mobility Institute before I get to answering that question. For those of you who don't know, Ola Mobility Institute is the policy research and social innovation tank started by we are a little over year-old and organization. We the of mobility innovation and public good. We do research across of electric mobility, sustainable urban mobility, access and inclusion, future of work and the platform economy, and of course, energy and mobility. In this background, the pertinent question that has been raised is, what is sustainable mobility? We will obviously take cues from the Sustainable Development Goals here. SDG 11, for instance, talks about the urgent need to create cities and ecosystems that are sustainable, inclusive, reliable, accessible, and safe. And I think these principles, which foreground partnerships between the public and the private sector, which foreground innovation, which also, of course, foreground, clean transport, in the sense that it is zero emission, in the sense that it is decarbonizing, which foregrounds equity, because you require, there is an urgent need to cater to all kinds of individuals, people belonging to different social groups, people with or without access to private mobility. All of that needs to be factored in. And of course, mobility innovations that are financially viable and sustainable in the long run. So these, I would argue, are perhaps a few facets that we need to keep in mind as we design sustainable mobility solutions for our cities, not just for today and tomorrow, but for the day after. Let's talk about shared mobility. Globally, like Ravi sir was mentioning, the world is adopting the new paradigms of mobility called shared, connected, electric, artificial intelligence powered, and autonomous mobility. What is shared? The ubiquity of smartphones and affordable data today has ushered in a new era of mobility, where mobility in terms of the vehicles themselves can be shared, where mobility services can be shared. In terms of vehicle sharing, you can share vehicles both parallelly and sequentially. So it is not necessary to treat shared mobility only as ride share, where a car or a two-wheeler or a three-wheeler or the mode of public transportation is shared among multiple users at one go, but also the sharing of vehicles, the access to these rides, which happens in a sequential manner, too, is important. Why is that important? Take taxi cabs, for instance. Any four-wheeler which can avoid a single occupancy use case, which can avoid the need for multiple parking lots being made available to them. Any four-wheeler that is as an asset shared in that manner becomes a sustainable mode of commute for the city. The sort of decreased reliance on parking spots by ensuring that your assets are utilized to the maximum, that these vehicles are kept on the move throughout, is also an important contribution in a positive way for the city. Similarly, shared miles, of course, this reliance on taxi cabs, auto rickshaws, two-wheelers that can be shared as well, helps you reduce your reliance on import dependent fossil fuel, reduce your reliance on the need, like I mentioned, to have ample space in urban agglomerations where land is hard to come by already from a parking standpoint. You also then look at reducing the ownership or the purchase of private vehicles as well, because now you're purchasing vehicles only from the intent of sharing with others. So sharing the excess capacity in the ecosystem itself is, I would argue, the first step that we need as a society to take towards sustainability as a future. One small additional point here would also be the potential of shared mobility to unlock jobs. India urgently needs tens of millions of jobs to be created for the masses. Digitalization of mobility has already created over 5 million jobs in the passenger mobility and the hyperlocal delivery space. This is another great positive economic output of digitalization of mobility, which then caters to the sustainability goal of equity. So these I would, collectively term as the efforts that a society, that a country like India need to urgently accelerate. We're already well poised to ride the wave of shared mobility. We as a country have always relied on shared, right? We are not like the US or the UK. We don't have 800 or 900 personal cars per 1,000 individuals. It is as low as 28 cars per 1,000 individuals as per the latest statistics by the Ministry of Road Transport and Highways. So given this context, we are heavy users of public transport, intermediate public transport, of walking and cycling, and therefore we are well poised to ride the wave of shared mobility. All we need to do is create those enabling policies and environment that can accelerate the adoption of digitalized shared mobility. Back to you, sir.
Thank you, Aishwarya. I'll anyway come back. Maybe I move to Dr. Sudindra. Sudindra, you've been an automotive person for a long time and now also leading innovation at Volvo. There are two things which I want to ask you. One is, of course, as an auto OEM, because now you represent also an auto OEM, how do you see sustainable transportation? Not only in India, would also like to hear your perspectives globally, what's happening, because being a leader in this space, you have seen multiple markets. So some perspectives from you in terms of sustainable transportation. Need not be electric. I mean, any means what we are doing is something would like to hear. And how does a vehicle OEM like you look at this space?
Yeah, thanks. Thanks, Ravi. Thanks everyone at BTC. Yeah, it's a very relevant question for us, obviously. We see sustainable mobility is not something that is going to happen overnight in any sense of the word. And we also do not see, like you rightly said, Ravi, sustainable mobility equals electric mobility, neither. So we are in one big significant part of our business at Volvo Group is transportation. So when I say, usually I make a distinction, we move people or we move things. So let me take the part which move things, say logistics and transportation of goods and stuff like that. When you look at that, we do see multiple technologies taking us forward in the coming year. So that is part A of my answer to your question. For us, sustainable mobility globally, I think Aishwarya also mentioned that it depends on which country and which stage you're in, and different countries are at different stages. So if you look at Paris Agreement, you can make out very clearly that yeah, certain countries who were polluting for the last 150 years are doing very well now, and those countries who are polluting only the last 50 years are asked to do much more. So that does not correlate with the economic development of that country itself to be able to cope with that. Still, as India, we are doing well, but globally we look at sustainable technologies to come from different angles. We are betting not only on one particular electric mobility, and it also depends on the type of transport that I mentioned to you about. So perhaps we look at, like as a Volvo Group vision, we look at 2040, where we are practically out of complete fossil fuels as a source of energy. But then what will be replaced with? So of course, one part will be electric. That might be for not long range, but for short, medium. Then we look at biodiesel and other ICE engines still to continue. So for those who are keen to know whether we believe ICE will continue, yes, for us, for sure it will continue, but maybe not as the same fuel as we see now, maybe in a different form and shape. But the third one is even more interesting when it comes to long haul. It is very clear to us and some other players in the global market that it will be more hydrogen kind of energy, because that's where I think the one technology will not serve all segments as such. So that's where we see heading. And of course, in electromobility, we have our own challenges as an ecosystem. The chicken and egg problem of charger and vehicles, I think, is still something. I think it should be more a matter of time. I think somebody will have to say, okay, this is how we're going to do it. So we as Volvo Group also have worked with a couple of European companies to put 3,000, 4,000 chargers around different parts of Western Europe to get this off the ground. So once the critical mass comes in, I think it will be easier. But then it gives rise to other things because each technology has its own disadvantages. So what I'm trying to say is when we look at sustainable technology, we look at the big picture. we have used science-based targets, but it's tougher to meet them in the long haul. But we do play the game for the long haul, and we believe it will be a difference. But also one last thing to mention is, in this whole game, we don't see products as the only source of innovation. We also look at services to play a significant role. And that, I think it's still fluid at this stage. It's a crystal ball. Everybody can gaze it and come up with something. But I think services, and again, referring back to Aishwarya's point of shared mobility kind of opportunities, recycle, refurbish, remanufacture of batteries, because that's the level we are thinking when it comes to sustainability, Ravi.
Sir, you are
Sir,
on
I
mute.
think you're on mute.
Sorry, I think I muted myself so that there is no disturbance. So, Aishwarya, coming to you, I think as part of your research, you have seen what India is doing. So maybe if you could share a little perspectives on what's happening in India and how do you see it happening across different states. I mean, of course, we are all sitting here right now in Karnataka, but it need not be the only flag bearer, because I think different states have done different deployments, implementation, and policy. So whatever you have done from your perspectives, where do you think it is going in India? What is the status, and what are different states doing? Maybe if you could update us.
Absolutely. So, on the front of sustainable mobility, states, of course, under the able guidance and perhaps demonstration by action by the central government, have been focusing heavily on both shared and electric mobility. On the shared mobility front, as well as the electric mobility front, interestingly, many states are taking a value chain approach. So right from looking at the manufacturing of electric vehicles, manufacturing of vehicles in general, to their adoption on the one hand, to creating robust networks of charging, refueling in the context of biofuels, for example, to also looking at end of life management of both batteries as well as vehicles. I think all these are becoming core issues for policymakers in India today. You have many central government policies that are creating frameworks for different states to consider, states that are coming up with relevant rules and enabling ecosystem, and of course also pumping in money to sort of accelerate the adoption of these sustainable mobility modes in the country. So let's start with the shared mobility ecosystem. So we have today not just a government that across the country that focuses on promoting public transportation in the form of having more metro rail, having more buses per 1,000 individual, but you also have governments that are enabling the sharing of private vehicles. So you have, say, two-wheelers that have the whiteboard on them that can also be encouraged to ferry passengers, to deliver goods. These become beautiful examples of how existing assets on the road. We all know 80% of our vehicles on the road are two-wheelers. So many states have come forward today to introduce bike taxi policies that allow you to convert these idle assets. Again, we know that more than 80% of the time, any private vehicle is kept idle. It's parked at home or in office or at a public parking station. So these can now be converted into shared assets. You create jobs. You're also able to prevent the further introduction of two-wheelers in the city, in the country. So this is a great move. Many states have already introduced bike taxi policies, and we would encourage that others do this as well. Bike taxis have serve multiple interests, right? So they offer first and last mile connectivity to public transit. They offer a short distance daily commute. They cater to short distance daily commute needs in cities. A city like Bengaluru could consider using a regulatory sandbox approach to make bike taxis more and more viable. They can test the outcomes of a solution like bike taxi in a controlled regulatory environment in the form of by running a regulatory sandbox and then testing this mode out. So bike taxi is one interesting area of regulation that we're seeing is picking up across states. Then you, of course, have carpooling and car sharing, as well as, making micro transit in the form of minibuses on digital platforms viable and readily available for citizens. These are other three areas of interventions, regulatory and policy interventions, that multiple states are taking up and considering. We, on the electric mobility front, of course, over 23 states have either a final or a draft EV policy. These EV policies, as part of our research at the Ola Mobility Institute, we've been noting how they leverage the comparative advantages of different states. Today, not all states have to think about becoming a manufacturing hub, because that kind of infrastructure is hard to establish. Today in the country, again, we know there are very few auto clusters, right? Component manufacturing, vehicle manufacturing, etc. So recreating it across the country may not be possible. But there could be certain states that are high on the human capital front, right? So they would have a workforce that is readily available for upskilling, for reskilling, and imagine preparing that workforce, keeping them ready for the future. That could be something that state governments could prioritize. So keeping these different strengths and needs and aspirations of states in mind, states are carving distinctively different state level EV policies, and these EV policies don't just offering purchase incentives and subsidies to the end user, but they also have fiscal and non-fiscal benefits for manufacturing. Like I mentioned, there is end of life focus as well. So there are many states that are looking at urban mining, which is where you identify or sort of call out the necessary raw materials for future products such as batteries and electric vehicles. So EV policies themselves are becoming very diverse today. EV policies are leveraging the strengths of respective states as they are getting designed, and the needs and aspirations, capturing the needs and aspirations of the states as well. What is the future? The future is definitely, I'd like to reiterate the new paradigms of mobility: shared, connected, electric, artificial intelligence powered, and autonomous. We have a drone policy that's already gone live. You have pilots today that help you with in leveraging the power of artificial intelligence, leveraging drones to deliver medicines and vaccines to the remotest corners of the country. So these pilots have to move from that, these experiments have to move from the pilot stage to becoming the mainstay of mobility in the country. So that's the direction in which we should head. And that's where, again, policy should not continue playing catch up with technology. It should be agnostic to the technology, but focus on outcomes. If our outcomes are equity, sustainability, which is, clean technologies, reducing the energy guzzling of the transportation sector, reducing the emissions. If those are the outcomes we want to focus on, if we want to focus on accessibility and inclusion, having each of your transportation modes accessible to persons with disabilities, accessible to women, accessible to children and the elderly, if these are the outcomes you want to focus on, then forget about controlling what are the technologies that will get you there. Instead, work with the public sector and the private sector together to design experiments, to conduct these pilots in controlled regulatory environments, and get to those outcomes sooner rather than later. So there's a lot of impetus from the policy end. There's a lot of impetus from civil society. People are now demanding from their states, why they don't have state EV subsidies as top up to the FAME subsidies at the central government level. So all these are, I think, pushing India quite rapidly towards a future where mobility will be sustainable end to end.
Yeah, thanks, Aishwarya. I have some follow-up questions, but maybe I'll go to Sudindra first. We are also waiting for our other panelists to join. I think one of them is a little delayed. So I will probably, between Aishwarya and Sudindra, we'll keep the conversation going till the others join in. Sudindra, one question. You're also an innovation champion. You've been helping a lot of companies and also yourself on different innovations coming in this space from an automotive space and in general. So when you look at a market like India, do you think India will innovate differently from other countries? Do you see our market looking at different way of solving the same problem of sustainable mobility? Your thoughts from whatever you've interacted with others. What are your thoughts and what do you think?
No, I think it's a very good question, simply because coincidentally yesterday I was in another discussion on a similar topic in another forum. The idea was when we look at innovation, many a times, not always, we see what you just said, Ravi, is to see a kind of control C, control V from what is existing elsewhere. The topic yesterday's discussion was about wireless charging as well, and how far can we push that envelope and so on. So I think my belief is also around what you said. I think the what of the problem will not change globally. If you take a particular segment, yeah. So Europe doesn't have a two-wheeler or a three-wheeler, but if you take car or a truck or a bus kind of an environment, the what of the problem will not change, whether it is within the vehicle or outside the vehicle. The impact of, for example, an electric vehicle in Europe on the grid, or Europe or an Indian EV ecosystem in India on the grid will not be changing dramatically. So I think, but the how part of the solution could be very different, because one, the affordability, but also just as a parallel, you know it better than me, Ravi, when you look at telecom market, data is still the cheapest in India. I think it's incomparably cheaper. It's not cheaper, it's an order of magnitude different. So I think scale gives you certain advantages, if you like you said in the beginning, if you play it right. And that's a very something we should tread cautiously. So when we do the how differently, we cannot be very short-sighted. We have to look at, my personal opinion, since you asked, is we should look at solutions which can go back to the Europes and the USs of the world, the so-called developed countries. And it's possible, because nobody wants to spend more than it is necessary on a particular solution. But that does not mean the perception of quality of a solution is the same across the world. No, it's not the same. So that means we need to think very differently, both in terms of solving it, but also making sure it can diffuse into other parts of the world. So to summarize, the what will remain the same, but the how will be different. And even there can be multiple hows, one for here, one for somewhere else, and so on.
If
Excellent.
I may also come in quickly here.
Yes, please, Aishwarya.
I like one point that Sudindra sir mentioned, the control, copy and paste sort of an approach. Simply because I think that's an interesting point to highlight, because we cannot have a context bereft import of ideas and solutions, right? Look at, in the global north, the evolution of digitalized mobility is so different from how it happened in India. 10 years ago, we had auto rickshaws and taxis that were situated in taxi stands, that were outside prepaid stands outside railway stations, airports, etc. And their movement was largely curtailed. Their free movement within a city was largely curtailed. And our focus was not to look at how do we enhance this segment, but to simply say, oh, we don't have a number of buses in a city, let's introduce more buses. But buses cannot be made demand responsive easily, right? You need the first and last mile connectivity to be provided by sustainable modes, especially shared modes, in order to make that entire transit ecosystem demand responsive. So in India, we were solving for inefficiencies as we began digitalizing our mobility ecosystem back in 2010. The inefficiency was that the taxi driver could not find a return fare wherever they went. Therefore, they were charging double or 3 times of what an ideal fare would look like. The passengers did not find a taxi or an auto rickshaw readily whenever they stepped out of their homes or offices, or their, or when they visited, say, hospitals or marketplaces, etc. So sort of plugging this gap of, demand supply match is something that digitalization of mobility, building on existing shared mobility assets, is something that, India managed to achieve. Whereas in the global north, you were not solving for the mere inefficiencies of taxis in New York City, for example, but you were also looking at how can I introduce a new brand of vehicles on the road, thereby perhaps leading to competition directly with public transport, raising questions in the minds of policymakers and regulators whether shared mobility is indeed helping the economy, helping the country, or is it adding to congestion? So the narratives are different, the contexts are different. Therefore, even when you study digitalization of mobility in different markets, understanding the context, understanding its genesis and evolution, within the limitations and the opportunities of the market that you're studying, I think is very, very important. And therefore, there is no scope for generalization. And I fully agree with Sudeen Rakowshik when he said, you are I think the outcome-based questions are the same, but the solutions, the context, the aspirations are all different.
Sure. So there is one question which I get asked many times in terms of do we need slow moving vehicles? I mean, of course, in India, this is a context within India. Right now, with all the electric and cleaner vehicles are two-wheelers and three-wheelers. This is what the conversations are all about. When you look at cars and trucks, and buses, these are still smaller numbers because 85% of the market is two-wheelers and three-wheelers. Or probably in EV, it is almost 95% of the market is two-wheelers and three-wheelers right now. So these are slow moving vehicles, many of them, the three-wheelers particularly. Though it is very beneficial for a last mile connectivity to make it shared and do it, these are slow moving, which means it may add to the traffic congestions we have. It may add to the other issues when it comes to our mobility, not just about the cleaner part, but maybe now the productivity levels and the other challenges come up. So any perspectives from both of you? I'll start with Aishwarya, then probably Sudhindra. Or do we need to look out of the box and not really reinvent our two-wheelers and three-wheelers to go electric or a fossil fuel based? Or maybe look at a very different form factor of vehicles which will make the transportation more sustainable. I mean, this is a challenge I've heard many times from different people to say, are we just reinventing the wheel and making it more complicated?
I think, beg to differ from you slightly, and perhaps
Sure.
those that are raising this concern on slow-moving vehicles causing congestion. I think congestion is a result of poorly planned and developed cities and having too many vehicles on the ground, right? This and also, you have a lot of construction material debris too lying around all the time that causes so many roadblocks as you travel, as you navigate metropolitan cities as well. Interestingly, at Ola Mobility Institute, we studied this concept called uncongested mobility. So in majority of the parts of the country, congestion or slowing down of traffic is not caused by these so-called slow-moving vehicles, but by poor planning on the roads, construction debris lying around, some other roadblock getting created, or the fact that we don't follow lane driving and we don't have that sort of discipline, right? Why we need all kinds of mobility, and that's something that I personally, as well as we at the Ola Mobility Institute, strongly second, is that you have different use cases, right? You have and beyond the use cases, you're also looking at the opportunity to unlock livelihoods in the millions. We have 500 million strong workforce that needs to be productively employed. And mobility and digitalized mobility, shared, connected, electric, artificial intelligence powered mobility unlocks millions of jobs. And that is a fact we cannot ignore, because that's necessary for us to grow both as a country and ensure that we grow, we experience and enjoy development which is inclusive. That's on the livelihood creation front, right? That's why you need your two-wheelers that can turn into bike taxis or bike pooled services. You need your two-wheelers that can handle deliveries. Then let's look at, the need for first and last mile connectivity as well. Buses, however fast or slow they're moving, cannot be accessed at your residences, cannot be accessed by individuals living in small lanes in their residential areas. Much of the commercial establishments in large metropolitan cities also don't enjoy wide lanes where buses can come in, where you can have faster moving cars come in. Both affordability as well as the feasibility of having larger, faster moving vehicles reach you at your doorstep to pick you up is not something that I can conceive right now because of land constraints, because of how India is designed, because of the affordability challenges that a majority of us have. Then the larger sort of the fundamental question I'd like to ask is slow moving traffic bad? Simply because when vehicles slow down, the road safety aspect improves, right? We want free flowing traffic, not so much traffic that's moving at 100 or 110 kilometers an hour, simply because that's the only way to enhance road safety. Like I mentioned at the beginning of this conversation, I guess, majority of us also walk and cycle to our workplace. This has come out in our Census 2011 data. This has come out in the survey that the Ola Mobility Institute conducted 2 years ago. Ease of Moving Index is a framework that the Ola Mobility Institute has developed. We carried out India's largest mobility survey, interviewing 43,500 individuals across 20 major cities. This index looks at measuring mobility scenarios across cities, across 52 parameters. We are now revamping the index and introducing a post-COVID survey as well. Now, here, what comes out clearly is that, individuals prefer active mobility as they commute to their work on a daily basis. This could include cycling and walking. And of course, majority of us do find only shared mobility such as public transport and intermediate public transport, including cycle rickshaws, to be the most affordable and accessible mode choice today. Although we do have aspirations as the growing, burgeoning middle class India to become car owners, it's not affordable, it's not sustainable. Many of us are making the switch also, not just livelihood cyclists, but many of us, individuals like me, we are making the switch to cycling to work simply because it's the better choice to make. So the millennials, their aspirations today of being, of contributing to sustainability in its truest sense, I think all these aspirations need to be factored in when you would, disregard or dismiss the so-called slower moving vehicles on the road. So I want perhaps on the other side of the spectrum to argue that yes, we need our cycle rickshaws. Yes, we need our electric rickshaws. Yes, we need our autos, we need our bike taxis, we need cycles that are both electric and pedaled. And this multiplicity of choices is what will help India transition to a future that is fully sustainable. We cannot do away with any of these modes. All these have to coexist, and we need to find, of course, innovative ways to help everybody transition to a cleaner fuel technology, be it battery operated electric vehicles for the long haul, like Sudeen sir was mentioning, hydrogen fuel cell electric vehicles, etc. So that's, I think, the lever we have to focus on, not so much getting rid of these vehicles on the ground. Thank you.
Thanks, Aishwarya. I would like to welcome Pawan from WRI also into the call. Welcome, Pawan. Pawan, we've been having an interesting conversation on sustainable transportation, EVs, and all of that. So now that you have come in, we have an interesting audience question from Ashok Das, and also I think there was one other question I had is why only, I mean, we are now gone a little deeper and talking about EVs and others. So why electric vehicles? Why not hybrid? Are there any alternate fuel which we can use other than electric to make cleaner mobility? I think you've also been an expert in this space, looking at hydrogen fuel cells and others. So your perspectives on why not hybrid, and why not looking at alternate fuels other than just electric?
Thank you, Ravi, and my apologies. I'm still at the ministry, but I just got excused to get into this interesting panel. I think the question, the technology choice will come from, the options will come from industry. And I think the government should be talking about policy setting and targets. To really say that, the government cannot get into saying that, we should do only this technology versus and another technology, right? It's not pitching or, pitting one against another. What is the overall objective? I think if you're talking about, I need to move towards, better air for the citizens, better access for the citizens. I think the motive is there. This what happens is we assume that the schemes are actually pushing only one technology over the other. I don't think that should really that should be the way we should be looking at it. I think the technology choices will come from OEMs. They'll be able to say, how they're able to create better products in which specific technology, whether it's hydrogen, it's EVs or hybrids. See, the challenge with hybrids, specifically in India, has been, and I think globally also, I think, of course, there are certain tax policy, we're talking about hybrid dominantly in the car segment. But when we are talking about in the two-wheeler and three-wheeler segment, I think the conversation is very different for us. The choices are very different for us. So it's also a choice based upon modes. And the thinking, at least in the government, is if we have to go to EVs ultimately, why don't we do leapfrogging? And rather than, why do we do hybrid? I think that's where the hybrid story has lost relevance. I would really say in India, you wouldn't really hear much today on hybrid at all. We are talking about, let's get EVs, let's get now to hydrogen. I think some of these are also coming because of the concern from political economy, energy security issues that we are really talking about. And that's why, we are saying that, okay, there is this confusion. Should we do BS6 now, BS7 standards, and then, get into the EVs and then hydrogen? I would say as the funds are limited, the options are always going to be limited in terms of where the government also can incentivize, and these are technologies where heavy incentives are needed. If given this situation, the question is the focus should be on a short term, medium term, and long term plan for the government. I think, and for states and at municipalities, we should really look. And this technology transition should be tied to what is the target that I will achieve for the citizen. I would say that is how we will do a technology choice. And I don't think we can jump into a technology just because it has worked in other geographies also outside India. Because if you talk about, we have a 70% two-wheeler usage in most of our cities. And are we really going to say that, we want to force certain technology? Are we going to achieve the kind of economy today that we will see with electric? I'm not saying do this or not, but I think these are some of the questions that we need to answer. And I also wanted to point out that we haven't thought through about the downstream also. What will happen when all these vehicles will come back in 3 years, autos will come back in 5 years? What will you do with all these batteries? Is there a second life of this? My understanding is some of these vehicles, we can't even use this battery for second life. Do we have material recovery? uh, standards and norms in place? I think a total view is needed and not just look at one chunk of the value chain and say that, in the service it works, so I will do it. But what is the upstream? You're talking about from where it is coming and all the way to downstream, what's going to happen? I think this is where institutes like us and, OMI and others have a major role to play, because I think a lot of information has to be brought out in public domain, that what will happen and what are their total impacts. Let's not look at what is the impact just because what's happening right now in the service delivery. Look at what happens when these vehicles are not usable. Is there really a second life possible? The what's going to happen with that? I think these are some of the areas where we are also looking at. And honestly, Ravi, we don't have answers very clearly yet defined. And I think therefore there's this challenge of technology transition also that's happening right.
Thanks, Pawan. I would also see if there is any audience questions. If you have any questions, please give it to me on the chat window. I'll pick it up. Pawan, one more question. Now that you're here, EV financing is something which you are also very passionate about, making the same clean mobility affordable to a lot more people. I think financing will play a major role. It did play a role in the last 2 decades also to get other forms of mobility. Sorry, what are your perspective? What is happening in this space? Would this be a game changer in the next 3 to 5 years to make a clean and sustainable transportation affordable for all by getting the right financing methods? And with technology in place, it can be done much better than what we did in the past. So even for the banks and the financial institutions, they have access to a lot more data and control to make things happen. So your thoughts, your perspectives on that?
Two, three perspectives. One is, I think what's already happening, demand aggregation will play a big role because I think when the scale of economies will kick in, I think you will have better negotiation power and you have a better way of handling this contract mechanisms and financing will kick in. For example, in Delhi, I was talking to the commissioner the other day. What they were saying is already there is a parity between the CNG autos and actually the um, electric autos because the price point to BS6 is roughly close to 2.5, 2.6 lakhs and electric with the subsidy which the state is giving, it almost comes down there. And they are confident that, they almost have 7,000 applications for, 4,000 auto permits that they're releasing. So that is already happening in terms of, with the schemes. But as you said, there is that incentive that is really needed from the state level. But talking about financing, I think in the lower forms of segments, two-wheelers and three-wheelers, it's quite achievable. I don't think we should be really subsidizing cars. And if someone can afford car, then I don't think there is a need for financing that. It's individual; they can go buy and get it. But definitely, where we need subsidies again is in public transportation. Electric buses will need. But we are also seeing certain interesting financing mechanisms, right, Ravi? Green Cell Mobility, which is now deploying buses in Uttar Pradesh. You see that they have really kind of cracked the mechanism they have been doing in Rajasthan. So, we are seeing that some of this equity investors really coming into this space, and that too in electric buses is something, bus space is something very new, unheard. That where, it was such a model where, very capital asset intensive. We are seeing that, the shift is happening. And one way to look at it is financing also to really tie it with climate um, funds and options. We have like national air quality um, funds. How can you really then show the health benefits and see can that be financed for buses? So I think these are some of the thoughts. I think in two-wheelers we don't really need to worry. The TCO parity is already there, and it's only about the kind of business models that will really need to come. But I think one big issue we'll see is, are we able to draw the kind of mileage that our customers are used to, specifically in two-wheelers? Will electric be able to match? And I think that's where the hesitation really lies. I don't see financing itself right now as a big challenge when you talk about individual owners versus aggregators. Ravi, you're on mute. We have not been able to hear you.
Sorry, my mistake. Uh, we have just few more minutes to go. Just want to keep up the time for the session today. Uh, I'm just checking if there is any other question. I think, yeah, I think we answered the hybrid question. There was one question to you, Pawan, on fuel cell based vehicles. I think probably also for other panelists. Do we see that happening in India? Because we are only talking about electric right now. What is the status? What are we going to do with fuel cell based vehicles?
I can give my repeat. Go ahead, Pawan.
No, please go ahead. Please go ahead.
No, so I was just saying, like I mentioned earlier, Ravi, so we do see fuel cell coming in as an option. It may take a little bit of time, but it will come. And the more OEMs or more organizations commit to get out of the pure fossil fuel options, this will become more real. Every technology comes with a plus and minus. I always wonder why the last time around 120 years ago, an electric car was not adopted. I still don't know the answer. I get different perspectives when I talk to people, when I read about it. I think there is something for us still to go and find out. Maybe something that made, because adoption is a very different animal than technology. So people can just ignore certain things just because it's too difficult from their behavioral aspect. So from a technology aspect, I still feel fuel cell will come. I think Dr. Gonda is asking fuel cell, I mean electric only. Yeah, for us, fuel cell can be a hydrogen too, in a sense of where the energy comes from. So that's what we mean when we say fuel cell, that because that debate is still not over, whether the energy that you use for EV is clean or not. I think fuel cell with hydrogen, I think there is less debate from that perspective.
Sure. Thanks, Sudhindra. I think would like to wrap up now. One just few lines from my side, from IEEE side. We are also trying to see how we can put down a roadmap for sustainable transportation, electric vehicle adoption in India. So we are working on a working group from IEEE standards. It's called an industry initiative. We have more than 50 companies participating. We are in the process of writing down a work paper or a paper which would come out by end of this year. From a technology aspect only, we are looking at what would be the roadmap which is meaningful for India. We are looking at 5 different aspects. We are looking at powertrain, we are looking at batteries, we are looking at charging infrastructure, we are looking at even skill development along with everything else, to see how can we adopt various technologies to make India in a better shape in the next 5 to 10 years. We have taken a 5-year horizon and a 10-year horizon. So would also, you will see some results coming out in the end of the year. So if you are keen to contribute or participate, do let me know. And I chair the committee, so we would like to also get your inputs as we go along. This is for everybody in the audience. If anybody is interested, please let us know. I think we had a wonderful hour of conversations without slides. I think that's very interesting. Many times we use slides to represent our ideas, but it was a free-flowing conversation. We had different perspectives. Thanks a lot, Aishwarya, for all your wonderful insights and the research you are doing. So we would like to also wish all the very best for the efforts you do to making things happen. Thanks, Pawan. I know you are busy. You are at a meeting, but still you found time to join the call. So appreciate it quite a lot. And on behalf of Bangalore Technology Summit, would like to thank you. And thanks for all your perspectives. Of course, you're also deeply involved in making things happen from policy and from many pilot perspectives. So maybe another day we get a lot more details and insights from you. We will anyway pick your ideas later on. Thanks, Pawan, for joining in. And thanks, Dr. Sudhindra. As always, you are one of the IEEE champions, and also now on the mobility side, also championing a lot of innovations. So thanks as usual for all your wonderful insights, and all the very best for your innovation program going on, Campex. And we hope to see a lot more Indian innovation which can go everywhere else in the next few years. I think would love to see that happen. Yeah,
Thanks.
thanks.
A lot of interesting questions also. And thanks, Aishwarya. Thank you, Pawan.
Thank you. And
Thank
thanks
you.
to Bangalore Technology Conclave for inviting all of us, to giving us this opportunity and the stage to share our ideas and perspectives. It's still an early stage, like Aishwarya said, there's a lot of work going on. So would like to engage and involve each one of you. If you're interested in this topic, do get in touch with any one of us. We are all here. And I think it's a joint ecosystem. Not any one of us are not going to change the world, but together we can definitely change the world. And I would request all of you to think, contribute in whichever way, personally, as a society, and also as a thought leader. If you're able to share something, more than happy, more than welcome to interact, collaborate, and make things happen. Yeah, thanks, and all the very best to IEEE Bangalore Section and the Bangalore Technology Conclave. Thank you. Over to you.
Thank you.
Chandrapal
Thank you,
and
Ravi.
Shah.
On behalf of the BTC organizing committee, we would also like to thank you for being the moderator and steering this panel discussion in the right direction, and also framing the questions in the right context, so that we can have a plethora of insights from all the panelists. So thank you once again. And as you are also working on e-mobility space, and as the same lines that you mentioned for Sudhindra, we would also like to see many of the contributions coming from you and your company on this e-mobility space in Indian context in the coming days. Thank you once again for joining us today.
Thank you, Changappa. Thank you.
Okay, Dikshita, over to you.
Thank you, sir. It was a really great session and an interesting conversation indeed. So moving on, our next speaker is Professor Vasant Kumar. Vasant Kumar is a professor of materials chemistry. In his group, they have research expertise in electrochemical redox reactions at the interface of electrodes and electrolytes, and morphology of electronic materials with an ecological calculus at the cutting edge of new applications. Their research output has attracted worldwide recognition for creating framework that places emphasis on optimizing rates of redox reactions, minimizing polarization losses and parasitic reactions, and on design features for recovering materials and components with minimal loss of value. Professor Vasant Kumar's other research includes energy devices, sensors, recycling, and sustainability. A warm welcome to you, sir. Over to you.
Yeah, thank you very much. Good morning, everybody. Good morning, ladies and gentlemen. It's a pleasure to be invited, and I look forward to discussing over the next half an hour some other work related to our thinking in the battery space specifically. Can I have this slides, please?
Yes, sir. We are bringing it up. Just a minute.
Thank you.
Thank you, Vasant, for waking up early and joining us.
No problem. I've been enjoying listening to the panel discussion just before. It's very,
Thanks a
very
lot.
informative. Yeah, and it's autumn in Cambridge. It's 7 a.m. and 6:30 a.m. It's still dark. Yeah, everybody's sleeping except myself. It's nice to be listening. Yeah, thank you for inviting. So yeah, so let me start with this slide. So it's energy storage for sustainable electrification is what I want to discuss with you. Next slide, please. Okay, so yeah, so this is, yeah, so I'm not in the college at the moment. This is my college because I think everybody's sleeping there, but I'm just from home now talking to you. But welcome from Cambridge University to all of you. Next slide, yeah. Okay, so let me just focus on a few items here. Let's start with energy storage and renewable energy systems, yeah. And for example, solar, wind, and biomass related electricity that requires support, requires energy storage. And the target cycle, and this is the target cycle set by the European working groups, of which I'm a member of, is that it should be about, in US dollars, about sort of 5 cents per kilowatt hour per cycle. Yeah. And it must have about at least 3,000 to perhaps approaching 5,000 cycles. It has to be safe and recyclable. If we move on to the next segment that is key to the electrification, is by 2030, the electrical vehicles, for example, the battery must have a capacity, like energy density of 400 watt hour per kilogram and 750 watt hour per liter, and 2,000 cycles at least at 80% depth of discharge. And the price point must be less than $100 per kilowatt hour. Yeah. And the aim would be to approach 12 minutes or less charging time safely and recyclable. Yeah, that's fine. And last one is about this small scale to medium scale individual houses to community grid support. Yeah, with an integrated smart grid. Yeah, let's move to the next slide, please. Okay, so I think one approach to think about these issues is to have a chemistry neutral approach, yeah, in terms of development, because I think in parallel, there'll be many, many different technologies. Just in batteries alone, of course, they add to it the fuel cells as well, and other potential green technologies. You will have many approaches, but just focusing on batteries today. So I'll suggest to have a chemistry neutral approach. However, the requirements are to head towards what we aim in the next 10 years to 20 to 30 years. We require tremendous rate of materials discovery. Yeah. And it's such that when you use these materials, we must be able to derive its energy and power within approaching the theoretical limits. in reality, at the moment, they're very, very far away from the limits. So in fact, the efficiency is very, very low. So the resource utilization is quite poor. Yeah. And not only how we can manufacture any given situation and have the supply chain secure for it, but also recyclability. That actually immediately supports the supply chain independently, because batteries are used everywhere. So therefore, all the raw materials are within our grasp in any place that we are. So that's a very important point to keep in mind. And of course, the other important aspects related to Internet of Things and smart sensing and self-healing will become key in these applications. Next slide, please. Yeah. Okay. The batteries can be classified according to cell structure first and the underlying chemistry second. Yeah. Okay. And this is from the Battery Europe. So the idea is that you have all the aspects of the active materials sealed in one system, and therefore it is not removable, although internally you can recharge again and again. Yeah. And these kind of structures are typically the kind of batteries our laptop is using, for example, and they're based on lithium ion, and potentially the other lithium chemistries may join it. And there is, we know that lead acid batteries are very commonly used at the moment. It's perhaps still one of the largest markets, and India is a leader in producing lead acid battery. But there's innovation opportunities here as well. And there's a whole range of other batteries that are actually in the queue to join in parallel development and compete very well with the lithium ion in some segment of the applications. The other structure, it actually depends on keeping all the active materials outside the system, and therefore it can sort of flow in and out of our cell, and therefore there's a decoupling between the energy and power, because essentially because we are able to draw the material. Fuel cells belong to this category, yeah, because for example, hydrogen is stored outside the cell, and it can drawn in, yeah. And others will, if they emerge, may be based on combining battery and supercapacitor and fuel cell hybrid systems, and perhaps mixed ion system. We always talk about one type of chemistry. There's no reason why one can have multiple components participating in those reactions, such that we have able to trigger one element for energy and another element for power. These kind of activities, of course, are in the future, but they're happening at the moment in terms of research. Next one, please. Okay, so I think this is only a schematic of what I just mentioned. So this is all the active materials are locked into the system and for safety sealed. Yeah, whatever happens, it happens inside, which is not visible to the user. And the other system has got essentially tanks. And these therefore lend themselves to large-scale applications for supporting, for example, renewable energy, solar farms, etc. And these are commercial or semi-commercial already, and they may be based on different chemistries. Yeah. And some aspect of it, like zinc bromine, is been already applied in some places. Okay, next one, please. Okay. Yeah, so we need to know what the KPIs are. The performance index must be related to the specific energy density in terms of weight or volume for the whole system. And charging rate, actually the C numbers determine the charging rate. So we would have a slow charging, for example, overnight charging, when you have long stop somewhere, or very fast charging. So there's a whole range of KPIs that may be relevant. And energy efficiency of the whole system at those rates. And there is what is known as a Coulombic efficiency. Therefore, for every charge that we put in or derive, it is highly efficient. There are no unnecessary parasitic reactions taking place. Cycle life, and we know that we like the battery to last for a long time. Yeah. And various things we want to know at the end as well, because if the battery has to be recycled, because electrically can still be alive, and if a large number of batteries together, if we're dealing with, safety is so important. Okay, yeah, and there are other aspects that maybe temperature may be very important from very hot climate to very hot climate to cold climates. Okay, and safety assessments before these batteries take off. Next slide, please. Okay, Yeah, the typical lithium ion battery that is the mainstay of all our electronics system applications and phones and laptops, etc. They depend on carbon as one structure and depend on lithium cobalt oxide as the other structure mainly. Yeah. And the lithium ions move from one side, and the intercalation in between the structure from one to the other. So that's why they call lithium ion batteries, because ions are moving from one structure to the other for discharge and charge. And the electrolyte itself is an organic electrolyte and contains a lithium salt. And this organic electrolyte can catch fire quite easily if it's very, very hot, or there's a short circuit between the anode and the cathode. Yeah, the other cathodes that are becoming potentially popular are based on lithium, nickel, manganese, and the combination of nickel, cobalt, manganese, and then cobalt and aluminum, etc. And it's a lithium iron phosphate. Yeah, there's a whole range of chemistry. They all have been applied or been tried and be commercialized. Next slide, please. Yeah. Okay. I think there's a game-changing activity has basically decision was taken by Tesla, while many others were developing specific batteries for, let's say, electrical vehicles or for electrical storage. Tesla's stole the march by using what is available batteries already, the available small batteries. They combined them in large number. For the first cars, they sort of used 11,000 small batteries, put them together. And the space filling was done by using underneath the car and with the armor supporting it. And it was 85 kilowatt hour. And that's the density they chose. The batteries are pretty good and volumetric and gravimetric. And the price point they achieved was around $200 per kilowatt hour. Remember 1995, shortly after Sony released these batteries into the market, the price point was 3,000 kilowatt hours. So you can imagine in 15, 20 years, how dramatically the prices dropped. And of course, this can go down even further, and it is going down even further. So they use the standard cells, and the pack itself, of course, was expensive. Therefore, all these cars were for high-end market to begin with. And of course, it's beginning to change slowly. The promise is that Tesla and others will follow with lower cost, but the cost is still relatively high. And the range, you can see that, and 1,000 cycles is pretty good to get into the market. I completely changed the discussion in the battery industry and the car industry. Next slide, please. And the charging, it was possible to achieve 30-minute charge at high. Yeah, okay. So this was early batteries, and this used nickel, cobalt, aluminum. Okay, and the one important point to note, if we need high energy density in gravimetrically, then the power will be very small. In other words, it will take very long time to charge, or you can't do much with it for many applications. Or if you want the power to be very large, associated with, say, half an hour or 10 minutes here charging, for example, 2-minute charging, the energy density will dramatically begin to fall. Yeah, capacitors are fantastic for power, but they always have a low energy. So therefore, the search is to combine these two concepts so that we reach somewhere here. So we get high energy and high power. Yeah, still we are far away from that possibility, but there are a tremendous amount of ideas that are being tried out. Yeah, next slide, please. Okay, so yeah, so just to say that the materials required are based on the original material, lithium cobalt oxide. Cobalt is actually a fantastic catalyst, but it's a very, very expensive material, and it's also available only in few places, yeah, at the moment. And this one was Tesla used. They used nickel cobalt, so therefore the amount of cobalt was lower in that electrode. And earlier on, a lot of batteries in China used lithium iron phosphate. They are relatively cheaper. They are not dependent on nickel or cobalt, but the energy is low, and they're good for sort of congested roads, etc. Yeah, definitely. And of course, what is becoming more popular, in fact, all Tesla and other cars nowadays are working on NMCs, and they become commercial. They use nickel, manganese, and decreasing cobalt because of the the sourcing of cobalt, and the price of cobalt is very, very high, and it's also competing with other technologies in aerospace and defense industries. So cobalt is in demand for other applications as well. And the anode materials currently depend on graphite, and graphite is used just to keeps lithium as safe as possible. Pure lithium is not safe at the moment to use, and more work is required in order to solve that problem. Yeah, and of course, increasingly silicon is being utilized. There are already commercial cells which combine graphite with silicon, but in the future we may have higher silicon content, producing very high energy and potentially lower cost. And of course, the holy grail is use pure lithium. There are safety issues, but there are some fabulous research now to show how lithium itself can be used. There's huge amount of energy in lithium. If you put carbon like graphite in the anode, the energy density of lithium drops by 10% of its actual value. Next slide, please. Right. Okay, so this at the moment, this is the plan with lithium chemistry alone. If you look at, I mean, it is stealing the march in the market, but others are coming in as well. But if you look at the European plan, the current technologies have moved on already towards NCM 523. So that just tells us the ratio between nickel, cobalt, and manganese. So decreasing cobalt is the answer for future. So I think now we're already looking at 811. So there's high nickel, but low cobalt. And manganese is, of course, a low cost, readily available. India is a very large producer of manganese, for example. Yeah, and then of course in the future we'll get more and more silicon carbon, and we'll have cathode which have high voltage, and there's a specific structure called spinel. And the other area that may be important is lithium sulfur. And this work has been going on for decades, but there are some important problems that are beginning to be solved. And then pure solid state, and that we hear a lot about it, that will improve the safety. And then we can readily use lithium as an anode. And of course, this is a really research. This is like a combination of a battery and a fuel cell, because you use air, the oxidant in a fuel cell, it's a gas phase, and a metal like in a battery. And that's really in the research stage, but it will actually begin to compete directly with hydrogen fuel cell, for example, in terms of feasibility. Okay, next, please. Yeah. Okay, so I think the key point I'm showing here, this is a volumetric. So this tells us about the size of the battery and the gravimetric, the weight of the battery. They're both relevant for different applications in different ways. But look at the rechargeable batteries in 19th century, invented first in France. And it's still actually market value of lead acid batteries still is the most dominant in the world. Yeah, lithium-ion batteries catching up with electrification and using lithium-ion batteries. It will outstrip the lead-acid battery market, but this is also growing, especially growing very fast in India, the application for lead-acid batteries. And then it took a long time before the next battery came out, but cadmium is suspect for toxicity, so it has actually reduced its share in the market. But nickel metal hydride was very, very popular in all the hybrid vehicles. They still use them. And that, unfortunately for nickel metal hydride, then lithium ion was invented around the same time. And therefore, actually, lithium ion basically took all the technology away from the nickel metal hydride. And because the energy densities were much higher, as soon as you have higher energy densities, whole new revolution is set up in applications that we can't imagine. Lithium sulfur battery, they are already semi-commercial. There have been many, many uses and trials of this, but over the last few years. And however, it still is struggling to reach the performance index of the lithium-ion battery, although potentially it's got very, very high energy densities. So in 5-10 years, we will expect to hear more about this. Yeah, next one, please. And sulfur is available. It's a low cost. It doesn't require cobalt, etc. Yeah. So yeah, just to say, give some idea about the lithium sulfur. It's a very complex chemistry. Yeah. So if you look at how the potential changes with the capacity, and because of this complexity and using sulfur, which is insulating, and the product which is very insulating, the battery begins to struggle. Yeah. So without going too much into the details, but you can look at that. Yeah. The typical. So this was a 2015 information, but still is relevant. So lithium-ion batteries are sort of have a range of 200 plus kilometer, maybe 260 for cars, for a European size car, let's say, and a zinc air, but it's not chargeable at the moment. It's mechanically charged. You have to just remove the cathode and the plate and put a new plate, the anode and the cathode. And the lithium sulfur can, if its cycle life is improved, it can immediately reach to 400 kilometers. The lithium ion is in R&D stage. Next slide, please. Okay, and it uses pure lithium. So that's one reason why it has got high density. And if you click more, and it uses sulfur, which is extremely low cost. And a lot of sulfur is available from so many of the industries. And just the oil industry produces so much sulfur stockpiled. And it's also in nature, you can get sulfur. It's very light and it's low molecular weight. And that's the reason the energy density is very, very high. But as I said, there are issues with respect to, there are technical issues to be solved. If you click the next item and the next two items, yeah. And you can use lithium metal, but the safety part is very, very important, yeah, for that. And the next item. Okay, and there is some uncontrolled diffusion of this product, intermediate product that form. So there's a chemical activity goes on between these two electrodes, which is parasitic. And that's why the cycle life is low, because it just suddenly dies. Yeah, next one, please. Yeah. Okay, so yeah, so they use a separator to keep it safe, but that itself attracts some of the lithium into it. And so this is a problem. If you have a very high energy density, the cycle life is low. If you have a large cycle life, the energy density is low. So this is a problem that requires solving. And there's a tremendous amount of funding all over the world to solve this problem, because this is a really attractive battery to go forward. Next one, please. Okay, yeah, so I think I don't want to discuss too much, but some of the concept related to type of catalysis, yeah, like a cobalt, as I said, or nickel, the catalyst, that's very reason why lithium-ion battery works so well at the moment. Here, there is no catalysis, the introduction of catalyst, and then there's some interesting techniques called interlayer to stop these polysulfides moving around. I think, yeah, and lithium in a new configuration, not just as a foil, but some 3D configuration, so that dendrites do not form and there's no direct short circuit between the anode and the cathode. Yeah. That's the reason why the danger of using lithium anode is very, very high. Next slide, please. Yeah, so we know that at the moment the market is potentially worth 120 billion of lithium-ion battery. Yeah, and I think lithium-sulfur battery can compete with lithium battery in lithium-ion batteries in cost for off-grid storage, definitely, and for drone applications, because it's much lighter for the same amount of energy. Yeah, okay. But we have to overcome some technical challenges. Next one, please. Yeah. Some other important points. If you have 1 kilogram of gasoline can generate 15 times more energy than 1 kilogram of lithium. Yeah. But spent gasoline cannot be recycled. Yeah. And soon, in practice, 100% lithium will be recycled. It's not at the moment, but it can be. And it's available wherever it is used. You do not have to look for chase the supply chain. Increasing electricity from renewable and renewable sources, that will also absolutely require energy storage as a key component of making that viable. And lower bill of materials and capex. If at $100 per kilowatt hour, and it is achievable within the next 3 to 5 years, is a tipping point, because an electric vehicle powertrain's net system cost is comparable to ICE powertrain. Yeah. Okay, some critical materials you have to look at in this. Any batteries we use, cobalt, vanadium, tin, rare earth, nickel, copper, these are relevant to the lithium batteries. Yeah. And if you bet on the low cobalt version for the future, this NMC, nickel, manganese, nickel is high. You can imagine even with that low cobalt version, the demand for nickel, cobalt, lithium will increase even for a 20% EV penetration in 2025 and 40% as planned in Europe. Yeah. So the worldwide nickel production is about 46,000 tons per year. By 2030, it has to be 3 million tons per year. And imagine the capacity requirement for that. and investment requirement. Yeah, it can be seen as an opportunity for investors. Cobalt from 13,000 to 670,000. Yeah. Lithium from 14,000 to 850. So cobalt actually could be a bottleneck, and recycling becomes absolutely key. So this is the point of time these technologies should be ready, at least in trial stage. Okay. Yeah, and the economic, if we just focus on lithium, yeah, I mean, you can think of each of those components. Cobalt, for example, most of it is in Africa, in the Democratic Republic of Congo, is the main. Yeah, so everything comes from there. So if you click a little bit, click more. If you click more, yeah. For most part, lithium was available from brine lakes in high altitude, such as in Argentina, Bolivia, Chile, and in Tibet. But with time, because of the demand, the lithium has also obtained from rocks. In fact, quietly, Australia has become the largest producer of lithium now, from the ores directly from mining, as opposed to before it used to be Chile and Argentina, for example, from South America. The seawater has 1.7 parts per billion of lithium. So together, it's huge amount of lithium. It can last for centuries. But how do we derive that? Yeah. So this work is of great interest. Okay. But for the ores, it's likely that these are available in many, many places. But the capital cost to set up the plant initially is very, very high. Next one, please. Okay. Yeah. So, and just for the 40% battery electrical vehicle penetration by 2030 will require 60 gigafactories. I think in my count is probably around 8. There are many being constructed and some are sort of semi-operational already. So you can imagine in a very short time that the scale of investment required is very, very high. These are very large factories. And the market is likely to be dominated by China and EU in the production at least. And because I think their targets, they're already investing in this area in a big way. But innovations and various different sizes factories are also possible. And UK, USA, Japan, South Korea, Taiwan, Singapore, India, you hear about all this planning in place for this. Okay, and Europe plans to achieve 250 gigawatt hour in 20 years. That Europe alone will require 50 gigafactories for that. Yeah, zero carbon economy. And this is legislation driven, yeah, and that will immediately change how the transportation and the renewable energy source and all aspect. It will have a huge impact. So, and Europe is trying to be leader in this area and march ahead of China in this. And this, yeah, they're taking on that competition. And demand for lithium, nickel, cobalt, I already mentioned, but also graphite. And all of these will dramatically increase, and therefore infrastructure changes, charging station, off-grid energy. So there's a huge amount of things to think about in a short time. Next one, please. Okay. Yeah, I won't spend too much time. I just want to say that India is perhaps the largest lead-acid battery, if not today, but very soon, and largest user and manufacturer. Yeah. And this battery itself can be improved tremendously, as some of our work in the lab has shown. If you just show the next slide, I'll just run past very quickly. I need to run out of time. Yeah, but lead battery is highly recycled, and there are lots of recycling plants all over the world, including in India. But there are emissions associated with that recycling because you can't throw lead away. There's no option of just dumping it. But for a 10,000 ton per year plant, is capital expensive, it's energy intensive, it uses fossil fuel for the recycling. Next, please. So through our research, we come up with a new process, which actually is a green process. So the capital cost is about 20%, and energy is negligible and doesn't use any fossil fuels. Yeah. And next one, please. And in fact, it uses the active material separately and the grid supporting material separately. And so this is the soul and this is the body. So the battery can be reincarnated in few steps. So this was patented by the university, and if you click, and it's licensed to an American Swiss company. And there's next slide, please. Yeah, next slide. Yeah, and the material that you produce after recycling is better than the original material. In fact, that's the reason why it has got more energy than the original material. So therefore, the opportunity in recycling upgrades the material. Normally, it's not the case. You just try to preserve the value. Next one, please. In fact, they're licensed to this company called IQ International, and there's a plant in the UK, which is a trial plant of 10,000 tons per year. It's got 30% greater energy density than the lithium battery or the dead lithium-ion battery from which it is derived, because of nanocrystalline structure, and there's uplift in battery life up to 50%, according to the early tests, and it cut down many steps in the recycling compared with the current processes. Yeah. And you get a very good control over the structure and the chemistry. The next slide. Perhaps I'm heading towards the end now. Yeah. Okay. So yeah. So and also it's less carbon. It's actually nearly carbon neutral. And it's got virtually no waste. Yeah. Again, in fact, it produces net energy in the process because it uses bio energy as a reagent and a source of energy. So it suggests that for the lithium battery, this is exactly the kind of model that we are researching, and many others are, to move forward. So therefore, you do not want to have more energy to recycle than from the raw material itself. So otherwise, that will economically not be viable. Next one, please. Yeah, and as I said, no, it's not only carbon footprint is low, reduced by 85%. It's got no sulfur dioxide, no nitrogen oxides. It's also not polluting. And it saves money, and because the capex is very low, and the cost OPEX is also comparable, if not low. Yeah. Okay, I think with that I like to conclude my talk, and thank you very much for your attention. I'm very happy to take any questions now or offline as well. Yeah. Thank you for the opportunity.
Thanks a lot, Vasant. It was a journey across the battery technologies, very illuminating.
Thank you.
And good to see some new materials coming in. But sometimes that's where the debate is. Do we go the chemical way, because there is a limit on how much chemicals are available, versus some other ways? So I think that debate will continue. But for now, it seems like lead acid will continue for a long time, isn't it?
Yeah.
And lithium ion on the transportation side.
Yeah.
Any other like futuristic ideas that, hey, this is the next most potential is this? What would that be?
I think if I would personally take bet on lithium sulfur, where very high energy densities are required. One should also not rule out zinc, because zinc, although it looks like a heavy element compared to lithium, there's no doubt, but it's very low cost, very easy to recycle back. And also it can be operational with air as the electrode. So it's like a semi-fuel cell. So therefore, yeah, but and
also the availability is high, right?
Very high availability, yeah, and yeah. So I think I can imagine that it might become aluminum also, because there are difficulties. It's a lot of energy. It's light. Aluminum is light. In fact, it's not far off theoretically when you compare it with lithium. But the problem with aluminum, it's passivates itself. It always has a layer of oxide on it. Yeah, yes. So that makes some difficulty in terms of recovering all its value. But having said that, I think there have been some good work in India on both zinc and aluminum, because these elements are easily available in India. The whole resources are there. Yeah, and so they're on the trial stage, but some big companies have actually made some aluminum batteries and zinc batteries in India for trials. I'm aware of that. So I would not, because as I said, it can compete really well, because where high energy density is important, perhaps one would look at lithium. But wherever other advantages, cost, long life, recyclability, availability of the supply chain, yes, one can't rule out zinc and aluminum. So I have a feeling it'll compete very well if more investment is made into these areas.
Okay, great. Thank you very much. I think we have run out of time.
Yeah.
Robert. So we'll conclude here with a token of thanks.
Thank you, Ashok. Yeah, very nice. Nice to be here talking to you all.
Go ahead, Dikshita.
Thank you so much, sir. It was
Yeah,
really a great
so we have, a formal thank you for you.
Yes, sir. So here we have a small token of appreciation from our side. Thank you so much, sir.
Thank you very much. Yeah.
So we'll be continuing the session after a short break. The next session will begin at 12 p.m. Thank you, everybody.
Thank you.
Thanks.
Okay, are you ready from your side, Chengappa, Dikshita? Okay, great. Sure. Good noon to all of you. As a session chair and organizing committee member of IEEE Bangalore Section Industry Relations Committee, a hearty welcome to the second session in second edition of IEEE BTC 2021. IEEE Bangalore Technology Conclave is a flagship event of Bangalore Section, which this time we are organizing along with women in engineering and young professional groups as well. The theme we have chosen for this particular conclave is Clean Technologies for Sustainable World. Some of you already joined the first session. We successfully completed the first session of Smart Tech today morning, covering various aspects of smart transportation, renewable energy aspects. In this particular session of Smart Tech, we are going to focus on ICT for clean technologies. We plan to cover the role of ICT, information and communication technologies, in the clean tech across industries. We try to cover, we have experts from power sector, renewables, telecom, and sustainability aspects. We try to address what are the real challenges and opportunities in this space, both global and local perspective as well, as our aim of clean tech is to improve the environmental sustainability. We are progressing one side on the technology, but it should not damage the environment per se, right? That's the main aim of the clean tech. We have lined up an excellent set of experts. Already a couple of them joined already for this session, representing various global organizations, sharing their insights and thought-provoking ideas. We have a packed session this time. So compared to the other sessions, we are talking about going to run close to 4 hours. We have a packed session with 2 keynotes, followed by 4 invited talks and a panel discussion in between as well, moderated by Narayan. Without further ado, let me start the first keynote session with our well-known Rajiv Lai. Dikshita, could you please flash the slide for introducing our expert? Over to you.
Yes, sir. So, very good afternoon to everybody. Our first speaker is Reji Kumar Pillai. Reji is the president of India Smart Grid Forum since its inception in 2011 and is also the chairman of Global Smart Grid Federation since November 2016. He is an internationally renowned expert with nearly 4 decades of experience in the electricity sector in diverse functions covering the entire value chain and across continents. He is actively advocating for the Right to Electricity Act that will ensure lifeline supply of electricity to all citizens in India. His current areas of research and work include grid integrated vehicles, district cooling, electric cooking, smart grids as anchor infrastructure for smart cities, grid interactive buildings and campuses, artificial intelligence, robotics, and blockchain applications for utilities. He has also contributed to several articles, books, research reports, and white papers on a variety of topics. A warm welcome to you, sir. Over to you.
Good morning, good afternoon, good evening to all the participants from around the world. I thank IEEE for inviting me to make this keynote today. It's really an honor, and also would like to ask many of you active in IEEE know Professor Saifur Rahman, who is from our subcontinent, is the new IEEE president. That is a matter of honor for all of us in the subcontinent. And Professor has already written to me promising that he will be working very closely with ISGF as well as the Indian chapters of IEEE. So March he promised to be here for our event. So we do an annual event which is India Smart Utility Week, which most of you are aware of. I can see Professor Mandiram here. So he been for our programs 2-3 times. In fact, the last major event which happened, physical event which happened in India was our program, which had about 1,600 to 1,800 people in the first week of March 2020. Thereafter, no major conference or workshop happened. Now, when we invite people for digital platforms, people are sick and tired. They say that for last 1.5 2 years, we are only doing online. So we physically want to see. So we have been talking to different stakeholders who participate in our program, and March we are now having a rethinking whether we could do, provided all this travel rules are eased, the vaccine politics comes to settle by end of the year, we may be able to get everybody in one room in Delhi in the first week of March. So coming back to the theme, the energy transition, it's appropriate that we are talking about this topic in the eve of COP26, which is starting next week. Even our Prime Minister is leaving today for COP. So we are expected to make some very big announcement that we don't know what exactly it is going to be. There was some rumor that 450 gigawatt of renewable energy target we set for 2030, that may be enhanced to 520. That's one talk which is going around, nothing authentic we know about it. So coming back to the energy, the life on Earth is driven by energy, and in the solar system, the only source of energy is sun. Autotrophs have the capability to absorb solar energy directly, and heterotrophs, that is animal kingdom, we steal it from autotrophs. This happened as in the course of evolution, as autotroph developed better methods to absorb sun's energy and store it on Earth. Heterotrophs mastered the art of stealing it more and more. But still some balance was there. And the balance started disrupting about 400,000 years ago when Homo erectus in China, they learned the art of controlling fire. They started using fire for making tools, for scaring animals, for cooking meat, basically cooking meat. By cooking meat, the time taken to chew meat, that has come down drastically, and that gave Homo sapiens more time to engage in other activities. And this consumption of energy outside of a species body is done only by Homo sapiens. It is called extrasomatic consumption of energy. No other species consume energy outside of their body. And this extrasomatic consumption started with controlling fire 400,000 years ago. This has led to Homo sapiens emerging as the master of this planet. David Price, in his very famous essay, Energy and Human Development, he estimated that time, it's about 25, 27 years ago, that time the total population was approximately 5 billion people, little more than 5 billion people. So he estimated that the total energy consumed extrasomatically by human beings on Earth is equivalent to the work of some 25 billion people. Sorry, 250 billion people. So each person having 50 energy slaves, and in advanced societies, each person having like 200 energy slaves. So this also, even 400,000 years ago to last 200 years or 150 years, things were still, some balance was maintained. But post-industrial revolution, they started changing. The entire balance started changing because of we multiplied several times our extrasomatic consumption of energy. And last 20 years, we have been Kyoto onwards, we have been talking about emission reduction, but nothing much has happened except shifting the post. And now everybody talking about a net zero by 2060. And in Paris, we all talked about certain NDCs, nationally determined commitments by 2030. Now the goalpost is moving to 2050, 2060 with net zero. So what will finally happen at COP26, we will see in next 2 weeks' time. So as part of the decarbonization program of the planet, the commonly accepted philosophy is to electrify everything, electrification. Electrify as much as human activities, including transport and agriculture and other activities as possible, electrification, because electricity is the cleanest fuel at the user end. So, and then take the power sector and decarbonize the power sector. This is, or the entire energy sector. So the other fossil fuel which we use for transportation and other areas, we are electrifying, and take the electricity sector and decarbonize it. Today, majority of the electricity generation is from coal and oil. And gas. We move that to renewable resources. So you heard a lot about the previous session. When I joined, I was hearing a very good talk on battery technologies, and I'm sure there are more experts here, including Professor Mandiram will be talking about that. So I talk about the application of all these technologies in the power sector for decarbonizing. So as part of this decarbonizing the power sector, we have to increase the use of renewable energy. We have to reduce the use of coal and oil and gas, and we have to retire fossil fuel based power stations and reduce the use of other kind of energies. And what are the challenges with the renewable energy? There is enough of sun sources. Technology has become cheap. Last 25 years, particularly last 10 years, the prices have come down, like lithium ion batteries or solar panels prices have also come down drastically. And for most categories of customers today, producing solar energy is economically attractive. In India, average customers, middle class customers, those who don't enjoy any subsidy from the government for electricity consumption, they pay 8 to 9 rupees per unit of electricity. And the cost of 1 kilowatt system, including inverter, is $500 to $600 today. The return on investment is 2 to 3 years. So awareness is not there. We can actually do a large revolution on solar rooftop PV itself, and that if we are able to integrate that with the grid successfully. What are the challenges in integrating solar and wind because of its intermittency? Particularly wind, when it stops, when it starts, nobody has any control. Solar, when you look at the solar generation graph, you see a daily graph, which is a smooth graph going up and coming down. But if you take 1 minute, 2 minute graph, you can see spikes. Today in the power system, we are not bothered about it because it is taken care, smoothened by the PV output is smoothened by the other power system, which is the majority of it, 90%, 95% of the power, most part of the power system is from large coal, oil, nuclear plants. And we keep a spinning reserve also to take care of the intermittency of the RE systems. But in several geographies that has changed. 20%, 30%, 40% renewable energy is coming onto the grid. And the phase of this development, how to do integrate this, has become a major challenge in many places. So this is one of the IEEE studies says that in the journey of renewable integration, it goes through different phases. There are a couple of states in India like Karnataka, Tamil Nadu is already in phase 3, where power system operation need to be taken care based on the RE generation, particularly distributed RE generation connected to the grid. There is absolutely no control today. And many of these things are getting connected to the distribution grid where there was only load in the past. I will talk about that grid architecture a while later. So integration of renewable energy with the grid require some certain amount of forecasting. How can we forecast solar and wind? 10 years or 12 years ago, when California adopted that 33% renewable energy by 2020, most grid operators had a heart attack. the maximum spinning reserve which is kept anywhere in the world is 10%. So how can we take care of it? There was no technologies which grid operators could immediately think of, which was commercially feasible to integrate 33% of the renewable energy onto the grid. But 5 years down the line, new technologies came, the storage prices came down, and today we are talking about 100% renewable. There are many reports, there are many roadmaps for 50%, 100% renewables. And only when you set a target, like President Kennedy had said that we'll put a man on the moon by end of the decade in the early 1960s, several new technologies got developed during that decade of 1960s. Same way, when we say that 100% renewable energy in most part of the world, many new technologies will come. So the solar and wind forecasting package, which some of the companies which had started with IBM and many other small startups, they have all today with a 90 to 95% accuracy, we are able to forecast a day-ahead basis solar and wind generation. And this was not possible even 5-7 years ago. And these are all possible because of the confluence of different technologies coming together. So again, IEEE has released a report recently, a global energy outlook, but an India specific report they had released early this year in February that estimate our current power system, which is third largest in the world, more than doubling to 826 gigawatt by 2030, and again almost doubling to 1589 gigawatt by 2040. And out of 1589, they estimate 869 gigawatt is going to come from solar and wind. And just imagine the amount of flexibility we need. And they estimated the maximum flexibility is required for the Indian grid, whereas the US, China, European grids require less than 50% flexibility. Indian grid needs 85% flexibility plus 50 minus 35. That's the IEA estimate. And nobody been talking about it. Last 2 years, we've been talking in every forum how solutions to increase flexibility on the grid. Last year, first week of April, when I think 5th of April or something, Prime Minister told the people to switch off the light at 9 p.m. for 9 minutes. So grid operators were really worried how it will happen. So we have shown that at least the transmission grid has a flexibility of 30% plus but that had more than a week for grid operators to plan that. And in this 85% flexibility which you are talking about, it is a daily or hourly, anytime it can be it need to be ramped up or it need to be ramped down. So that is something which is very, very difficult, and digital technologies are going to play a central role. So some of the solutions which we have been talking about is building distributed storage. How can you increase the distributed storage commercially viable route? So we recently published when I say we, it's India Smart Grid Forum. So we recently published a white paper which is replacement of diesel generating set with lithium-ion batteries. By one estimate, India has more than 70,000 megawatt of large capacity DG set. And incidentally, today, 1 kilowatt hour of electricity generated from a DG set cost more than 29 rupees. In our report, we had considered 95 rupees for diesel last month. Now diesel in many places are more than 100 rupees. So 29 rupees 7 paise or something is what we calculated as 1 kilowatt hour, 1 unit of electricity from a DG set. And lithium-ion battery storage, when we do that, the current prices which we everywhere we hear about $100-$200 per kilowatt hour plus the power electronics, the whole system, when we calculate at $300 to $350 per kilowatt hour, and buying electricity commercially at 8 rupee from the grid, storing it on the battery and pumping it back, that price comes to below 15 rupees, 14 rupee 35 paise something is the number which we have in our studies that report. So many cities in India, including the National Capital Region, NCR, the National Green Tribunal in 2018 issued an order banning the use of DG set from October to March. It has not been complied. The implementation of that order is still very limited. Everybody uses, in case of a power cut, everybody uses DG set still. But and as many of you read about the pollution levels in India, 14 or 15 most polluted cities in the world are in India. So many cities, I understand NGT is going to ban use of DG sets permanently, and all new infrastructure, when we say that as a standby power arrangement, it should be battery storage. A typical DG set comes into operation only when there is a blackout, there is a power cut or a load shedding, and that may be few hours in a month or few hours in a year. The rest of the time you maintain it like there. But a battery which is connected there, it can offer grid services 24/7. That's a great asset. It facilitates more renewable integration. It has several advantages. I won't get into the details of that. So another program which the government of India launched last year is irrigation pump set solarization. Farmers, there are millions, even in Karnataka, there are a couple of million irrigation pump sets. Total India, some 20 million plus irrigation pump sets, which are ideal candidates for solarizing, and along with batteries. There could be third-party operators who will come. The government of India plus state government give 60% grant for solarizing the irrigation pump set. 40% need to be put in by the farmer who are not interested because they get free electricity anyway. So what we have been advocating is that bring in third-party aggregators who will invest in the solar panels as well as in battery systems, and the electricity which is not used by the solar output which is not used by the farmer require less than 50% of the electricity production from a system in a year, that they should be allowed to sell it in the market. So these discussions are going on, and cooling is another biggest challenge in India. So we have been advocating that district cooling system should be promoted instead of today. Some report says there are only about 5% of the people households have access to cooling or room air conditioners. There are about 38 million, and some estimate says that by 2040 we will have 600 plus million room air conditioners and over a billion air conditioners by 2050. Those are going to increase the load on the grid, and that is not a sustainable. And when you have room air conditioners in every room, outside of it, it creates local heat pockets, which make the life hell for people, those who don't have access to cooling. So district cooling systems are successfully done in many countries, and in India also we have in Gift City in Gujarat. There is what district cooling system does is produce chilled water at 5 degree or 4 degrees centigrade in a centralized plant, and circulate that through insulated pipe to different buildings, and each building the air handling unit take the atmospheric air into the building, passing over the chilled water pipes and air conditions, that the total air electricity consumption come down. The advantage why we are advocating for that is because chilled water can be produced and stored, and it can give a load relief. It can be a load for the grid when required. So most DCS systems comes with large, very large uh, chilled water storage tank, which is a thermal storage, which can be successfully integrated with the grid. Same with of late, everybody talking about the hydrogen, green hydrogen. When green hydrogen is produced through electrolyzers, which again gigawatt scale electrolyzers are being planned in several countries. That is again a very good load as well as a load relief. Today with the renewable energy, scaling up of renewable energy, in many times during the day, we have surplus electricity, and which can important thing which are become electric vehicles did not come with grid interactive this thing. It was only one way storage of electricity from the grid. Battery stores, battery uses for the transportation needs. But the same technology, we can pump the battery back, the energy stored in the battery back to the grid. Those technologies been used in some of the, demonstrated in some of the universities and research labs for years. We have been at many forums like in the ISG been advocating for that in the AC charger where the slow charging takes place. You go to your office and you plug in your car, you should be able to offer the grid services, or in not in the DC fast charging, the public charging stations, but in the offices, residential complexes, and other places where the AC slow charging happens, we should have V2G feasibility. And this is now becoming a reality. New versions of the vehicle which are going to be announced in 2022-23 are all going to come with V2X. You can take AC power out of the vehicle, integrate with that. And this is going to be a great boon for the distribution grid, where the rooftop and the electric vehicle both are connected to the low voltage segment of the grid, and both of this can integrate and support each other. When there is a sudden drop in the PV generation, the battery can support the feeder. The low voltage will not happen there. Similarly, when there is less load during the day on the grid from the buildings, the surplus generation can be stored in the batteries of the vehicle which are connected to this. This is all possible today with digital technologies and appropriate communication systems. EV grid integration or grid integrated vehicles is now becoming a reality, and a large number of vehicles which are connected to the EVs connected to the grid can be aggregated as virtual power plant, and that can defer investment in generation, transmission, and distribution for several years. And this is something which you will see very soon. And smart microgrids, I believe there should have been sessions, otherwise people will be talking about the microgrid. Ideally, our idea of a microgrid is a very large building with self-generation capability and storage and electric vehicle should be with have a form a microgrid, smart microgrid, which can island from the grid when required. It could be even for price arbitrage, when there is going to be prices which are going to be time based or real-time pricing for electricity, peak hour when the price is going to be high, the building could disconnect from the grid, consume the essential applications from the stored electricity or from the vehicle batteries which are connected to the building, or even sell back to the grid at a higher price. And when the price on the grid is less, buy and store it. This is going to be at a later date, maybe in 5 to 7 years, the smart appliances which are going to come in. Even you can program your smart appliance to buy electricity from the grid at the cheapest rate or a cleanest electricity available on the grid at the cheapest rate, and run it. Your washing machines, your rice cookers, your water pumping, even your refrigerators, all these smart appliances which you could even monitor and control sitting remotely. And that is exactly which is the role of ICT in this energy transition, the smart appliances and smart infrastructure which are going to control and balance the power generation from distributed renewable resources as well as the consumption. So many other applications we have been talking about it. One is the dynamic energy market. There's a lot of people who want to actually buy green electricity. In US, there is a REBA, Renewable Energy Buyers Association, promoted by Rocky Mountain Institute, actually. And in India, we have been talking about it. A few months ago, Maharashtra Electricity Regulatory Commission issued an order based on a Tata Power request that if any customer wants green electricity, they should be given access to that, and the licensee, that is the distribution company, can charge a premium for making that available. So it has not started yet. We have done two pilot projects, one in UP, one in Delhi, a peer-to-peer trading of electricity, particularly rooftop solar energy, on a blockchain platform, along with a technology company from Australia. ISGF implemented these two projects successfully. And UP now, why we selected UP? Because we wanted to do it not in Delhi or in Calcutta or somewhere where it's a private company is there. That when you go to the DISCOM owned by a state government, there things are different. And we have done that very successfully there, and that project is also operating. The regulator has taken note of it, and they have issued the tariff order issued in July this year. They said the same system may be made available to the consumers across the state. So several of these things which I talked about, to control all that, there is a new solution which it's not new, it's been there, but India, nobody has done it yet. Distributed energy resources management systems, DEMS, That's a platform which is gaining acceptability, and some people are developing today on fleet energy resources management systems. And another very important technology which you will see is synthetic inertia, which more and more of renewable energy connected through inverter connected systems, which is coming on the grid. The traditional inertia we are losing, and for which synthetic inertia is a new technology which will again becoming commercially attractive and available very soon. So two major challenges here will be: one, nothing smart will work without reliable communication systems. Communication going to play the key role, particularly in a grid which is spread over very large geography. Not one technology, we leverage all technologies for reliable communication systems. And cyber security is going to be the another major concern. With millions and millions of uh, smart connected devices with the grid, cyber security of the grid is going to be a major concern. And incidentally, 2 days ago, Prime Minister in the ASEAN meeting, he talked about the importance of that. And October is a Government of India declared as a cyber security awareness month, October 2021. And there was some one-day seminar yesterday organized by CEA and NPTI. So I spoke yesterday there on cybersecurity. So I will stop here, and if there are any important questions, we'll be able to answer if you have 1 or 2 minutes.
Thanks, Reggie, for walking us historical moments, right, from 400 years to ISGF initiatives and mainly the challenges which you put forward, right? In the interest of time, maybe we'll take one question. So what do you see the smart grid implementation, be it at a distribution side, let's say the smart meters? I heard of it a couple of years ago. So what happened to the real implementation on the ground?
This is, I'm very happy to say that the Government of India has taken that very seriously. There's a program which has been recently launched. It's called RDSS scheme. So result oriented something, has a long abbreviation of a program which is 3 trillion rupees, of which about 95,000 crore is reserved for giving grant. A portion of the money will go as a grant from Government of India to distribution companies for implementing smart meter. 100% smart metering for about 25 crore customers in the country, or 250 million smart meters. They have excluded the agricultural connection, all other thing will be. So there is a standard bidding document prepared by Ministry of Power. About 15% of the cost of the system will be given as grant from Government of India. You will ask what will happen to the 85% of the money. The model which is proposed is that will be a services model. Instead of discoms, the distribution companies buying and maintaining it, we had proposed a system 4 years ago. ISGF white paper, we said that discom will find it very difficult to buy the right system and maintain it properly. So it should be a services model wherein a technology company comes and do the smart metering and maintain it for 10 years, and they should be given X rupee per meter per month. So this 85% of the cost will be a monthly fee for 10 years.
Subscription kind of a fee.
Yeah,
great.
Absolutely.
Thanks a lot for your insights, Reggie. On behalf of IEEE Bangalore Section, it's our pleasure to host you today.
Good to see Shiv here.
Yeah. Hello, Reggie. Nice to see you again.
It's a small world.
We'll catch up. Thank you. Thank you.
Yeah,
have a good day.
Next, could you please present the official thank you note?
Thank you so much, sir, for sharing your valuable insights on role of ICT in energy transition. It was a really great session. So here we have a small token of appreciation from our side. Thank you, sir.
Thank you. God bless. Bye.
Thanks.
So, thank you, sir.
Thank you, Reggie. Thanks a lot.
Yeah.
On.
So
the next talk is on the
Go ahead, Dikshita. Yeah.
The next talk is on the software and AI-driven future of renewables by Shivkumar Kalyanaraman. Shivkumar Kalyanaraman is CTO of Energy and Mobility Sector at Microsoft India. He is working towards building a global industry platform as a service business for Microsoft's Azure, including end-to-end technical business strategy, execution, and strategic partnership responsibilities. He was previously executive GM in GE Power Conversion. Shivkumar Kalyanaraman has developed and led industry solution teams involving the transformative digital technologies. He has also developed and delivered industry solutions in areas such as energy and utilities. He has over 200 plus peer-reviewed technical papers, 35 plus patents granted, and he is also the IBM Master Inventor Awardee of the year 2017. A warm welcome to you, sir.
Thank you.
He's our IEEE fellow. I think that's the important one which we missed out. So welcome, Dr. Shiv, for this.
Thank you. Yeah.
We'll share the presentation as well. Yes, we can hear you and see you as well. This allows 20 seconds to flash your deck, Changappa.
Sure. So while the slides come up, my talk will complement what my good friend Raji talked about. So Raji, really nice to see you again after our days at IBM together. And so he set the stage perfectly. What I will talk about is I will focus more on renewables and which is driving the change in decarbonization. And as we drive for greater renewable penetration and deep decarbonization to address climate change, I will make a case that the role of software and AI is going to become a lot more important than we realize today, right? So it's not just about hardware and so on, and many of the things that Raji talked about, like communications and pieces of the smart grid, but the role of software and AI is going to become critical in the future. So that's the simple story I'm going to take you through. So without further ado, let's go to the next slide. So just to recap for everybody's knowledge. So as we all know, there is COP26 climate summit coming up very soon, and there are, whether it's companies or countries, everybody's scrambling to make net zero type commitments, which means at some point in the future, 2040, 2050, 2060, they would like their country or company to go net zero, which means their emissions to drop below zero, right, or cross the zero line. And if you take the world as an aggregate, if you keep going business as usual, you are going to keep increasing the emissions, and then ultimately it'll peak and come down sometime in the future. However, if you look at the targets agreed in Paris in 2015, you want to go below 2 degrees centigrade, which means a very sharp drop in emissions. And that drop is associated, and then reaching net zero, if you look at the y-axis, at some point that red line crosses zero, right? But if you look at most of the emissions, almost 75% of the emissions, GHG emissions, can be traced to some form of energy use or the other, right? So, and if you look at from a technologies standpoint, there are abatement technologies like wind and solar and things like that. And then there are avoidance technologies such as electric mobility and so on. So you're avoiding future emissions. And then there are negative emissions technologies, which include carbon capture, storage, direct air capture, things like that, or planting trees or natural solutions, stuff like that. Okay, but overall, the key message here is that, we are trying to achieve both a significant change in trajectory of greenhouse gas emissions, specifically if you think of carbon-based greenhouse gases like carbon dioxide, methane, and so on, deep decarbonization, right? So over the next few decades. So what is the implication of deep decarbonization, right? All pathways of deep decarbonization involves, some combination of the above, right? You want to drive significant electrification of energy. That is, the energy use doesn't come from fossil fuels, but comes from electricity. The second is the source of electricity comes from zero carbon or low carbon sources such as renewables, and the demand side of things like vehicles move towards electric mobility and so on. Of course, there are harder to decarbonize sectors like industries and agriculture and other areas, right? And negative emissions technologies have a role to play. So keep this in mind. So deep decarbonization, how do we bend the curve of decarbonization? And usually that involves electrification and decarbonization of the electric utility fleet, right? So let me go to the next slide, please. So given that, one of the drivers of this is not just government support and policies and so on, but it's been the incredible drop in costs of some of the component technologies like solar, wind, and so on, right? Solar, wind, batteries, etc., have become cheaper and cheaper. through a combination of technological innovation, through a combination of manufacturing processes, and more deployment leads to learning. These are called learning curves or experience curves that keeps lowering the cost. So what it means is that on an average basis, or something called levelized cost of energy, they have already in several cases come parity to fossil fuel alternatives, and increasingly this trend is likely to continue. So one obvious question in your mind would be, hey, you're trying to bend the curve. All the future deployments or more of them will be of this type, right? Because these are becoming cheaper and also absolutely cheaper, and reduced policy support is required. So why doesn't it naturally happen? Why do we have to do more, right? So let's go to the next slide. So the key thing to note is that cheaper is not enough, and we'll come to that. And so the key part of it becoming cheaper is, and you can reduce policy support. So policy has helped to jumpstart the whole network. You've gotten to a critical inflection point. And now you're going to see, as you can see on the left graph, the fraction of resources like solar and wind are going to dramatically increase on the grid over the next few decades. And the overall amount of electricity, if you look at the top two circles, from around 7.5 terawatt, you're going to go to about 20 terawatt. So the electrification trend is captured in the top diagram, and the bottom diagram shows the decarbonization of the electric grid. So there is a simultaneous increase in use of electricity, there is more electrons, and the simultaneous decarbonization or the thing, right? So this is like a double growth of solar wind that is being implied here. Similarly, other resources like electric storage or cars, electric vehicles, and so on are going to see tremendous growth, right? So there's growth. So what's the problem, right? So next slide. So you can think of this as sort of the hardware of the thing. So what's the role of software? Why do we need software? So the key thing to remember, and this is an important slide, is that cheaper and getting cheaper is not enough. So, and yes, through learning curves, we'll continue to see cheaper and cheaper renewables, cheaper and cheaper storage, cheaper and cheaper electric vehicles, and increasing penetration. But increasing penetration itself is going to cause some very interesting problems. So if you look at this graph I borrowed from the previous slide over here, I call everything before 2020 as a honeymoon period of renewables, right? So if you look at the honeymoon period of renewables, if you look at the orange part and the blue part, it's a very small fraction of the grid on aggregate, right? About 10% or whatnot, right? So if you, but the key thing to notice is that solar and wind are variable renewables. In other words, they will, as the sun shines or wind blows, it will generate electrons and then pump it into the grid, right? Now, if the total amount of solar and wind is small, that variability that it causes is small relative to the aggregate demand. And that variability can be absorbed, okay? And it can be treated in policy as what is called negative demand. Just like you have positive demand for electrons, negative demand for electrons means you're pumping electrons, right? So you can treat solar and wind like pumping electrons. You can give it preferential treatment, and anyway, its marginal cost is zero. All that is goodness. However, this situation becomes tricky as it becomes a larger and larger fraction of the grid. When it becomes 20, 30, 40% of the grid, the volatility or the variability will start dominating the grid. Okay, so think of it like a freeway and so on, right? When you have more traffic, you suddenly will have a traffic jam. Okay, and less traffic, the traffic will flow smoothly, right? But in a traffic jam, there's an implicit thing that traffic can back up, and you have some sort of a storage, and you can store these cars, either in the on the road or somewhere. But unfortunately, in the grid, you cannot store electrons, right? So the challenge is that so the grid is like a real-time supply chain that needs to clear every millisecond or second, and you cannot store. And of course, storage is increasing, but it's an extremely small part of the grid, right? So what is important is that demand and supply needs to be better matched, and any source of volatility that becomes dominant, like solar and wind and aggregate, will start causing all kinds of problems in terms of stability of the grid, and it will not be well matched to demand, right? So so this is driving a lot of changes in the industry. Okay, not many are fully appreciated, and one change is that in the honeymoon phase, renewables used to get what is called long-term contracts. So you set up a solar farm, so either the government, federal government, state government, or utility, or maybe a counterparty in the corporate world like Microsoft or somebody will set up a very long-term contract for 25 years, right? So you set up a farm, you get a 25-year contract, and whatever you produce, whenever the sun shines, wind blows, I will pay you. Okay. This is very interesting to observe that if you consider an airline business or like a hotel business or even the oil and gas business for today, right? When somebody buys a plane, right, you don't sell all the seats for the next 25 years. In other words, you don't have a long-term contract for the next 25 years. Similarly, if you buy a hotel like Hilton or whatnot, right, you don't sell out all the rooms for the next 25 years. So whereas renewables has been getting this sort of special treatment because it's been a fledgling industry. So if you go out into the future, even oil and gas, when Shell or BP or somebody sets up a large oil rig, they don't have contracts for the next 25 years. So the future is going to be more real-time, market-linked, spot-linked, short-term contracts, medium-term contracts, and essentially this commodity, the perishable commodity, which is the electricity produced, will have to be matched to demand better. And that matching is going to happen in shorter and shorter timescales. And even in the context of longer term timescales, there will be a demand matching clause that will be there. Like, for example, there are new contracts out in India called round the clock contracts, and in other markets it's called 24/7 power purchase agreements. What it means is that the demand and supply has to be matched. And if you don't match it, you will not get paid. In other words, if you produce demand and there's in some parts of India, we call it also banking facilities have been removed. So if the demand and supply are not matched, that supply, those electrons will not get compensated. So the key thing to remember is from a supplier perspective, the matching responsibility with demand is being increasingly moved to the supplier. Earlier, in a long-term contract, you would just produce electrons, give those electrons to the demand side and say it's your job to match it. Whereas now that job of matching, it comes back to supply. This is a very subtle but very important point to remember. And this can happen either within the context of a long-term contract or a PPA. It can happen in electricity markets. It can happen through specific resources like storage and so on, which can allow time shifting or space shifting of electrons. And of course, aggregated constructs like what Reggie mentioned, distributed energy resources or virtual power plants and the like, right? Or any other source of flexibility. Even electric vehicles, they can actually be smart in when they charge. And how much they charge, right? So, when the grid is overloaded, they can actually cut down the amount of charging, for instance, right? So they don't necessarily have to send electrons into the grid. Even being smart and when they actually present the demand to the grid can cause a huge difference, right? Especially as electric vehicles become large. Okay, anyway, I think the key points is that there is going to be value deflation and payments associated with the matching. If you have excess supply in the wrong times or unnecessary volatility, excess volatility, you're going to get penalized for it. Okay, so this matching and orchestration, if you step back and ask, this is nothing but what Uber does or Airbnb does, or if you look at say Booking.com does in terms of tickets for hotels, or airline tickets like Make My Trip does, and so on, right? So this is really a software platform problem, right? You have to figure out when are your perishable resources going to show up, the commodity going to show up, and you have to predict it. You have to sort of match it to demand, and that demand supply matching is intermediated through a wide variety of markets, right? Next slide, please. So, if you look at it as a money-making entity, future money in renewables, the easy money has been made. Now the business is going to get harder, and you will only make money if you are able to match it to demand, and that's called monetization, right? So that monetization is going to be a software problem. It's AI-driven. Right. And what this means is you have to monitor when your supply is happening, monitor when the demand is showing up, either through directly or through markets. And then you have to forecast supply, forecast demand, forecast, and orchestrate your assets to produce when demand exists. Just like Uber and Lyft and so on, they orchestrate assets, or Ola orchestrates assets like cars, or, if you look at Airbnb, orchestrate perishable assets like room nights or whatever, airplane tickets, and match it to demand, right? So that's why in an airplane, you are in two different seats, but both the seats look alike, but you might have paid very, very different amounts. So the monetization on that seat mile or that seat trip is very different for those things. So this becomes a yield management software problem. Okay, so what I want you to think is that it's no longer about all the hardware. Of course, hardware has to keep growing and so on, but that hardware, whatever that produces, the asset, whatever it produces, that perishable commodity will get paid only if it's matched, and that matching is a software problem. Next slide, please. Okay, so what this means is that, there is also a key relationship to the economics of renewables players. Unlike the coal and natural gas and other thing, there is a very sort of, I would say skewed economic structure. You have a very high upfront capex, which needs to be financed, and then a very low OPEX or operations expense, lower than 2%, almost lower than 1% in several cases of capex per year. And there's a very long-lived assets for 25 years, right? So given this, what it means is that if your sales can increase even in a small way, okay, since you have very high gross margin and most of the other costs are fixed, that increase in sales, let's say 1% increase in sales, will lead to almost 0.9% increase in net margin, right? And if your net margin is only 10%, it means on a relative basis, there's a 9% decrease in net margin. So the reason I'm telling you this math is that there's a huge improvement in your profitability with small improvements in sales, and it also cuts the other way. You don't want you have to manage your risk of downside in sales going forward, right? In the honeymoon period, your sales was guaranteed. In the post honeymoon period, your sales has to be built up, and it has to be built up through software and AI. So software and AI and digital are going to become fundamental to even survival in renewables in the future. Next slide, please. So some of the things that Microsoft is doing and so on is, of course, in a cloud business, you have things like IoT and so on, measurements and reliable IoT, all of that can come together. But once the IoT data comes from different sources, it's important to bring the demand and supply side together and, sort of match it on a 24/7 basis, hourly basis, minute by minute basis, or 5-minute basis and so on, so that you can do accounting. When was the supply there? When was the demand there? Did it match or not, right? This is a simple example of an accounting. And then you can look at, hey, when was carbon emitted? When was carbon not emitted? And this is called emissions accounting. And then you can orchestrate these resources, account, and then clear contracts and things like that, right? And you have to be able to have this in an auditable way and enterprise class way and so on, right? So these are simple examples. And this will also allow you to have more complex power purchase agreements to be designed as well as delivered, right? So for example, one of the interesting things Microsoft has done is we have a distributed PPA where we aggregate a lot of distributed solar resources in, this is in UK and Dublin in Ireland. And then we have a PPA our data center gives to them, right? So rather than having a centralized farm that sells to data centers, we actually aggregate a distributed set of resources and we can have a PPA against that, right? So it's a very unique business to business PPA. So these are examples of innovations in the PPA structure, and it also has this attribute of 24/7. And as you have storage, you can sort of also match it to emissions optimization so that we can focus on actually reducing the emissions on the grid and giving the right price signals, right? So these sorts of innovations can be done through value-added, data monitoring and IoT and other technologies. Next slide, please. So the next thing you can do beyond all this accounting and data value addition, next slide, please, is forecasting and optimization. And once you have data and you have real-time data and so on, and historical data, you can use big data and AI technologies like deep learning and so on to figure out how the wind is going to blow, how the solar sun is going to shine, how the power is going to get produced. And this is very non-trivial. And people have, there is forecasting, there's forecasting. So to get really good forecasting, trust me, it's an extremely difficult task in this area. And once you have forecasting, not just of the average power produced, but also how the ramps are working and so on, then you can use that information to orchestrate your resources. You can determine which part of that power goes into storage, which part you can sell into something called an ancillary services market, which part you can sell it to day ahead market, intraday market, capacity markets, and so on, right? So this allows you to convert data in or fundamental uncertainty into more like a measurable risk with probability and other distributions. And then you can start having this risk management area. So this entire area is going to become a lot more market oriented, a lot more financialized than we realize today. And there are many markets that are popping up in different parts of the world, including in India, across these various time scales, right? If you look at the diagram on the bottom left, it just says that there are different types of markets that are at different time scales. You can do matching at a second or sub-second time scales. Those are called ancillary services markets. You can do matching the minutes and hours time scales. Those are called intraday and day ahead markets. And then beyond that, you can have, of course, longer term matching a few days ahead. It's called term ahead markets and capacity markets and so on. So watch out for markets and multiple markets, and how do you optimize your resource across multiple markets is a very difficult decision problem under uncertainty, right? Let's go to the next level. So once you have risk management and uncertainty management tools available, then you can start orchestrating a hybrid set of resources to match it to these markets, right? So you have resources like storage, you have wind farms, you have solar farms. You may have some wind farms in, say, Rajasthan. You may have a solar farm in Ladakh. You might have some hydro resource in Himachal, et cetera, right? How do you orchestrate a distributed portfolio to map it to these thing? Or you may have off-grid, sort of what I call microgrids, things like that. Or even in a single farm, as is shown in some of these pictures, you may have wind and solar together, and the wind might actually be causing shadows in solar. They may be, how do you sort of orchestrate both of them together? You may have some storage resources, or even if you have offshore wind farms, one of the big problems in offshore wind is, one wind turbine can actually shadow the other wind turbine through turbulence, which is called wake effects. And management of wake effects, especially in offshore wind, is a serious problem which is being looked at. And many of this involves dynamic controls, right? So these are called power plant controls or so on. So one trend that is happening is that normally in control loops, you have very short control loops and local control loops in the operations technology or OT domain. So one new thing is happening is that these control loops are starting to embed AI. So just like you have IoT and AI for observability, now AI is also starting to show up in controls, and that is called reinforcement learning technology, deep reinforcement learning technology. And so it's all data-driven control loops are starting to show up. And this is a new for a future of controls, AI-driven controls that is starting to emerge, right? And this can happen across multiple timescales and milliseconds, seconds, minutes, and beyond, as well as over larger geographical scope, right? Like very large wind farms or across the country itself, right? So so this is a big transformation that is happening, and all of these technologies are improving rapidly as we speak. Okay, next slide, please. Okay, and once you have this, even some of the cloud technologies itself can start behaving like flexibility resources. Okay, if you take a server or a rack of servers, you can actually increase or decrease computation on them. And similarly, you can actually turn on and off servers very quickly in the order of milliseconds. So one of the projects we're doing in Microsoft Research is to show that if you can take large enough data center chunks, this can actually behave almost like a battery, right? We call this a virtual battery, where you can have a very high speed, increase and decrease or ramp up and ramp down capabilities that can be done through batteries. And you can actually take the data centers, rather than keeping them far away, you can actually move them right to the point of the renewables resources, or you can put them at a transmission line or in substations and things like that in smaller form factors or mini data centers. And this is a future we are seeing. And to do this, next slide, please. What we are doing is to integrate a whole bunch of technologies that has been developed, including how do we allocate resources in a highly flexible way. So given the power envelope, your compute resources or the capabilities can change. And then how do you allocate that through, sort of operating system scheduling? We call these harvest VMs and other things. How do you allocate, computation across multiple virtual batteries to give new abstractions? How do you value stack across the energy complex as well as the computation complex? And of course, there are these data centers are going to be in remote locations where they can get connected. They may or may not be fiber connections. You can actually connect it through space, and you can sort of package them in interesting form factors such as containerization, and you can even use reused servers, older depreciated servers, right? So there are a whole bunch of technological innovations that we are in the process of packaging in this thing. But the key point is that computation itself can start behaving like a battery. So the purpose of cloud computing AI is not just to manage renewable resources, but to also become a battery, become a resource in this ecosystem. Next slide, please. So finally, bringing this together, Reggie talked a bit about electric mobility and so on. There's a lot of trends happening. But another dimension of digital and so on is in countries like India, our digital infrastructure is outpacing the growth of physical infrastructure. Like fintech, UPI, wallets, and all of those are growing rapidly. The cost of CleanTech, like distributed solar storage, is dropping rapidly. Geo and all these developments are the cost of phones, the cost of digital connectivity is dropping rapidly. AIML technologies are dropping rapidly. So what we believe, and I have a long article on this on LinkedIn if you'd like to read it, is that we are seeing a nexus of these three things. And as you can see, these are all digital technologies. These are all AI technologies that are coming together. And the future of electric mobility, right? Whether you want to finance electric vehicles, whether you want to have new business models, like we talked about a subscription model in the last talk, or as a service models. These can all be intermediated through a combination of IoT, sort of cellular connectivity, and paid through finance, where you can collect on a day-by-day basis as opposed to a month-by-month basis, and of course orchestrate a bunch of solar storage and e-mobility resources like charging in vehicles and things like that, right? So what we see is that these ideas of orchestrating resources extend not just from renewables but also to these domains, right? So finally, that's the last slide I have. If you can just go to the last slide. So overall, I think the message I want to share with you is that the future of the future is very rosy. You have the lower and lower costs of the hardware, whether it's sort of renewables or e-mobility or storage. That is a huge driver. But the future is going to be equally, if not greater, driven by software, especially as the penetration of these technologies increase, and to even guide the penetration. And we need to push for these high speed penetration, because if you want to really bend the curve that I showed you in the first slide of saying you need to accelerate adoption of these technologies. If you want to accelerate adoption of technology, you need more money to come into these technologies. And think of your own money, right? Where will you put more money? You will put more money where your returns are higher. So we need to be able to increase returns, and you can increase returns through software orchestration, right? So that's the net message I want to share with you. I think it's an exciting world for both hardware and software in the future. Thank you.
Great. Thanks a lot, Dr. Shiv. As usual, lot of things to capture. Thanks for highlighting the angle of software and the AI-driven technologies, right? Be it deep learning or be it deep reinforcement learning you are talking about, and a new thing, what is new term, maybe virtual battery, right? Be closer to the generation and the data center. So thanks for all these insights. I have one question. When you talk about the broad perspective, right? What is the focus of Microsoft India? Is it like, because you are maybe representing the cloud unit Azure, but is it talking about the main focus is of these building models is cloud centric, or you are building the models for the smart grid ecosystem as such?
So look, I am responsible for helping renewables take on a software role much faster, right? As part of our cloud business, right? So we do work with clients globally as part of this. So whatever technology we develop are globally, but at the same time, since I'm in India, I also work with several of our key customers in India to deliver these innovations in the context of India, right? India is a very interesting market because, as you said, the digital infrastructure is growing faster than the physical infrastructure, and also, there is interesting new challenges. So we work, with selected customers to deliver some of these innovations in the context of India as well. But the idea here is that, these innovations initially are trialed, but ultimately we become part of cloud offerings or platforms and so on. But overall, the goal is that, we want our customers and partners and others to really drive this, right? It's not just about Microsoft as all, right? The cloud is a vehicle or a platform to really drive all of this and really accelerate the digitization of the renewables industry, right? So that's the key message. And we believe the future is thing. And if you think of deep decarbonization or renewables integration, many of these problems are as much software problems as they are hardware problems, right? And as a premier software company, our goal is to help drive this innovation here.
Thanks for showing us the way forward and then insights. Over to you, Dikshita.
Thank you very much, everyone.
Thank you so much, sir. Thank you for sharing your valuable knowledge on software and AI-driven future of renewables. Here we have a small token of appreciation for you, sir. Thank you, sir.
Thank you, Dr.
Thank you very much.
So the next talk is on fixing the grid edge with open standards by Vish Kanti. Vish serves as the head of AutoGrid India and is responsible for leading the growth of AutoGrid artificial intelligence-driven flexibility management business, as well as the AutoGrid Energy Internet platform, which also champions strategic initiatives such as capital investment, growth, and partnerships. As a technology pioneer and a subject matter expert in DER IoT, Vish has a long track record of research, development, and deployment across the spectrum of smart grid applications. Vish has held senior roles at CPAR, Johnson Controls, and NRNOC, as well as leading innovative research at Lawrence Berkeley National Laboratory. A warm welcome to you, sir.
Ishita, thank you so much for that readout. It's been such a great honor, first of all, to attend this session, and the previous speakers, Shiv and Reiji, have done my job very simple. So they really set the stage for what the future holds in terms of software and where the market is going. So I'll just quickly share my screen, and what I will do is, in addition to the slides that you guys have seen, what I want to do is take some time out and show you some real data from some systems that I've been using at my house here in California, but also at the company here at AutoGrid. So quick overview about AutoGrid. So we manage about 6,000 megawatts worth of DERs around the globe. We're definitely a venture-backed company right now. And in the next slide, I'm going to talk a little bit about the most recent announcement. But we were born out of Stanford University and Lawrence Berkeley National Lab. And I was actually a professional scientist at LBNL at the time when this company was co-founded as part of an ARPA-E grant. So quickly, I'm really excited to announce that we recently had a $85 million funding round, and some of the key names that you will recognize are behind this funding round. And so, starting from Schneider Electric, Microsoft, SolarEdge, National Grid, and a lot of, the reason why I wanted to show you this is to really show that in this clean energy transformation, there are companies who are coming from the IoT point of view, from companies like Schneider Electric or SolarEdge. You have oil and gas majors who are transforming their own business models. You have utilities like National Grid who themselves are going through a lot of transformation as a utility. And then as Shiv gave a very good introduction about what Microsoft is doing in the space. It really showcases how technology is being brought together from IoT, from capital deployment, to really transform the business models of utilities as well as oil and gas majors like Shell and Total. And we'll see a lot more of this happening. And as an American company, it's really sad that some of the oil and gas majors in America are lagging versus the Europeans are leading the market in this space. So with that, our mission was basically to accelerate access to clean, affordable, and reliable energy. Very strong words. We have roots, all of us have roots going back to Silicon Valley and India. And we want to make sure that whatever we are coming up with here is clean, affordable, and reliable. So I want to spend a little bit time on the broader story in terms of the use cases and how open standards and integration of assets through internet as well as through secure channels, all of these come together. So at first, what AutoGrid does is actually provide a software-based orchestration platform. It's an optimization engine, as Shiv prior alluded to. So it is geared towards solving multiple use cases, whether you want to take large-scale assets front of the meter and optimize them in energy markets to trade them, or you want to manage energy storage more actively. And the far right, you have microgrids and EVs. So one thing that you have to understand is this involves integrating assets, which are made by many different IoT partners around the world. So as a software provider, one of the core things that you want to do is to drive the market towards open standards adoption. Because when you go from, let's say, Japan to another market like US or India, you don't want to keep reinventing the wheel each time with the same problem. So standardization is key to solving that problem. So in agencies like IEEE and IEC have been very instrumental in basically solving some of the challenges that this problem comes together. So, so at its core, if you were to think about the electric network, in the past, you had your traditional power plant and power generation assets. What's happening now is introduction of more dynamic loads and flexible loads. So your end customer who has smart homes or smart buildings or factories of the future They can actually participate in energy management programs with the utilities, trade and include a lot of on-site generation as well as free carbon-free energy from the grid if available. So the smarter energy network is taking components of the grid edge, which are the homes and buildings, along with the evolution of transportation sector. My CEO says the two of the biggest transformations that are happening is one is on the transportation side, the other is in the energy side. So the best place to be is at the intersection of both of these, where you have energy management built into your DNA, along with a lot of load control and asset management. So as Shiv said earlier, the idea here is to take data from all of these various type of asset classes and devices, and you want to provide situational awareness. You want to optimize the grid. You want to control these assets in the most optimized way, and essentially run virtual power plants, or VPPs as we call it. So at its heart, this is what my company does. This is what my product does. And we've been deploying this for the last 10 years in various geographies globally. So since everybody spoke a lot about this, I think I should spend a little bit more time digging through some data, which might get exciting for a lot of folks to dive in. But at the highest level, where open standards and interoperability are very critical is this aspect where you have homes at the edge, or buildings or factories, and they may have devices made by Samsung or Panasonic or like 15 other vendors out there. You may also have electric vehicles made by Maruti or a lot of the other car OEMs. So how do you actually integrate these assets from the edge back into the grid in the most cheapest, reliable, and secure way? Wherein you get the data, you're also able to send control signals back. And also with that, you're updating forecasts. So once you control assets, your real-time situation of the grid changes. Hence, you want to take all those changes and update your forecast plans and what a grid operator sees. So essentially, we are talking about collecting, thousands of data points in real time, and in managing the electricity on a more real-time basis. So let me just skip through all of this and just tell you where where AutoGrid is placed in terms of this virtual power plant business. We lead the market in most cases. We've been awarded by Navigant last year that AutoGrid is a leader in the virtual power plant space, and you can see some of the leading brands and large controls companies still in the contenders and challenger space. So here is an example I want to talk a little bit about, where how can you actually manage load using air conditioners more actively. Reggie mentioned during his pitch earlier about the growth of air conditioners in India, and the challenges that it presents in terms of load growth and managing the demand it causes. What we've observed is most of this load, especially air conditioning load, appears in the nighttime caused by residential peak. So we are trying to bring in a program here in India where we can actually actively manage air conditioners with Wi-Fi or without Wi-Fi, using various control strategies. Now here is a perfect example where there are no standards which govern and say here is how our AC should be controlled. You have it through your remote, but there are no internet-based standards which say here is how you control the ACs. Now, when you have 20 different OEMs out there, how do you actually provide a platform that allows devices from any vendor to be integrated with your platform, so customers can join and participate in these demand response type of programs? So here is an example where standards need to evolve so that you avoid getting into the trap of custom APIs or non-replicable APIs. So I will skip through this. So here is a great example of a very optimized home. This is actually my own house, And you can see there are a few things that I want to call your attention to. The rates of electricity is actually different. So there's off-peak rates and on-peak rates. So this period here between 3 o'clock and 8 o'clock is on peak. So this is where I get charged the most. So what I have here going on is actually a solar, PV system paired with a battery from Tesla. So what this is allowing us to do is actually store the energy in the battery produced from solar and use that during the rest of the day. Or if you do have electric vehicle that is getting charged, it's getting charged during off peak and when the grid is cleaner, right? So because there's a lot more wind energy available during this time. Now, this is ideally the kind of optimization you expect from distributed energy resources. So there's a lot of pieces involved here. Controlling air conditioners, which are made by a bunch of different people. Batteries are made by Tesla. Solar PV is made by someone else. How do you actually bring all of this together? So there's one really good standard that's emerging called IEEE 2030.5, which is a very popular standard that is allowing us to fix this kind of problem at the grid edge, which allows hardware OEMs to adopt the standard so that devices can actually share the data, collect the data, and also be controlled remotely by third-party aggregators or utilities. So I've made an enhancement to this. So since I promised I'm going to dive into the data myself, so I want to show you the live system that I have going on here. So we're looking at the Tesla batteries at my house. If you're actually seeing my video, they're right behind me, 2 batteries. So I actually have a system where I collect the data, but also trend the carbon intensity or the emissions on the grid itself. How clean or dirty is my power from the grid operator, who in my case is PG&E. So here is a data for the most recent day. It's for today. But let me just start out with a high level for the, about last 30 days, and we'll look at a first pattern. First and foremost thing, you can see a very distinctive pattern of solar production. And there's some disruption that happened here. But by and large, by using machine learning and deep learning and adding weather features and other type of data sets, you can predict and come back with a very good forecast of what the solar generation looks like. And the same way, you can apply similar type of forecasting techniques for forecasting load, forecasting how the battery will be optimized. And as a combined, was the amazing thing, right? So this is what the overall consumption looks like on the overall electric grid. So while I have solar being produced constantly, I'm also storing that in my batteries and then running the house at a later time. So all of the generation that you see here, this blue stuff, is usually during mornings or late evenings when the batteries are not fully charged. The thing that's most interesting for me is the repeatable pattern of the fossil fuels itself. So when I overlay all of this data and look at it, I can see a very predictable pattern that in the afternoon when solar is produced, the carbon intensity on the grid drops significantly, and as the solar starts dropping, the carbon intensity starts to increase on the grid. So let's observe that for the last day and then see if you guys have any questions. So here is a full day what we're looking at. As you can see, on the right axis of this is actually carbon intensity. I've plotted that. And the left axis, y-axis, I have power consumption. So it's relative to show you how in time these two correlate, right? So what I'm looking at here is the blue part is the only load that I've consumed from my grid, because the rest of the day I am actually using power from the batteries. Few things to call out. Number one, how are you going to get this kind of granular data sets from your assets? So standards play a role in that. Absolutely. Right. I had to do some wizardry to come up with this, but this is not normal. The other thing is whenever the carbon intensity starts to increase, as you can see, the battery starts to discharge and supply the load in the house, allowing you to offset and basically almost decarbonize, almost reduce your emissions from the grid during these hours, right? So just thought I'll pause here and see if you guys have any questions. And as it relates to it live right now, I'm running off grid 100%. So my house is consuming about 1.5 kilowatts, and all of that is coming off of the batteries. So this is as live and real as I can explain to you guys what the power of IoT and what the evolution of devices and distributed energy resources can bring to the table. So now coming back to what AutoGrid is doing is actually aggregating 10,000 of these batteries into a very large pool and dispatching these assets as a virtual power plant. This allows us to actually targeted and in a surgical way look at certain areas and offset.
Wish, any issue from your side?
It seems like there is a.
But we can see his screen, but maybe it has frozen.
Yeah, but it indicates that there is a low bandwidth issue at his side.
Okay. Let's give a few seconds.
Yep, sure.
It's good to see the live system in this conference. So meanwhile, participants, if you have any specific questions, I can see one question from Sriram. We will ask. If there are any questions, please feel free to type in. Use the time. I know this kind of technology is in research. Even in fact, maybe during my PhD days 10 years ago as well, we are talking about smart grid, adding back to the grid, and self-sustaining virtual power plants. Good to see that they are in reality right now. Can you hear us, Wish? Now at least not see the warning sign of low bandwidth. Maybe he's trying to.
Yeah, rejoin. So I see he has
You
dropped out.
rejoin, great.
Yep.
Yeah. Are you trying to share the screen again?
Yeah, he just joined and I'm making him the presenter.
Yeah, sure.
Wish, can you hear us?
Hey, sorry.
Yeah, no worries.
No,
Yeah, we had lost you. Seems like there was a bandwidth issue at your side. So
okay.
probably what you can do is you can just share your screen rather coming on the video feed, and then probably you can speak over the audio. Yeah.
So we can hear you, Wish, till the live system you are trying to show, right? We do have another 2-3 more minutes for you to share some of the thoughts. Then we'll take a few more questions.
Yeah. So did you guys follow?
Yeah,
Did you guys hear
we are
this
able
part?
to. Yeah, we are able to follow till the live system. You are showing the entire 1.5 kilowatt. You are getting it from off the grid, right? From your battery
Yeah.
itself.
Yeah,
Yeah,
from the
we're
battery
able to
itself.
see that. Yes.
Awesome. So I hope you were able to follow this part where there's a correlation between the actual solar storage and the emissions itself, the grid
Yes.
emissions. Awesome. So let me show you very quickly about how this works as an aggregate pool, right? So what we do is, this was one unit or a single system at my house, but what AutoGrid is actually doing is aggregating 10,000 of these systems together as a single entity, right? So we create pools, and at that pool level, we apply a lot of forecasting and predict, sorry, one sec. Predict what is the exact nature, what is the load going to look like. And then, as Shiv said, we'll bid them into energy markets and trade them in the markets, almost as if like it's a real power plant. But rather than have a power plant, a physical power plant, this virtual aggregated portfolio is able to provide the same exact value as a real power plant would do. So just wanted to show you an example of how a single system was working at the most grassroots level, and taking that to more aggregated assets. Similarly, as we talk about IoT and devices, here's another example of EV fleet management, where there's a lot of vehicles and buses which are getting charged, and based on the route of the bus, we forecast their state of charge, and by the time the bus reaches the depot, you can also feed back to the grid and manage whether you want to charge them or discharge them. So that's called flexibility up and down. And again, starting more fundamental, but getting all the way down to applying machine learning and AI to achieve this kind of a system. So so with that, I'll take some questions, see if you have any questions.
Definitely. Thanks a lot, Vish. Definitely it adds value to see real system beyond our presentation in a PPT, right? Thanks a lot for that. We have one open question. Let me see from the chat window. There was a question from Sriram. What is the role do you see from hydro plants and pumped storage plants? Talking more on solar and wind, right? So this question is on pumped storage plants and hydro plants.
Yeah, I mean, I have, if you can place them everywhere, they're great. So there's physical limitations of where you can place these systems. And I think and it's also become very, very geopolitical where you place the systems. So I would say I'm not against it, except that if you have all the answers to the other economic and geopolitical things, pumped storage actually is the most cost-effective form of storage.
Interesting. I have another question. So if you see, good to see your as latest as today's system or last 2 days, 7 days. Mostly you are using in the live system, just produced, maybe the battery charging is good enough for you to run the show at your home. But are you adding back to the grid, and how often it is common, adding back to the grid?
Yeah, it is very common. I mean, so this is actually winter. So that is another very important factor. So in summer, my system overproduces. So my batteries fill up 100% by 3 o'clock. And after that, you start selling back to the grid. But winter, it's a different story because there's a lot more reliance on the grid. Your solar does not produce enough as you normally would. So the system, what my initial thought thesis was, you could be off grid, but in reality, you could be off grid 60-70% of the time. You will still rely on the grid for times when the solar is not producing enough.
Interesting. And one last question in that regard, when I see this kind of a system from past 10 years, especially in the California, your own operators point of it, there is a lot of resistance in initial days from the demand response system point of it, right? Taking control for on off hours, on hours kind of a thing from the grid point of it. Yeah. How is the customer support in the recent past? What is your observation from AutoGrid?
So in the past, well, first of all, customer adoption has increased quite significantly, and I think incentives play a huge role in changing that perception. See, one of the very subtle things is that you trust your utility. One way or the other, you have no other choice. Like there's an inherent trust built into that relationship between you and your energy company, right? Because you expect the power to be there. When those companies go forward and say, hey, you know, in the past we were only charging you money, but we can put money back in your pocket, that changes the conversation and actually helps them turn this into an engagement tool. The other very important thing that we really realized was these kind of systems actually make it cost effective to deploy smart meters. In India, you have, you know, theft detection is the most popular, or revenue improvement is the most popular use case. But if you actually see cost avoidance because of not increasing your distribution capacity, but by using these kind of systems allows you to make it more cost effective to deploy smart meters, because you need the smart meters form the basics and the fabric of data for all of this to happen.
Interesting.
So Vish,
I
have a question. You talked about, you know, standards to communicate to all these diverse devices.
Yep.
So in your experience, what has worked and what has not worked? What are the major challenges you see there?
Standards, first of all, take a long time for adoption, no matter which standard you take, unless there's government intervention and they force it down. There is really fast adoption. Best example is FASTag, UPI, because they're government mandated. There's like really fast adoption. So in the smart home and smart grid space, India particularly is lagging in terms of creation of and adoption of these open standards. I think a lot of what is what's coming out is we're looking at standards from international market and we're literally like translating that to Indian standards. But UPI, as it turned out to be an excellent standard that could be followed everywhere else. The same way, India has you know, an opportunity to leapfrog in this particular domain. And what hasn't worked is the interpretation of the standard. You know, as over time, because things are new, a standard gets interpreted by every single vendor differently. There's no, even though there's conformance testing, but adoption is not that easy.
So how have you, you know, so far you have been communicating with all of these devices, right? Otherwise you won't get the data. You have to collect the data, right?
Yeah, believe it or not, we hate this, but we connect to a lot of APIs because those standards don't exist.
So
right?
API is the only way right now.
Yeah. So for example, storage, right? Like we integrate with about 4 or 5 different storage vendors, global vendors. We integrate with all of their APIs because they have not actually adopted standards more broadly. And if you think about it, like Tesla, like we integrate with Tesla with an API, like not with a standard, right? And we're controlling 10,000 batteries, which is not actually a fun, but that's the way the industry has gone because the standards don't exist.
Okay. Okay, so API is the answer for now.
For
and
now, yeah.
is that true also in the US?
No, so in the US, 2030.5, IEEE 2030.5 is actually becoming a very widely adopted standard. We feel that is going to be the solution to the problem that exists out there, but almost nobody in India has heard of it. Right? So I think there's a lot of education that needs to happen, and government also have to procure and create an ecosystem of IoT partners who are either suppliers or vendors or who are part of the supply chain in that standard thing.
Okay.
Yeah, one of the most amazing things we found out was there are no smart home standards in India at the moment. So, you know, if you buy a smart plug, other than the UL and electrical certification, there are no standards around the communication, and the whole package itself is not certified.
Okay.
There's a lot of room for the standardization for faster adoption. We do agree, Vish and Ashok. Thanks for the interesting conversation on that. So let me thank on behalf of IEEE BTC, Vish, for taking time and sharing the live system and insightful thoughts on this topic. Thank you.
Excellent. Yeah.
Thanks a lot, Vish. It is a late night now. Okay.
Yep.
Special
Sounds
thanks
good.
for
Thank
that.
you. Take care.
Thank you. Bye-bye.
Yeah, Dikshita, please.
Thank you so much for this amazing talk on fixing the grid edge with open standards, sir. It was a really amazing talk. Here we have a small token of appreciation from our side.
Thank you
sir.
very much. Take care. Bye.
Sir. So the next talk is on ICT sustainability, key challenges and opportunities by Michael J. Ogia. Michael is a Belgrade-based consultant, editor, researcher, speaker, and ICT sustainability advocate working within the digital policy and infrastructure, internet governance, and media development ecosystem. He is a third culture kid and a connector at heart with more than a decade of professional experience in conflict resolution, journalism, and media policy and development across 5 countries: the United States, Lebanon, India, Turkey, and Serbia. He has also worked on projects within the digital policy, internet governance, and media development ecosystems, specifically focusing on access, capacity building, digital rights, infrastructure, and sustainability. A warm welcome to you, sir.
Just a very quick, just very quickly, can you hear me?
Yes,
Yes,
we
sir.
can hear you.
Brilliant. Okay, so give me just a moment to share my screen.
We will make you presenter. You want to share your screen?
Yes, please do. Sorry, just a second.
Yes, we can see the screen.
Oh, sorry, it's not didn't choose the right one. Just a moment. Sorry about this. Let me try again. Okay, well, I don't know. I'll just share my whole screen. That's probably easiest.
No problem.
Okay.
No problem. You can just go to that button. Yeah. We can see
Yeah,
that
there we go.
you will have 20 minutes to share your presentation, and so that we will have some interesting questions at the end to interact. Over to you.
Did you say 15 minutes?
No, 20 minutes. You'll have
20 minutes. Oh,
20 minutes.
brilliant. No, that's no problem. So you can see my screen now, right?
You can see. Please proceed.
Excellent. Forgive my slight Luddite nature when it comes to WebEx. It's been a while, but Sunil, I'm so grateful to be here to join you all. Thank you so much for hosting me. My apologies that Max couldn't make it, but it's actually wonderful for me to be here because so for any of you who don't know, which is probably all of you, I used to live in Bangalore from 2013 to 2014, and I definitely really wish that I could be sitting around with you all having a dosa with some kesari bath right now, because I miss both of those things way too much. So it's a pleasure for me to be here, and I really want to you know, we've already the presentation that I've heard, we talk a lot about the technology itself, but I want to share a lot more about kind of some of the things that aren't necessarily seen. So this is why this talk specifically is going to be about sustainability and ways that we can move forward in a way that actually preserves a lot of the effort that is going in to making technology what it is, but also in a way that can be respecting toward the environment, toward communities that digital technology is meant to serve, and of course, the bottom line of which drives so much of our economic development. So with that, I want to start with, I'm going to start with an overview of ICT sustainability. I'm then going to go into 3 challenges for digital infrastructure sustainability in particular. I'm going to then introduce our roadmap to a sustainable digital economy, and then end with some recommendations and conclusions. I have a timer over here, Sunil, so I'll make sure that I stay on time as much as possible. And if anyone has any questions, please either save them for the end or feel free to put them in the chat. I'll also have my contact information at the end if you'd like to hear more. So let's get started. Let's dive right in. So to start with, when we're thinking about digital technologies, you have to understand you have to take into account the absolute complexity of the system. So for instance, the journey from an electron to an Instagram post, it spans more than 30 industries and many layers of technology. So for instance, you have the enabling infrastructure, which is the electrical power generation. You have the rare minerals and the materials and the metals that are being used. In the case of a data center, you have the buildings and land. But then on top of that, you have then the digital infrastructure, you have your fiber networks, you've got internet exchange points, you've got the data center itself, the hardware, etc. Then going in to the next layer, you have individual hardware, laptops, PCs, you have virtualization, you have many other bits of technology that are all working to make the internet what it is, to, as I like to say, to not just go from an electron to an Instagram post, but to take you from to when you start your computer and you want to log into your email, you have everything that works the way it does. And then lastly, built on top of that is the digital economy. You have your platforms, you have the web, you've got marketplaces, you've got your e-government portals. In total, globally, this is a 13.7 trillion USD ecosystem. At least that's the economic value of it. And so this is very, very extensive. If you're thinking everything from power generation all the way up to software, in between that is a lot of supply chains and so much complexity, most of which don't necessarily interact with each other. So take a look at this graph, for instance. In 2020, which given you might think, oh, well, that was different because of the COVID-19 pandemic, this was how many of these digital services were used, across the world. And so, for instance, you have 1.6 million swipes on on Tinder per minute. You've got 4.1 million Google searches. The whole idea is that what is data though? This is all generating data, but what is data and what does that mean for the environment? I define data as the tangible output or the tangible outcome of all human or machine decision making over time. And so when I say it's the tangible outcome, a data point represents a decision that was made. I went to a website, I clicked somewhere, I chose, I looked at a Google Map link or something like that. The point is that is a data point. And so, but it's important to remember that everything virtual connects to something physical, because as we're generating all of this data, it doesn't just go into this nebulous cloud. It actually is being powered, stored, and transported via our physical infrastructure. So if we think then, what does this have to do with the environment? There are major ICT sustainability issues that are including, but not limited to, you have energy consumption and the climate impact. You have resource use, including water and land, but not just. Of course, there's waste generation, including e-waste, including pollution, and other types of waste. You have mineral and resource extraction, especially pre-production, but then, and not just, I should say, not just extraction, but then you have to process those as well. Obviously, construction, transportation, and then of course infrastructure resiliency. With this kind of connects to climate impact, in that as sea levels rise, you're going to a lot of the coastal infrastructure that we're all dependent on, especially with submarine cables, they're going to become more difficult to service. But then of course there's data transit and storage, there's very extensive supply chains, there's the lack of design considerations. Oh, and what I mean by this is that we have not integrated design into the core of our ICT structures, our technology, and which is we're having profound effects now. There's of course issues with production, consumption, end of life. There's a significant impact on biodiversity and communities, and of course there are very problematic business models. And what I mean by that is that if we recognize that we need, and this kind of again connects to production consumption, and that if we recognize that we don't need to necessarily keep producing, or sorry, yeah, keep producing or keep consuming, a lot of business models are pushing linear economic models and pushing consumption. So just think about this. Just over half of all humans connected to the on the earth are connected to the internet, while more than 3.5 billion don't have access to reliable electricity, and just under a billion don't have access to electricity at all. So I often say that when we're addressing, especially internet access, especially in a place like India, we can't really legitimately discuss access without addressing sustainability. And I wanted to take you through through a few case studies, and I'll see if I can get through these a bit quicker. So for instance, if we're starting at the start of the value chain, let's look at minerals and metals. In case you don't realize it, just looking at a mobile phone, for instance, there are so many different metals, materials that go into it. And you might have seen something like that. Oh, sorry. You might have seen something like this before, but there are so many valuable metals and minerals just in a phone, not to mention IT hardware, servers, racks, etc. To give you an idea, there are conflict minerals, which are actually sourced oftentimes from the Democratic Republic of Congo and Central Africa, but also elsewhere, related to these four types of minerals. But then there are also other key metals sourced from all around the world, such as cobalt, copper, lithium, especially in Bolivia, silver, and of course rare earth elements. And as you can see in this map, there are multiple sites all across Central Africa in particular that are either related to conflict mining, forced labor, child labor, or other kinds of environmental and human rights issues. So at the same time, clean energy demand for critical minerals is set to soar as the world pursues net zero goals. So here we are in a situation where a lot of our production capacity and a lot of our resource capacity is not necessarily clean, environmentally friendly, or good for the community, or necessarily good or beneficial to the communities that are involved in them. Of course, that there are some typically artisanal mining that is done in a way that is good for populations, but a lot of the industrial mining, there are issues there, but then there are also issues with small scale mining. But the point is that there's a huge demand, and we have to think about, well, what is the supply coming from? What are the impacts? We want to transition to a clean energy future, but that has real implications for the earth that we're actually still on. Now, let's shift to the end of life. Let's shift now to the end of the life cycle, and let's go to e-waste. And so, to give you an idea, there's a lot of electronic waste is one of the biggest problems when it comes to technology that's out there. This, for instance, is a dump that is in Agbogboshi, Accra, in Ghana, and it's a very notorious site for its e-waste. Now, something I should have done is that I should have. Oh, sorry. Before I get to this, I should say that India also has a very significant gray market for e-waste recycling. And I say recycling because oftentimes it would be situations that look very similar to this, where minerals and other components are being extracted, often it can be by younger laborers, child laborers, etc. Throughout the country. And so it's common in the global south, it's common in West Africa, but it's also common in China and India. To give you an idea, the world discarded 45 million metric tons of e-waste in 2006, I want to believe. Yeah, I couldn't see it. In 2006, and that totaled 65 billion USD. But then in 2019, 3 years later, that figure actually rose 53.6 million metric tons, and with only 17.4% of all e-waste generated in the entire world being collected and recycled. And this, by the way, imagine, where is it? My phone is over here, but like I'm talking to you on a computer, and there could be gold, silver, who knows what else in this device, and yet it often just gets tossed out as if it's garbage. And so there's a significant problem with this. This is something I wanted to show you. This is an older this is an older graph, but it just gives you an idea of kind of where e-waste dumping happens, which is the exporting often illegally or with governments turning a blind eye from the north to the south to show where it goes. For instance, Ghana is not on here for whatever reason. It should be included, but this is just to give you an idea of kind of where it's coming from and where it's ending up. That's not to say that India doesn't produce its own e-waste, for instance, but this gives you an idea. And it's completely unsustainable. Even the UN is saying this. China, India, and the US all have issues. And I will share this presentation with you. And if you're interested in reading this specific article, this source is down here on the bottom. And as you can see, they actually profiled someone that's working in Delhi. So I mentioned that there are three key challenges for digital infrastructure sustainability in particular. I want to get through these. Before I go, am I going too quickly? Am I speaking too quickly? Is everything okay, Sunil? Everybody okay in the audience? I can't see the, I'm looking for the, I can't see the WebEx at the moment. Okay, thank you. Thank you, Prasant.
Oh yeah, we can. Yeah.
Brilliant. So the first challenge that I want to highlight is that ICTs themselves are responsible for about 2 to 3% of all annual greenhouse gas emissions, which is a figure that might sound like much, but that's on par with aviation, which is about the same. And think about the giant uproar that so many people rightfully make about aviation, of which I'm guilty of as well. I criticize it, but I also fly. But ICTs are actually responsible for about the same amount, yet we don't hear the same, so as many people, for instance, calling for a reduction of internet resources or use, etc. So I just wanted to make that clear. But data growth is also rising exponentially, and demand is expected to outpace efficiency gains over the next 5 years. Now, for the most part, efficiency has remained flat or plateaued while data growth has risen. But this figure is from, for instance, from the London-based Uptime Institute, and it is something that is something to consider. If we have something like 20.5 billion IoT devices that came on just last year or that were actually working. Imagine what it's going to be like in 10 years. And all of those devices, again, everything is generating data, using resources, using energy. I'm actually worried less about the energy than I am more about the material use, given what I just showed you about the minerals that are going into production, the carbon emissions associated, etc. So um, so given that, the first challenge is that we have to take a holistic approach. For instance, we do this at the Sustainable Digital Infrastructure Alliance by recognizing that emissions, energy consumption, e-waste, resource consumption, pollution, and the cost of digital power are all actually integrated. And another thing, and I'll get into this in just a bit because I still have a little bit of time, but I don't want to go into this too much, is that we need to take a holistic approach to sustainability, recognize that actors at one end of the value chain ultimately impact actors at the other. And by not taking a holistic approach, a systems-based approach, we're actually making the transition to a sustainable digital economy much more difficult. So of course, my slide, I need to fix it, but the second challenge is that we need to make the business case for sustainability. What do I mean by this? If you're going to a tender and the government saying, okay, we're in between you and another organization, but another firm, but we're going to go with them because they're cheaper. That's a problem. We want sustainability to be economically viable, because if it's not, it's never going to become the standard. And on top of that, sustainability is often better in the long term. It's a good case for this, for instance, is shoes. If you spend a little bit of money on a pair of shoes that you then need to replace every year, year and a half, versus paying a lot more money for shoes that you don't have to repair for 5 years, or you don't have to replace, you're probably going to save money in the long term. Well, we think that the same is true for sustainability. And this is just, I wanted to highlight some of the ways that we're actually doing that. We're working with our partners, we're working with our members in order to actually, to actually turn a lot of the innovations that are coming out into something that is good for business. And so it's not just an experiment, not just a pilot, but we can say, yes, this can scale. Maybe this needs a new incentive, this needs new policy support, something else might need a subsidy from a government, for instance, but this is exactly what we're doing. And so lastly, probably comes as a shock to no one, another significant challenge is political will and geopolitics. If we don't have government support for sustainability, if we do not have actual policy, genuine policy support for making sustainability important, both to technology as well as elsewhere, we're never going to get anywhere. And I say geopolitics because this is another one to think about. If you think about supply chains at the moment, there's a lot of geopolitics involved with supply chains. There's a lot. It's getting harder to get hold of most things. And if you think about, for instance, like rare earth, most of the rare earths are actually processed in China, and so this is something you have to consider if we need to expand clean energy, but we then don't have the resources to do it. That's going to be a major problem for a lot of countries' standards. So I have just a couple minutes. I'm going to go through this a little bit more quickly. Again, you'll be able to have the slides, so you'll be able to see it on your own. I just want to, I'll probably actually go to this slide and then go through my recommendations slide next after this, which will be a little bit of a change. So, but I just want to say that SDIA, we do take a holistic approach to sustainability. As you can see on the right of the screen, this is what we call our roadmap to sustainable digital infrastructure by 2030. And the way it works is that there are 6 metrics that we have that then are broken down into multiple activities that extend between 2021 and 2023. Oh, sorry, 2030. And each of these activities all constitute a specific part of the value chain where we believe if we bring all the actors involved, we'll be able to create more holistic and more resilient and more sustainable outcomes. And so in each of these activities is led by a steering group. That's where the work happens. And so, oh, sorry, sorry about that. So we were established in 2019. We're co-based in Hamburg and Amsterdam, Hamburg, Germany, and Amsterdam in the Netherlands. And at the moment, we have more than 65 members and partners working across Europe. We have multiple metrics and multiple activities and steering groups. Some of the projects that we're working on include an open data hub to bring transparency to the digital sector, as well as work on creating a sustainable European cloud to challenge some of the major players. And of course, there is more information and it is available here. I'm going to skip this just at the moment, just because I'm out of time, and I will do a better job in the future at timing myself. But again, most of it is self-paced, and you'll be able to look at that on your own. So I just want to quickly go through what I would recommend if anybody's interested in this topic. The first thing is for any of you that are just end users or citizens, you need to, I encourage you to think local, work with civil society groups, think about repair workshops in your community, as well as fight for the right to repair, things like that. Respond to public consultations as much as possible, sign petitions. Again, you file FOIA requests, Freedom of Information requests. You can run for office and vote, obviously. I mean, depending on your level of cynicism with Indian democracy, I fully understand if you're not necessarily so keen about those. However, you can choose a green hosting service. You can keep your devices as long as possible. You can fight against marketing. All of these things are things that you can do. When I say fight against marketing, if we're being told all the time you need to replace your phone because it's not good enough, even though it's got the latest technology or some of the latest technology, say, no, that's ridiculous. I don't want to do that. And then for individuals especially, I always say, give up your climate guilt. That's not to say that you shouldn't care about your footprint, for instance, but we really need to focus instead on collective action. The status quo needs to change, and you can demand that with both your voice and your wallet. Now, for any of you that are infrastructure operators or work in the infrastructure space, I encourage you to see sustainability as holistic, including energy, land and water use, e-waste, etc. We need to think beyond PUE. It is a completely outdated metric. It does not mean that much anymore from my personal point of view. We need to instead embrace infrastructure synergies. In other words, how can we take some of the things that we have that are being produced and actually turn them into a resource? A good example of this is turning byproducts like heat waste into valuable resources that benefit both the environment and local economies, communities. That might not be as relevant in India, where obviously it's warmer most of the time, but there are other examples of this. Reuse or refurbish equipment as much as possible and embed sustainability into to design. And lastly, do not underestimate the power of sustainable procurement and collective bargaining. So with that, I will say thank you so much for listening to me. It is a pleasure to be here. Sunil, Prashant, thank you for inviting me. And the very last thing I'll say to wrap up is that, internet and the ICTs in general are not a panacea, but just as the development of the internet and its evolution has demonstrated, collaboration will be is really the only way forward if we want to create a more sustainable digital economy. Thank you very much.
Great. Thanks for a great presentation, and we will be happy to host you soon, maybe once things are aligned, right? So once we are eased with the travel rules, and we'll be happy to host you, and welcome back to Nama Bangalore soon.
My pleasure.
So,
thank you so much.
Yeah. Maybe let me see if there are any specific questions from the audience. Otherwise, I have one question, but I will wait for any questions from the audience. Feel free to unmute if you want to ask a question. While we wait for that, let me use the time because we are really running out of time, Michael, right?
Go ahead.
So I have one, when you say about 3 challenges, right? So I really impressed by that. So even the one is the holistic approach, and the second one, if you're talking about the making business case for sustainability, we may not be able to balance different stakeholders, right? Be it government, be it environmentalist, or be it on the organization point of view. How do you really prioritize the different or conflicting goals there for the sustainability to make an impactful business case?
So the irony is, I would say, well, that's exactly why SDIA exists, for instance. It's to create that dialogue that needs to happen in order to do that. Now, of course, part of that is that there might be different interests, there are different interests, and of course there are politics at play. I mean, not just within not just across sectors, which is obvious, but also even within sectors. But I would say it's kind of like, one of the best ways to unite people is to create a common enemy. Well, I would say to kind of put that into a positive spin, if we instead of creating a common enemy, create that common denominator. And for most firms, a common denominator is profitability. And so if you say, well, listen, especially given that customers around the world are now demanding sustainability, governments are more likely to start demanding sustainability, to start demanding accountability for environmental issues. If we are saying, okay, well, we want to meet those needs, and by working together, we can actually do that in a way that's not going to take away value, but is actually going to add value to both our business, to our downstream, or rather our downstream and upstream suppliers, to the communities that we're working in, obviously to the planet. It's about creating those win-wins because they're very much there, and especially if we focus on, well, can we do that in a way too that is then creating economic viability for particular technologies or ideas or whatnot? Can we create more connections between business leaders who are also looking for those kinds of solutions, like sustainable ones, one that save money, etc.? That for us is a key. It is a key way to do that. So, is it a little, perhaps is it ambitious? Yes, but I think most of us can agree that saving money while working to improve the planet is something that everybody can benefit from. And so that's the thing. Sustainability, when taken in a holistic way, is win-win-win across the board.
I agree. Exactly. So thanks for that elaborative answer. So let me take this opportunity to officially thank you from the IEEE BTC Organizing Committee. Over to you, Shita.
Thank you
My
so
pleasure.
much, sir,
Thank
for
you.
sharing your valuable thoughts on ICT sustainability, key challenges and opportunities. Here we have a small token of appreciation from our side. Thank you so much, sir.
It's my pleasure. Thank you for hosting me, and please have a dosa on my behalf. Okay.
Thank you, Michael. Yeah, let's go ahead, Akshita.
The next talk is on breaking the energy curve by Jairam Belatkere. Jairam Belatkere is a leader with global experience in business strategy, product planning and engineering, and full life cycle management with specialization in telecommunications. He has a deep expertise in enterprise service providers and cloud networking with solid understanding of IoT technologies and solutions. He is well versed in go-to-market, co-development models, and emerging market needs. He possesses a broad knowledge of technology trends, including solutions built using AI, ML, and data analytics. He has 20 plus years of solid accomplishments, gaining and demonstrating a wealth of experience in AI products and services, business strategy and operations, etc. Operations and so on. He is an excellent team builder and a mentor. Consistently gets the best of diverse teams, and he's a strategic thinker as well. A warm welcome to you, sir.
Yeah.
Thank you, Deepshita. I think the presentation that we had from Michael on ICT sustainability is a good lead to what I am going to cover. So let me start sharing my slides. Let me know when you are able to see this.
We can see this, Jaira.
Okay.
Maybe you can go to full screen.
Okay.
Yeah.
So the topic or the theme that I'm going to cover today is called Breaking the Energy Curve. It is an area of great focus for Ericsson for the reasons that we heard from Michael. What I'm going to do today is to cover a few questions of the following types. The value of ICT as an industry and how it has become critical to all of us over the last several years, and how has that impacted its energy use, sort of a background information. Then the second sub-question under that is, how does this industry help the greenhouse gas emission reduction in other sector? So that's that part. In the second part, I am going to cover more specifically the mobile industry, operators, product companies, and services. So what are the technology trends that we are seeing, and traffic growth related matters? Again, we heard some of that from Michael. And when you then consider fifth generation of mobile technology, 5G, what does that really mean in terms of the carbon footprint? While a range of rich services are being targeted for deployment using this. So with that, let me start off by jumping to first part. So we heard from Michael, I think he showed a number of 2 to 3%. I would trust that this is a sub part of what he was showing. So this shows that in that ICT sector, again, this is a study from this group here from 2018, we are seeing that the energy consumption as a part of overall energy consumption has been approximately 1.4% to 1.5% of the total greenhouse gas emissions. So that is the trend. And you are seeing that traffic is going up non-linearly, exponential growth. But the projections tell you that the percentage that this industry contributes is not going to increase, which is great news. The second part is to also note that 3.6% of global energy is consumed by the ICT industry for its operational parts, but it also represents the largest purchaser of renewable energy, which is another good news. With that, a couple of more views on this theme. we are dividing the ICT sector here at the bottom. You can see the numbers again represented, carbon emissions on the y-axis, and you also are seeing the entertainment and media sector overlaid on top, and the GESI estimates are being shown. The ICT sector numbers are shown at the top part, middle part, it is showing you the entertainment and media sector, and at the bottom you see the print media sector. And what you are really seeing is that from 2010 to 2015 and going on to 2020 and beyond, that curve is already bending down. Again, this theme that we are going to cover today is about how we continue to see this downward trajectory in the light of increasing data traffic. This whole initiative is a joint cooperation or collaboration across many different parts of this industry. We heard again from Michael I think he represented from Electron to an Instagram picture. So this is representing something similar. You can see that, at the very bottom are enterprise networks. Then you have fixed access, which can be passive optical network, DSL, cable, etc. Then you have mobile networks, data centers, and user devices. So all of them from 2020 to 2030 are seeing this reduction. And more specifically, we are now looking at the infrastructure part of it and particularly the operations part. This represents the entire embodied emissions. So this is from the creation of products to running them and then doing end of life, whereas this is only about the operational cost of those products, and emphasis on the bottom part here. So fixed networks going down by 62%, mobile going down by 45% from 2020 to 2030, and data centers 53% reduction. Again, you can see that trend. All of this, the message here is that while ICT contributes to 1.4% of the carbon footprint, it has the potential to greatly reduce the overall greenhouse emissions in other industries. And in the next slide, I am going to show you how. And we are showing here 5 different industry sectors: energy, industry, buildings, transport, food, and how they are expected to reduce over time. This is between 2020 to 2050, and there are also these nature-based sinks that are being proposed, so that over time, we can not only reduce it but go below where we were at 2020. So 50% cut in the global carbon emissions by 2030. That's the target. So with that, I think a quick view on how greenhouse gas emissions are reduced by the ICT sector. So you can see here, smart services 3.2%, smart agriculture 2.9%, smart travel around 2%, smart work 2%, etc. Total is approximately 15%, and this comes from Ericsson's own mobility report from 2019. For those that are interested, this is available on our website. So with that as the background, I will now jump to the operational parts of what it means to the communications industry, more specifically to the mobile communications industry. So a bit of business background, I think, is important to understand. You are seeing, this picture shows you the value creation from 5G powered networks. While the operator revenues, you may be familiar with this trend already, their own revenues are not growing even as the traffic in the network has seen an exponential growth. I will touch upon that in my next slide. Whereas the associated benefits through industry digitization are tremendously valuable. The CAGR, cumulative aggregate growth rate of that is expected to be around 12%. So the meaning of all of this is that operators are also going to become more and more value-based players, vertical industry players. And so the importance of service providers as service creators and vertical industry players is that much more. And you can see that we expect them to have a potential of 35% extra revenue on top of what they are making today, which is around $700 billion. Okay, So with that, there is the concern, like all this new growth that is happening through industry digitization, not just in the telecommunication, but in the related industries, driven by this Internet of Things, Internet of Everything. So what does that mean? There are themes today. Some people seem to be very happy with the increasing energy consumption. For example, tower companies may be more than happy to have larger antennas, more power consumption, and that itself is counteracted quite powerfully by the concerns about what does it really mean to keep burning energy like this for operational matters of these networks when we know that the traffic itself is seeing exponential growth. So this view that you are seeing here is coming from Huawei. What they are showing is how generations of technology in the mobile industry, if you don't do anything, from 2 to 3G to 4G to 5G, how it goes from 4.8 kilowatt to almost 11 kilowatt. So this one can easily see that this is unsustainable. So we in Ericsson have a way of balancing this out, which is what I am going to talk about. And that is motivated primarily, I think there was also the theme that we heard from Michael. He was talking about how energy considerations need to become part of overall business models themselves. It cannot be just a feel good, do good kind of an initiative. It should contribute to your top line and bottom line. And how is that motivated? This picture is showing you that closed loop, if you will. So if you continue to deploy 5G in the same way that you deployed the previous generations, you will see much greater consumption of energy. And that, today, $25 billion US dollars is what energy costs are for mobile operators. So if you see that going up, that's not going to sustain them because their revenues using mobile broadband only, enhanced mobile broadband, is not growing. I showed you the 0.75% per year, which is negligible. So they need to find newer revenue streams, which they are working on, but they are also under pressure now to improve operational efficiencies and reduce their energy spends like never before. And what is happening is, in the light of 4x increase in the data traffic, we saw the reasons for that in the previous presentation by 2025. So what are you going to do when 5G is everywhere? It is being used not just for enhanced mobile broadband, but it's also being used for doing a range of other use cases, whether they are machine-related use cases, whether they are real-time control use cases, whether they are dedicated networks kinds of use cases. So operators, we heard from SDIA, there is public pressure now to also do more. So in the light of all of this, what is happening? This is going to tell you a little bit more. Going from 2G to 3G to 4G, this is what you saw. Data centers saw a reduction, 51%. IP edge and the transport network saw a reduction again. Fixed access and the core network saw a reduction, whereas the mobile net infrastructure itself saw an increase. So what you see here is out of 100, previously it used to be 10%, 20%, 25%, and 45% was the mix. Now with going to 4G, it has become 5%, 19%, 37%, and 39% because more and more mobile infrastructure is being deployed. Mobile has become the primary means of access to internet and related services. So that is the reason that is driving this. So what does this mean now to mobile operators? You can see this picture. To them, network operational costs, the parts that are shown in blue are the ones that are related to directly to energy. So field services, this is, you can call this as labor cost, but there are energy related costs. This is truck rolls. Network operations center, where you have people monitoring networks, then energy, operational expenses of infrastructure, then rent and others. So you can see that 20 to 30% of the overall network operational expenses come from energy. Now, another way of looking at it, countries like India, you see where you are seeing network outages, large percentage of them are related to energy. This is, power outages, diesel generators, battery backups, etc. going wrong. This is called site operations, and I will touch upon that. Extremely important. It's not just the radio antenna, the baseband processing, and radiated power itself, but also the infrastructure that you have at the site. That is very important. So, and then carbon emissions, if you really look at it, where are they? Network energy is 82%, employee activities are approximately 10%, and supply chain contributes again into the, from a network operations point, approximately 8%. So this is the dominant contributor. With that, our CTO, Eric Ekuden, this is public information. What we are showing here is, we call this as bending the energy curve, which is an important question, $25 billion question, really. How do you really look at this curve here? How technology, as it migrated from 2G to 3G to 4G, saw an increase. And if you let that happen with 5G, that trajectory, we believe, is unsustainable. So you need to really get on this track, the green track. That is what we are looking to achieve. And how do you go about doing it? One part of that, very important part, is through our products and portfolio. This is the innovation engine, technology leadership that Ericsson has. So we have some very ambitious targets around this. So what are we targeting? We want to, while supporting the 4x or so increase in the network traffic, we want to achieve in our radio portfolio, Ericsson radio system, compared to 2016, 2017, 35% energy savings are what we are targeting. This is SBT, science-based targets. Now, the second part of our targets are 5G for the same number of bits shipped and supported by the infrastructure. We want that to be 10x, 10 times superior to 4G, because the network traffic, as we saw from 2020 to 2025, went up by 4x. So we are saying that we want this to be 10x more, so that net you have that benefit of operating the 5G infrastructure without dramatically increasing the energy consumption. So where are we? Happy to report that we are already at 32% of 35% target here, and of the 10x, we are at 5.5. This is in the 2019 timeframe. Okay, and you will see future updates on this on our public website in due course of time. So I will then also want to touch a bit about the other parts. See, breaking the energy curve is not just about a portfolio that is compelling from an energy efficiency perspective. Very important for operators to modernize the infrastructure. Traditionally, what has been done is to keep the infrastructure, legacy infrastructure in place. It is paid out, paid down, and then you feel like, I'm just leveraging it. Oh, it's free. It is not, because the operational costs of that are going to offset any capex that you may have invested in that. So really important to use the latest technology. Sometimes, and we have calculators that show you this, that it allows you to have 5G and realize overall total cost of ownership benefits as compared to keeping the legacy and also bringing the new technology. So migrate to newer technologies. When you get to the newer technologies, these newer technologies also have built-in a range of energy saving capabilities. Some of this is driven also by the application of artificial intelligence kinds of solutions that Ericsson has developed. So machine learning kinds of techniques will bring in greater benefits. There are features that are turned on or off based on network traffic conditions, climate conditions that you're seeing on that particular time. And so you are able to leverage this. Third, building the network during the rollout process with precision, and then operating it with precision. There are right ways of building the network. You don't need to build it out everywhere. You can target the deployment to those areas where you are going to see higher and higher usage of the infrastructure. And also, you can operate the network in such a way that you are able to maximize the performance and the user experience when the traffic really demands it, and turn down the network usage during non-busy hours. So that's also possible. And the last point that we are showing here, extremely important, more than 50% overall site power consumption. You are seeing, well, this is diesel generator. We heard about this from Reggie and the Microsoft presenter, Shiv. So, like passive elements are not that efficient. Diesel generators, battery backup kinds of scenarios, etc. So what can you do to really improve the passive infrastructure while you're also optimizing your active infrastructure? So that also needs to be added in. So with all these steps, we believe that we can bend the energy curve and make sure that the 5G infrastructure, 5G technology delivers on its promise of not just improved mobile broadband, but the rich set of services that it is expected to support, while also keeping the network itself sustainable. And we call this as imagining the possible. And more information may be seen on this site, Breaking the Energy Curve. There is my presentation. I am happy to take any questions.
Great presentation, Jairam, as usual. So I too enjoyed going through the details, but let me wait for the audience if they have any specific questions. Audience, feel free to unmute if you have any specific question. While we wait, Jairam, I do have one question from the previous discussion. So when we are trying to, this is an ambitious goal when we talk about, you have shown an interesting graph from 2G to 3G, 3G to 4G, 4G to 5G. If we are not taken any specific measures, naturally the requirement of energy will be much more, right? Whether it is operational cost or deployment cost kind of it. So when we are presenting specific initiatives from Ericsson point of it, but from a global footprint point of it, is there any role of standards which can play here in terms of the energy conservation point of it?
Yeah, a number of capabilities, Sunil, thanks for that question, that you saw there. For example, the software capabilities that we referred to are definitely being built in 3GPP as part of the 5G specifications themselves. Okay, so there is no doubt there. What used to be optional capabilities, for example, in the infrastructure, have become mandatory capabilities that both the device side as well as the network side are expected to satisfy. That is definitely there. Since you brought that up, I do want to point out, one of the very important considerations. There is also this notion of disaggregated infrastructure now, with Open RAN and such initiatives taking hold. The considerations related to energy, I think, are also going to become more and more important in that journey, I believe, over time. The reason that I say that is that a lot of the energy today, if you really think about it, is going to be burnt in transferring bits from one part to another and one part to another. So in the physical or the virtual interface that you are going to have. So I think that integrated infrastructure in a very fundamental way is going to be more energy efficient as opposed to a completely disaggregated infrastructure. So I am myself looking to understand how that dynamic is going to play out over time. Initially, I do understand the benefits of going for open standards and disaggregated models for the network, but how do you counteract the benefits of that from an efficiency, both from a capex and an operational perspective, is also going to be something that we will see over time. I expect that to be an important conversation probably in the next 5 to 10 years.
Interesting. Maybe 5 to 10 years. By that time, maybe we will be hearing 6G as well.
Yes, 6G I think is going to have some of these from the ground up. That's what I expect. So
yes, great. So I'm not able to see any further questions. Let me just wait for another 10 seconds before taking up the next step.
Thank you, Sunil. thanks to IEEE also for this opportunity. I appreciate it.
We should thank you on behalf of Bangalore Technology Conclave and IEEE Bangalore Section. Thanks for your time, Jairam. Nikshita.
Sir, thank you so much for this wonderful talk, sir, on breaking the curve, energy curve. We have a small token of appreciation from our side, sir. Thank you so much.
Thank you, Jairam.
So coming up, we have a panel discussion on use cases and opportunities for ICT in clean technologies. And the session is going to be moderated by Narayan Subramanian. Narayan Subramanian has 27 plus years of technology leadership experience, spanning the telecom, networking, data center infrastructure, SaaS and electric mobility domains. He is currently the Senior Director of Engineering and Principal Architect at Nutanix. He graduated with a BTech degree in Electronics and Communication Engineering from IIT Madras, and he received an MS degree in Electrical Engineering from the University of Maryland at College Park, USA. He holds 10 US patents. He is passionate about sustainable living, renewables, and climate action. A warm welcome to you, sir. I kindly request you to introduce the other panelists and take over. Thank you, sir.
Thank you so much. Thank you to IEEE for this opportunity for this panel discussion, and we have had a really great set of presentations so far. Today in the panel discussion, along with myself, I would like to introduce my fellow panelists. The first is Sudipta Devnath. So Sudipta is from Cisco Systems, where she is an enterprise software architect, and she's TOGAF certified and a service delivery lead, inclusive of program management, PMP certified, Scrum certified, and she's an active Agile practitioner as well. She possesses a lot of hands-on experience in various Agile techniques like Kanban and Agile frameworks itself. And she leads a lot of deployment activities in customer premises, and she's an expert in implementing various test methodologies at the organization level. She has excellent hands-on project cost program delivery negotiation with customers, and she has a vast experience over 18 years working in the telecom, SATCOM, network orchestration software, and a lot of experience in handling customer and on-site offshore team models as well. So hearty welcome to you, Sudipta. Thank you for being part of this panel discussion today. Next, I would like to also introduce Dr. Venkatesh Sarangan, who is the coordinator of Smart Grids and New Energy and Sustainability Research at TCS, where he focuses on applied machine learning, smart grids, energy infrastructure, and computational sustainability. There are a variety of projects that Dr. Venkatesh has been involved in, some of which are listed here, notably around sensor data analytics for anomaly detection, fault diagnostics and identification in buildings, distributed network infrastructure, smart operation of assets using optimal control and ML techniques, some of which he will describe as part of the session today, and also in smart trading and portfolio optimization techniques in energy markets, which I think Dr. Venkatesh will also cover today. So thank you so much for being part of this panel today. And last but not least, I would like to introduce Neeraj Dasila. He has more than 7 years of experience in a variety of new age technologies. He's worked in multiple capacities with Government of India, at NITI Aayog, and large corporations as well. He's one of the founding members of a highly award-winning CleanTech startup in Switzerland, that is Smart Helio. He's an alumnus of IIT Bombay, specialized in electrical engineering, and he's absolutely passionate about the innovative application of technology for a better and sustainable world. So thank you, Neeraj, for being here with us. And I will just, if you could just give me the share access, please. Sunil.
Yeah, Chengappa.
Oh, yeah. Okay.
You have
Thank
it, sir.
I just thanks a lot. Right.
Thank you.
So just give me a second while I get this ready. So I hope my share is visible. Is it okay?
All good.
Yes. Oh, we can.
It's okay?
Yes.
Yeah, we can see this. Yeah, thanks.
Okay, all right. Thank you. So, yeah, as part of today's panel discussion, we have a very rich and diverse background of folks. And what we thought we would do is, to shed a little bit more light around the use cases of ICT in clean technologies at various layers of the stack, right? Starting from extremely low level physical hardware and so on, all the way up into the pure application space, right? What are the different use cases where, different solutions, sample solutions are using them? And as part of this discussion, also to look at, what are all the opportunities that remain to be solved. I think some of the previous discussions did cover that. But would like to get some perspectives from our panelists today for improving the effectiveness of ICT when it comes to clean technologies. So that would be the trend for today's discussion. And if we net look back as to why all of us are here today, right, is primarily around energy efficiencies, looking at clean technologies to address the impact of climate change, right, which is really an energy imbalance in the entire planetary system owing to human activities. I'm sure a lot of you have heard about this, and the previous sessions have covered it fairly well as well, right? So I would like to start off the session and hand it over to Neeraj. So Neeraj has a lot of experience, and it's part of a very innovative startup called Smart Helio. So Neeraj, if you could take us through some of the use cases that your organization uses as part of solutioning ICT in clean tech, and all the motivations that you have as part of this effort and what drives you. I think that'll be a great start, and then we'll move on to Venkatesh and then Sudipta and then myself to round it up. So over to you, Neeraj. Thank you.
Yeah. Thank you, Mr. Narayan, and thank you very much for setting up the context, and thank you very much for the stellar introduction. I really appreciate it. So before jumping into the multiple options of ICT or the low-level data acquisition systems or the systems that are basically work as a warrior for data acquisition or in the entire digital value chain, let me treat a couple of highlighted or starting points that are more associated with the renewable energy. So if we just take an example of a 300 megawatt solar plant or a solar park, it will have around 1 million or more solar panels. And these 1 million and more solar panels are just small individual independent units that try to generate energy. So when we have a complex system with millions of independent energy units performing independently, generating electricity or energy independently, we need a system that ensures that these individual small units operating at the optimal point. And in order to ensure that, we will be requiring a massive digitization support that allows us to capture information from these individual small units. So this is one requirement. It's not like a conventional thermal power plant where the centralized generation is happening at a location and its geographical footprint in terms of generation or the generating unit is very, very less. It is not like that in solar systems or even in the wind farms. There will be multiple small units generating electricity in a distributed manner from different locations. This is one problem, and if we do not do it well, so it will create multiple negative impacts and problems in our society. One analysis by PV Magazine says that most of the independent power producer in their current global practices dump their solar panels whose performance degrades permanently by 5% or below. And keeping that particular trend in future, it says that by 2050, around 10 to 20% of total global e-waste will come from solar panels. So now there is a question, if we have solar panels, are we moving ahead towards a cleaner world, or we are just replacing one problem with another problem? So there are a couple of new challenges with this new change that we might have or we are having. So how we can handle this particular situation. If we do not manage these small units at the unit level itself, it is going to be a problem in future. This is what the current asset managers or IPP challenge is. So keeping that a particular challenge, as a company or as a technocrat, we believe that designing, developing, and deploying affordable devices that can go across these up panels to make sure that these up panels are operating at the optimal point. This is the requirement for the moment, especially for the solar system. So that's why we believe edge computing and these IoT devices can play a vital role. Locally collecting information, locally analyzing the information, and then managing the device in such a way that these operate at the optimal points as per the local condition. This could be the future, and this is the future in order to go forward and break the barrier of these renewable energy assets that is going to come. So keeping that in mind, we have created a sensor, or most of the companies, organizations, or research institutions are looking forward to design certain devices that does edge computing at the source to process the information and then federate that information in such a way at the local level so that the maximum information being transmitted in a very sustainable and effective manner so that these panels or these assets operate at maximum operational efficiency. So this is one of the way to move forward, and although it is going to play a vital role with the cloud part, because cloud will be providing the necessary information maybe on a periodic basis how to operate, when to operate, but this is the way in future. We will be requiring devices that allows us to manage billions or maybe millions of devices at a time in real time and together. So the entire system for us looks like a social order, not the real social order, but the renewable energy social order. Instead of having a centralized control, the way we have in the ICT right now, one cloud and then multiple data points, but entire operations and processing of the data is happening at the centralized cloud. We can have a much more federated, democratic cloud system where these independent small units processing information and independently generating insights as per its local requirements. So this is something that we will be going ahead in future, and this will be the solution that will come ahead with renewable energy in future to make them more effective, more sustainable.
Oh.
Yeah. So this is the highlight on this particular thing, Mr. Narayan. So maybe the second step might be taken care by Deepta.
Yeah, sure. Thank you, Neeraj, for and giving us, specific focus, especially on the edge compute needs, on specific form factor sensors, and compute, intelligent compute devices at the edge leading into the cloud. I think that's very important. And so, Sudipta, over to you. To talk about the next layer of the stack in terms of connectivity and so on.
Thank you, Narayan, and thank you, Neeraj, for the detailed insight. So today's panel discussions, I'm just going to brief about how we look into the energy efficiency when it comes into the picture of the mobile network. So in the previous session itself, Mr. Jairam from Ericsson, I was listening his talk and it was very inspiring indeed. So when we bucketized basically the mobile network energy efficiency, it is very important that how we should plan the energy efficiency in a mobile network. The first thing is that resource allocation, which plays a very, very crucial role there, like increase the energy efficiency of a wireless communication system by allocating the radio resources in an efficient way is a very crucial problem to resolve. As we are heading towards the 5G and beyond 5G, and in another few years might be the 6G. So there is a substantial increase of the mobile handset and the client devices, and which actually targets the more energy expansion, and it requires also more energy consumption as well. The next thing which plays a crucial role is the network planning and deployment. So when we deploy an infrastructure nodes in order to maximize the covered area, per consumed energy, how we should plan it on. How we should plan on the use of the base station, switch on or switch off algorithms, that plays a crucial role. And moreover, if you see, the 5G network is now the software driven network. So the third bucket which we can consider is that the energy harvesting and transfer. So to operate any communication system, this basically applied to both renewable and clean energy sources, which we are targeting as part of the ICT challenges here. So radio signals are present over the air. So whatever energy sources you are using, sun or wind energy, anything, the radio signals are present. This is a major interest in developing countries where we are basically using the power grid, or not only using sun or wind energy. We need to consider that the radio signals present over there, how we can best utilize it. The last but not least is the hardware solution. So whenever we call about the energy efficient hardware solution, how this broad category has to be strategized, how this can be simplified over the RF chain, how this can be simplified over the transmitter receiver structures. When we talk about the radio access network, or when we talk about especially that the quantum network for the next generation, or network function virtualization, this part of the problem is basically plays a crucial role in terms of the energy efficiency. Now, let us understand what Cisco plays a market leader role over there. So Cisco proposed a circular economy in terms of the energy efficiency. So what does it mean by the circular economy? You design, you provide the solution, you establish a circular ecosystem leadership, and moreover, the circular consumption. This is our motto from the Cisco side. So when we talk about IoT integrated with circular economy, basically target to the digitization of the grid, which increase the efficiencies across the entire network, which actually leverage more renewable energy sources that promises to deliver high levels of reliability. The second option, which is that Cisco Silicon One. Cisco as a global market leader, our solution of Silicon One could save up to 580 kilowatt of energy, and it promises up to $9.75 billion energy saving cost as well. Third, but not least, that the design once used everywhere. So devices with low energy usage don't need cooling or heating to be maintained. So we design the system, or we design the devices in such a way so that it can cover up anywhere and everywhere across the globe. Now, let us understand a spatial use case where Cisco CleanTech technology plays a crucial role. So the Cisco CleanTech technology basically promises to have an automatically optimize the wireless LAN for reliability and performance. What does it mean actually? If an interference resource, or whenever the transmission is happening over the radio frequency channel, if the interference source is strong enough to completely jam a Wi-Fi, the Cisco CleanTech technology, through its tight integration with Cisco radio resource management, promises to switch the radio frequency channel in such a way so that the customer operation or the devices are being operated will not be interrupted. It automatically detects the channel outside of the affected area, and it switches the channel over there. The CleanTech technology also promises to perform remote troubleshooting. So you do not have to get connected over the actual energy level to be consumed for the deployment. So your deployment happens over the Wi-Fi network with the zero touch consumption. So that promises that we are basically not using or consuming a havoc amount of energy, which can cause the network performance to be reduced. Last but not least, at the same point of time, the Cisco Clean Air technology also monitored the air quality for the entire installation or entire network deployment in a 24/7 way and generate alerts on customizable anomalies. Keep track of device temperature monitoring, predict cooling effects, ensure the environment-friendly option to be facilitated. And if you see the entire stack behind here, controller, mobility service engine, and WCS, everything is getting operated in a backend by an reliable algorithm. So it consumes
I'm sorry if other folks who are participating can kindly mute. Thank you. Yeah.
Thank you, Narayanan. So it's basically consume fewer IT resources with automatic interference mitigation. So the wellness deployment ensure zero energy consumption. And that is where we play a very, very crucial role over there. What we basically promise as part of the next step, Cisco's approach for a green world, it extends from how we design, build, and deliver the products. So any software or any software-driven network, how we design, build, and deliver, we always target, we always value the assets, have to turn them into the new products, targeting to facilitate a green world. Our support towards the customer, that the technology where customer would like to use the circular transformation technique, there we always are ready to help the customer understand their need and convert it into their goal-oriented product. Last one, the circular economy matters. As a society, as part of our ICT goal, we are using more natural resources at this point of time. As we move from 4G to 5G and beyond 5G, our planet cannot regenerate that amount of natural resources we are planning to consume. So we can't keep taking without giving it back. So a circular economy is really important at this point of time because take, make, and waste model, and that actually aims to redefine the growth by focusing on positive society-wide benefits. The measurable impact which we are targeting to complete by 2025 is like 100% of Cisco products and packaging that we are trying to make it as a recyclable. They are 20% of our target is to packaging the product in a more efficient way, and 75%, these are all couple of data that we have targeted to achieve. From there I have taken this. So 75% we are targeting to reduce the packaging cost. We also promise our customer that renewable stack and product. So as we supply the things, the customer complete the usage of the product, we are ready to take it back and make it renewable as well. So that is how we as a Cisco, part of Cisco, we are innovating and we are deploying the circular economy to contribute towards the green world and green economy. Over to you, Narayanan.
All right. Thank you, Sudipta, for covering certain aspects, especially related to the RF side and the clean air technologies. I think you mentioned some things about silicon chipsets as well, which are well integrated and low power. So just to connect from there, so moving on from Neeraj, you covered about low-level sensors and edge compute technologies, so with connectivity. So next to Dr. Venkatesh from TCS, who will take us on from here. So over to you, Venkatesh.
Thank you, Narayan. Thanks for the introduction. Am I audible?
Yes, you're fine. Thank
you.
Okay.
I'm going to sort of share some slides. Hope it's okay.
Please do.
Is it, are you able to see my slides?
Not yet.
Okay.
Yes, it's coming up.
Okay, great. So, so I'm going to talk about, a few minutes about, ICT in the context of electricity grids. Okay. The reason I put this up because I just wanted us to see the big picture. So what primarily what this is, these graphs are telling us is, renewables will go a long way in terms of reaching our climate goals. Number one. Number two is some of the traditionally brown loads like transportation and industry. They will become greener by adopting electricity as the fuel. Okay, so we are seeing greening from two ends. Green electricity being driving, traditionally brown areas as well. Okay. Now the challenge here is, unlike like with any other resource, this generation is not distributed equally. There are some places where there's a lot of sun. There are some places where there's not enough sun. For example, many of you might have heard this project. They're planning to connect Australia with Singapore via undersea cable to harvest the solar power from Australia. Similarly, UK is planning to lay a submarine cable to harvest solar power from Morocco. So there are some projects like this across the world where they want to evacuate clean energy from one place of generation to place of consumption. So grid is going to play a crucial role here. Now the challenge here is, unlike water, unlike gas, in electricity, the way the grids have been designed is that your generation and consumption should always match. Storage has not picked up to a great extent as we wanted to. So when renewables sort of kick in, we get variability in supply because wind blows and sun shines as per their own whims and fancies. They don't they don't bow to human wishes. So there is variability in supply, and we have demand side consumption variability as well. We are going to have newer loads like electric vehicles, maybe things like even heating, the likes of which the utilities have not seen before. So we have unknown demand, we have variability in supply coming in, and still the grid is tasked with balancing these two variations in real time. Okay, so what this primarily indicates is that, the sense, analyze, and control cycle that typically all of us are used to in a lot of domains should happen at scale, at a high speed in the case of electricity. And sensing is what, Neeraj was touching upon. We talked about edge computing, edge sensors, etc. devices. And Sudeepta, she talked about taking this data to a centralized place where analysis and control can happen. And I'm going to maybe touch upon the actual applications, give a couple of applications wherein, all this come together to deliver something useful for the end user in terms of making the world greener. Okay. So, a couple of sort of, green applications that we want to talk about. If you look at the left-hand side, primarily what this means indicates is all of us know wind farms where we have an array of wind turbines installed. And these wind farms, they harvest wind power and then they generate electricity. Okay. So what happens is just like any other, fluid dynamics. Let's say when a plane takes off, as soon as the plane takes off, we have what is called as a wake effect or turbulence. When a ship goes in ocean or a lake, we see those waves emanating from the edges of the boat or the ship. That's the wake. That's turbulence. Okay. And what happens is this turbulence happens even in wind farms as well. And unfortunately, this turbulence is very detrimental for the turbine blades which are downstream. They are going to create a lot of fatigue or stress on the turbine blades. They will reduce the amount of green power that can be harvested, so on and so forth. And so what we are trying to do is, can we apply some machine learning techniques to control the blade angle, the turbine orientation, so that the effect of this turbulence is sort of reduced. Okay, again, remember this has to happen at scale for all the turbines in the wind farm in real time as the wind is blowing. Okay, so we have an application which has to sort of take data from these sensors which are there in the turbine blades, and the turbine, these sensor would communicate through some RF or something to a centralized system, and all the the magic masala should happen in the centralized cloud to change the orientation of the turbines, and that's what we do. And so what is the result that we're able to get? We are able to improve the energy that is harvested from this wind farm by, let's say, 7 to 10%. And we are also able to reduce the stress or the fatigue on the turbine blades. So how does it help us? It helps us by extending the life expectancy of these wind turbines by another 5 to 10 years. So people who have already sunk in some dollars in wind turbines, they can continue to sort of reap the benefits for for some more time. So in some sense, we are prolonging the life expectancy of green renewable generation without degrading the usefulness. Okay, that's probably the first application that we wanted to talk about. So just to give an example of how sensors, communication, and control come together for a common cause. Okay. The second one is along the same lines, but in a more larger scale. Okay, so all of us have, let's say many of us have, at least in Bangalore, maybe in Chennai as well, rooftop solars. We have solar panels on our rooftops. Some of us have batteries as well, electric vehicle. I know Narayan has an EV. So very soon all of us will start having EVs as well, electric vehicles. So in smart grid parlance, we call these guys, these entities, as distributed energy resources. So these are resources which the grid can tap into at times of need. Okay. And so what we are trying to do is we are trying to develop, again, control technologies which can orchestrate the behavior of operation of these energy resources, of course using sensors, communication, and control, so that these guys can provide required services for the grid. Number two, when these guys provide the services, the grid is going to pay them back in terms of some revenue or some profit, right? So we are also working on strategies of what we call as market participation. How can these energy resources come up with a way to price their service that they are offering to the grid? Okay, again, we are trying to use ML algorithms here. As with most things that are happening elsewhere, we are creating sort of using sensors and then the communication technologies. We are building digital twins, not for individual assets, but for the entire electricity ecosystem. So the idea is we want to study how the individual assets, how they interact with each other for the greater good. Okay, Neeraj and Sudipta talked about individual assets and the communications part. We are looking at a slightly higher layer where we are looking at the orchestration of all these assets together as a single group for a greater good. So let me stop here and probably, I'll come back to you if you have any more questions here. Thank you.
Okay. Thanks a lot, Venkatesh. That is a very insightful sets of applications. What I really liked was, the combination of physics in terms of wake turbulence, combination of technologies in terms of AI and ML, and all these has a good impact. 7 to 10% is very impressive in overall efficiency improvement. So that was really heartening to see, plus the examples that you gave from a grid analysis. So thanks a lot for that. And we'll come back to all of you in just a second. I will just round it off with a very quick example when it comes to the EV space. I mean, EV space I think is reasonably well understood in India. So while I was leading the development of Sun Mobility's first battery charge and swap station, traditionally EVs fall into two categories in terms of fixed or swappable entities with respect to lithium-ion technology, at least, right? And ICT plays such a big role everywhere, right? Starting from the battery and battery management systems and optimizing power control, keeping a close watch on battery thermal characteristics, stability, and so on. ranging into the swap and charge stations, where it just not only provides the user experience, but also very, very importantly, thermal control and safety for all these batteries, right? And life cycle management, right? So how do you make sure that there are no anomalies in charge discharge cycles, whether the battery is actually in safe and healthy condition before being sent back to a customer. There's a lot of analysis of data and metrics. And like what Neeraj mentioned, if I just to connect the dots, there is edge compute investments in these fields as well, in order to process data in real time, so that swap stations and charge stations are just as autonomous as your regular petrol stations, right? Yes, the cloud is there everywhere, that all of us know, but that's mostly for post facto large network operations and so on, right? So the applications of ICT is in clean is pervasive everywhere. I think the previous speakers have all talked of different areas and different applications, right? Now, if I was just to take a deep dive a little more, right, and we'll probably come back to this in a couple of minutes, right? Along with ICT, yes, there are sensors, there's RF, there is chipsets, but then there's software as well, right? And I think there is, a space for talking a little bit about software stacks. I'm not going to go into this in any detail, but the software aspects of ICT in clean actually, in my opinion, play a much larger role and is a little bit underestimated, right? And the reasons for that I'll come, because software stacks have to, connect the dots together between sensors, between your edge compute, between your cloud, between your data metrics, in order to derive intelligible output out of it, and to provide, hopefully, a net negative energy sum in the total game. That's where it is important, right? So software stacks, like this, this is something that I had used and developed while I was at that organization. But these are things that play a big role, right? And software plays a big role in overall the clean technology space. So one more example of mobility and ICT, just extending this to aviation, right, is, taxi bots which are electric powered. These save a lot of fuel burn in busy airports. This is an example here on the left at Frankfurt Airport. ICT plays a role here, not just in powering the electric machine, right? Also in terms of scheduling, optimizing when the engine should be shut off, when it should start up for safety checklist prior to takeoff. A lot of that goes into the operations of these taxi pods. I believe Bengaluru Airport has also piloted this, right? And another innovation is around using the existing auxiliary power units in aircrafts, which is the big noise at the back of the aircraft, when you board, right? To power electric powertrains for taxi in lieu of taxi bots, right? So this too requires a fair amount of intelligence and maintenance. And when you look at the overall life cycle of an aircraft, once it's ready for departure to going ahead, right? So the application of ICT is pervasive everywhere, right? And what I would like, perhaps the audience to also take away is that while we look at technology, whether it's RF, chipsets, aviation, electric vehicles, it's a combination of ICT know-how along with system domain know-how. For example, how does a solar farm actually work? What are the challenges in that, like what Neeraj briefly touched upon? Or like what Dr. Venkatesh talked about in wake turbulence, and the real system issues in running that, and how ICT can be used to address some of them. Or like what Sudeepta talked about from the RF space, right? It's not just software and hardware alone. It's a combination of the entire domain knowledge, right? So with this, I would like to, open the panel for a few observations or thoughts around, where they see additional new opportunities in terms of further enhancing the current sets of solutions, and where we could go forward. So if any one of you would like to touch upon that, perhaps Neeraj we could start with you and then move on. Yeah, please go ahead.
Yeah. So I think the biggest transformation that is happening in the energy space and its application, it is increasing gigantically. So it will increase. It will replace all the conventional energy application in whatever way it is possible, or attain some sort of big pie share out of it. So when that is happens, then there will be multiple devices, independent units that will be requiring ICT intervention, local ICT intervention. And if we have some computational infrastructure, some sort of centralized system, it might need not be the only solution. We might need have some democratized distributed computational networks and frameworks that allows us to locally process and design solutions for such assets. So in future, we might have a universal framework, a universal protocol like Android or Windows for these IoT devices or these edge computing devices, where they are not just sharing information, but they are also sharing their computational memory, computational space for doing some complex computational activities. So they are sharing their computational power for doing some complex calculations. So at Smart Helio, we have initiated such observations and such research activities with our certain products, where we are using a network of 10 to 15 devices to do certain complex algorithms together, where a certain section or the piece of algorithm is being run by a device, the remaining section is run by another device, and then they are sharing their outputs in real time with each other to generate some valuable insights for these panels. Then in that case, even if there is no permanent or good network availability of these devices with the cloud infrastructure, they themselves are capable enough to make decisions locally. So this will be the real autonomous assets or real systems when these devices will be able to manage themselves locally. So this is going to be the future, because in future the devices will be in millions of number, especially the energy devices. The infrastructure is going to increase in gigantic number. So we need to adapt certain solutions that can accommodate the future need. So this is something that I'm thinking, not only democratizing the data acquisition, but also democratizing the computational work or the computational load, the decision-making load. And if we make it locally, it is some sort of replication of the social order that will happen in the energy space. Instead of a centralized stuff, it will be a more democratic, more federated framework or ecosystem that might be sustainable. So this is something that might grow in future, and I think this is something that will come very quickly as we move forward with more and more renewable energy in future.
Excellent. Thank you so much for those insights. Deepta, any further thoughts?
Yeah, so RF space, I just want to highlight that the concept of radio frequency harvesting, okay? So when the energy get transmitted over radio waves, that can be captured and used on the client device or parts of the underlying infrastructure as well. Now, understand one point, that when we talk about the radio frequency signals carry both information and energy. So theoretically, if you think the scenario that it is possible to harvest some energy from the radio frequency signals and receive some information from the same input. Now, a lot of research is happening on that particular space, which is known as SWIFT, the simultaneous wireless information and power transfer, where it says that the hardware required for this is still under development, and there is a rate energy trade-off between the amount of data and energy derived from a signal that is still under the research field. But if you see theoretically, the SWIFT will never charge your smartphone wirelessly. Don't consider that as a concept. But on the other hand, if we adopt this approach, it can offset the power consumption required for data transmission on the client device. And that's a very good use case that we can consider in the RF space. Another thing you can consider, that the backscatter communication. So with so many mobile devices, so many electronic devices deployed in the network, at this point of time, the backscatter communication, it is relatively a little bit novel thought at this point of time, because a lot of research is going on that particular field. Australia is the first country who are all basically looking for the backscatter communication at this point of time to be utilized. But if you consider that the backscatter communication to be used, or the method that uses the incident radio frequency signal to transmit data without a battery or power resource, this is another use case which surely can be taken care of for low power and low complexity devices to be used across the network. Both sender and receiver at the end of the day cannot transmit simultaneously. So if you can build up a half duplex communication system, so it will actually save massive amount of energy across the network. So these are two use cases I think we can surely think about with respect to the communication system.
All right, excellent. Thank you, Sudipta. It's almost like a circular energy economy between transmission, right? All right, Venkatesh, your thoughts, please.
Sure. I mean, so since I look at a holistic point of view, putting things together, I want all the small guys to talk to each other. A challenge that I foresee is privacy. People's respect for privacy will make this task a bit more challenging. The task of controlling different individual devices towards a holistic goal of stabilizing the grid, that will become challenging, because if no one is willing to share sensitive information which is needed for controlling, obviously it's going to make the task a lot more harder. So that's something, privacy is going to be I would not call a hurdle. It is a challenge which we need to overcome. Privacy is as important as the grids. It's not, we cannot trade off one for the other. Both are important. That's one thing. Second thing is cybersecurity. Gone are the days where people hack into servers and Windows machines or Unix machines or whatever. Now we're talking about real grids. These are cyber physical systems. People can hack into a grid and shut down the grids completely. There is a movie, Die Hard 5 or something, where they call it a fire sale, quote unquote, where the guy takes over the entire infrastructure. Those are the things which are kind of which can become possible in the future. So that's something we need to watch out for. Yeah, that's all. Thank you.
Okay, cool. Thanks much, Dr. Venkatesh. And I think we are also pretty much at the end of our allotted time. So I really thank each one of you for this vibrant panel discussion. I'm not sure if we'll have any time for any questions, or we will be happy to take perhaps the questions offline, Sunil, if that's okay.
That should be fine, because we fully utilize the time here.
Yeah.
Let me thank for this wonderful panel discussion. Thanks for moderating, Ryan.
Yeah.
Thanks for all the panelists as well.
Sure. And
thanks a lot, everyone.
Yeah, just to sign off, right? I mean, finally, all these initiatives that we are doing is to have a healthy partnership with the environment, right? And as long as all of us keep this as a goal in mind for ICT and clean technologies, finally, this is the final goal, right? Because we need a healthy environment in order to survive, right? And with this, I'd like to thank the panel and thank IEEE and the excellent organizing committee. Thank you, Sunil, Ashok, Prashant, and Chengappa. So over back to you.
Thank you.
Thanks a lot, everyone.
Thank you. It's our pleasure to host all of you. Yes, please, Dikshita.
Here's a small token of appreciation from our side now. Thank you, Sudipta ma'am. Thank you, Venkatesh sir. It was really great session. Thank you. Thank you, Neeraj sir. It was a really interesting conversation. Thank you. Finally, thank you, sir, for moderating the event so well. Thank you, sir.
Thank you very much.
Thanks a lot from IEEE Bangalore Section and IEEE BTC committee as well. Look forward for more interesting discussions and presentations in future.
Moving on, next we have a talk by Pia Tanks. I'm sorry about the pronunciation. So Pia is a sustainability and a corporate responsibility professional with 20 years experience from valued brand in global ICT business, both in B2C and B2B. Passionate about topics such as recycling and circular economy, sustainability, innovation and value creation, volunteering and engagement. Proven track record in successfully performing and delivering results in climate targets, innovation operation strategy, management systems, environmental reporting and marketing communications, as well as working together with academia, industry and NGOs. Experienced leader for local and global teams, both in matrix organization and as line manager. A team player who really enjoys bringing together a group of experts for creating something new and meaningful. She believes technology can really help us in solving global climate challenges. A warm welcome to you, ma'am. Over to you.
Okay, hey, thank you. Can you hear me well?
Yes, ma'am, you are audible. You can continue.
Okay, thank you. So if you can share the slides. So
It's
I
coming
will...
up. Yeah. Hope you can see it, Pia.
Okay, great. Hey, very happy to be here and talk about Nokia's partnership with Planet, with environment, and how do we see we can, what kind of impact ICT industries and digitalization and connectivity can have for us to work towards better societies, better livelihoods, happiness of people when making societies more resource efficient and benefit from the digitalization. The picture is actually from Helsinki, so greetings from here, Finland, Helsinki, where I'm sitting. I'm working with Nokia here in Helsinki office. So if you go to the next slide. You all have seen these pictures, and this is a climate change, and the increasing temperature is a very topical issue now when we are all reading news about the COP conference in Glasgow that will start next week, where countries again and the leaders from all over the world will get together to really look how can we work together as countries, as companies, as societies, as individuals actually limit the global warming. So I really believe that's the responsibility for all of us, not only for governments or not only for individual people or not only for companies, but really everybody together to look for the opportunities. How can we change the temperature rising curves that we see? If you look at the next page, climate alone is not a topic that we need to tackle. Move to the next page, please. So resource usage is another alarming issue for us that we face as an industry. I don't know if you come across the very interesting reports called circularity gap. And this is an analysis that is being published now every year to look at how much resources we as countries and industries all over the world are consuming every year. Everything that all the resources that we need in order to build up our cities, to build up housings, to run our industries, and how much of that is actually being used again, so circulated. And the gap is actually 91% based on this research. So from the resources that are being used, only 9% is being circulated back to use. And this is quite obvious that things can't continue like that. There's an impact to climate, but there's impact also on getting access to materials that we need in order to keep our societies up and running. The next slide, please. So how do we look things at Nokia? I typically describe our impact to environment and what we can do using 3 different dimensions. So if you look at the very inner circle of things, that's the traditional company approach on how to manage its environmental impact. So these are the things that are, how do we design, how do we work as a company in our logistics, in our supply chain, in our own operations, our own factories, to minimize the use of resources, to be as efficient as possible. These are the things like being energy efficient, changing light bulbs, making more efficient cooling systems, using automatization, minimizing the waste in everything, recycling. All these are things that we need to do in our own operations to be as eco-efficient as possible, so to minimize our operational footprint. But of course, that's not enough. That's actually rather small thing even for a big company like Nokia, who's operating in more than 120 countries. So, if you expand, we are 85,000 employees and then work with thousands of suppliers all around the world. But really the big impact for us comes from the products that we are designing. So Nokia is in the telecom infrastructure business. We are the ones who are making fixed and mobile network products in order to enable the digitalization of societies and businesses. So our engineers who are designing telco equipment, networks, systems, software, hardware, that's the place where a lot of the important decisions happen actually when it comes to environmental topics. So designers are designing products to be more energy efficient, and it's about the whole system design. It's about making changes everywhere in the system, shortening the cables, integrating cables and devices, introducing new chipsets that are more energy efficient, making smart software that will make the products sleep during the nighttime when there's no traffic needed as much as during the daytime. So product design for environment is really important. This is the energy efficiency, it's the material efficiency, it's substituting those materials that should no longer be used in the products. And it's making the products such that our customers also benefit when they are operating the networks. So telecom infrastructure, you all know, it's running 24/7, day and night, and our customers are the ones who are operating the systems. So energy efficiency is a very important point for them as well, not only because of the sustainability commitment, but also because it's reducing the OPEX costs when we talk about power consumption. So operational impact for making sure that the whole value chain is working as efficiently as possible. Then the product design, making sure that the products we design and put into market and that our customers are using designed by using eco design principles. And then we have a third dimension, and that's the impact to societies. So digitalization helping societies, helping industries to be more efficient, making agriculture more smart, more precise, making mining industries less wasteful, safer for employees, making factories smarter to just produce what's needed in that particular moment, making logistics more efficient, reducing emissions there. And there's been studies on the impact of ICT industry in general, and typically they say that the positive impact of the industry is about 10 times bigger than the negative impact. So really the strategy for us and for the industry is to minimize the footprint and maximize the handprint. So bringing benefits to societies, to individuals, and then minimizing the footprint that is needed to deliver the data and the connectivity. And if really looking probably like 10, 15 years back, there's so many amazing examples of the new business models that digitalization will bring for us as individuals, like sharing economy. We can get access currently to a lot of the entertainment businesses just by subscribing to digital services on music, on television, on actually reading books. So digital services are replacing a lot of the goods that we used to have as an ownership for in the earlier days. And the same transformation is happening for mobility services. Many people say in the coming years we don't own our own cars or even bikes because we get an access to good mobility by using good digital platforms and service models. So really exciting to see how the innovations of people by using for both for the technology design but also for the design of the business models will actually make our societies more sustainable and more resource efficient. Sustainability today is quite a lot about frameworks and data. So I have a couple of logos here to talk about important frameworks that we are following and that are important for us in our sustainability journey. United Nations Sustainable Development Goals, for sure, it's a topic area which shows where the whole world needs to be moving on. ISO 14000 management system standards help us to be systematic in how do we manage our environmental programs, how do we manage target setting, data collection, making sure that everywhere where Nokia operates, we have the same good principles in place. Greenhouse gas protocol is a framework that explains how to disclose your climate data, so that everybody is doing it in the same way using similar principles. It's a little bit the same like we have seen in the financial data. There's certain systems how companies are disclosing their profit and loss accounts, and the same is coming for sustainability data disclosure as well. We actually today are facing a lot of questions from our investors, from banks, from all over the world to say, what are your climate targets? How is your climate data? How is your performance? And for that, we need to have a very good, credible systems in order to disclose the data, have external audits, assurances for our data sets. Science-based target is an initiative that Nokia did join in one of the first 100 companies all around the world in 2016. And we have set ourselves long-term climate targets, and those are now according to 1.5 global warming scenario. And that's to halve our emissions by 2030 across of what we do. CDP is a climate disclosure program where we are disclosing our climate data every year, including risk opportunities, governance models. And then we have increasing amount of regulation for ICT to talk about the substances, talk about the product, extended product producer responsibilities for waste, and many more. So if you go to the next slide, please. So environmental programs are rather wide. They cover all our areas, as I have explained, from our suppliers to our own operations and then product-related design topics. So this is an example of our significant environmental aspects, and we have divided our programs into two categories. One is related to energy and emissions, so climate topics, and another one is more like a circular economy related programs with usage of natural resources and waste related to those. And then depending on the area, surely we have different kind of integration of our internal processes, like how do we work with our suppliers, how do we audit suppliers, what kind of requirements we do set. And then processes related to our own operations, what kind of car fleet we have for our services or for our employees, how do we manage our own laboratories, R&D laboratories, and then for the products the similar way. So different kind of approach depending on the business area that we work with. And like I quite often have said that sustainability and environment is a really interesting area to work with because you really get to see everything what's happening in the company. You are working together with everything from the operational part to R&D to customer specific questions and so forth. So environmental topics are integrated into every aspect of the company. The next, please. So I was talking about the data already, and I just have seen so much how much more important data is coming all the time. And there's a data hierarchy. How do we actually look at our sustainability data? I've already mentioned the protocols, GRI standards and GHG protocols, who are giving guidance for companies how to disclose your data. We have internal data handbook that gives them exact information or the instructions how Nokia is looking at this data. What are our boundaries? What are the IT tools where we are collecting data? Who are the responsible persons? And what are the emission factor sources and every detail of the data collection. And then for specific data types, we have external assurance who's then looking our data and making the quality checks and making sure the data is correct. And this is extremely important, as I have described now, when we have a lot of stakeholders from customers to investors and other parties to see who wants to see how we are proceeding against the targets that we have set ourselves. Next one, please. So I already a little bit described about our climate targets. So science-based climate targets with Nokia are such that we have set ourselves, and these are being assessed and approved by the Science-Based Target Initiative. And this is to halve our emissions between 2019 base year and 2030. And we have also made a commitment to be carbon net zero with our emissions by 2040. So there's a lot to do across all the areas that I have described. On the bottom of the page, you also see Nokia's carbon footprint. So this is the data that we do put together every year to reflect the current business that we are having at that particular year. And there we collect the climate data across all the business areas, even from the employee commuting to our business travel to our operational footprint from offices, R&D laboratories, car, marine fleet, and then to supply chain, and then the product use time emissions. And interesting thing from the chart is that if you look at Nokia's carbon footprint, 90% is coming from the product use time emissions. So when our customers are using our products. These are so-called scope 3 emissions. So naturally, when setting a target, this really requires a collaboration between us, our customers, and then the energy grid, because getting emissions down is, you can impact that by using more renewable electricity, but then surely making products more efficient, you are using less electricity. So it's a collaboration between our customers, ourselves, and the electricity providers. So as mentioned already before, collaboration is really important in reaching any of the sustainability environmental climate targets. The next page, please. So here I have collected a couple of recent milestones. We do publish our sustainability report every year, where we do talk about the milestones and achievements and the targets from the previous year. So a couple of points here. I mentioned the CDP, the Carbon Disclosure Program, and there I'm proud to say that we are included in the leadership category, so A ranking. We see a lot of reductions with the new technology, getting products more energy efficient. So 5G base station power consumption average 50% improvement in the efficiency. A couple of weeks ago, we did release our new FP5 chipset, and that improves 75% in power consumption per bit. Modernization is always good, so we see more than 50% reduction of efficiency when modernizing the legacy networks with the new more modern products that are using multi-radio technologies and so forth. We are using a lot of renewables in our product packaging. Average about 85% of the product packaging is renewable. We still have plastics there to protect the product, especially in the marine transportation. Just this week, we actually launched a pilot when we are shipping our 5G products from China factory to German hub with the zero emission flight with Lufthansa. So this is a really exciting new opportunity to reduce the logistics related emissions. We do have a take back service for our obsolete products, and we are able to we take our spare parts, we use components, parts from our old products. A couple of weeks ago, we actually did talk about a program that we are doing together with Orange, our customer in France, to use refurbished equipment in their network. We are less than around 1% of the material that is collected back from market is landfilled. The rest, 99%, we can either reuse, recycle, or recovery through our partners. And then maybe the last, but for me very important milestone is the use of recycled metal content in the new products. And we did a project together with a lot of our partners, with our suppliers that are supplying aluminium cast parts for our products. Those are used as a heat sinks. And we found out with the detailed collaboration with them that around average 54% of the aluminium that was used in our heatsink is coming from the recycled content. So very important step in closing the material loop in telecoms. And we continue this work and look how can we increase even the amount and then increase this approach to other materials as well. And then the next one, please. So design for environment, I already did talk about a little bit, but a very important program that we have. And there I have taken an example of the customer-facing document. We want to be proactive on how to share information on the environmental benefits and features, if you like, of our products to our customers. So we provide a document called Environmental Product Declaration, which gives information on the product-specific carbon footprint, recycling instructions, energy power consumption, substance and material content of the product, packaging materials, how many grams of different materials, and so forth. So this is the document that when our customers are looking the products that they are purchasing from us and what are the different environmental questions that they are interested in, then we have already collected and shared the information with them in this Environmental Product Declaration. Then if you go to the next page. And circular products and services, recent press release with Orange is one example of the collaboration we have with our customers. So as our industry is fast developing, we have legacy technologies, we are bringing new technologies. So we offer to take back the old products from our customers, and we are able to use spare parts from those products in another network, in our repair services. And then when there's really old products or the products that have been somehow, they are not really functional, are not repairable anymore, we are working with electronics waste recycling companies to collect the materials from the products and then close the loop in that way, putting materials back to circle. Then the next one, please. And this is the last slide. So my title was Working Towards Zero Emission Digital Societies. So the previous examples have been pretty much on the how to minimize the negative impacts of the ICT and telecom industry, but then positive impacts are many. And one example on the left-hand side is the recent year with the Corona and COVID pandemic hit us. So surely we were able to keep on working and collaborating because of the services like we are now in this virtual meeting phase, and then traveling less. and not even going to the office. And interestingly, that was seen, of course, in our data that we do publish when the business travel went remarkably down, no emissions there, but then the usage of the virtual meetings were growing really a lot. So even though already before when Nokia, with Nokia Context, we're working together with our colleagues across the countries, across the continents, but with the pandemic, things got even more challenging in that way. But we were able to cope because of the good services in telemeetings and then reducing the business travel. And then the other picture is very small. You can't see the font there, but that's the sources from the GSMA, looking at all the different areas of business and the society where digitalization can bring benefits. And there I'm very optimistic and looking to see the new exciting things that we will see in the coming years. How can we make other industries, other areas of society more sustainable by using digitalization in the smart way, as smart as possible to benefit both us as humans and then also the environment as our important stakeholder. So thank you very much. And I think this was my very last slide. Thank you.
Thank you. Thanks a lot, Pia, for walking us through the bigger picture, which impacts the society at large, right? So I'm checking the chat if there are any questions, but while we wait for those questions, I have one question for you. In one of the slides, you mentioned 90% of the maybe emission CO2 footprint is from solid products, right? And you have a target to reduce 50% from operations and products. So that reduction, is it how it is related to operations versus the products, that 90% of the solid?
Right. So it includes also the commitment as such is Nokia as whole, so including our so-called scope 1 and 2 emissions. But as I have shown, the majority of emissions are from scope 3 and they are from the product use time. So that's the priority area, and that will really help us in reaching our target and also if not then not reaching. So it really the majority of emissions are coming from product use, but the target 50% is consolidation of everything. So we may balance between the different beaches, for example, many different product lines that are included in the target, and they are moving forward in different speed. So because the development in the area, you have let's say a new chipset, you don't get that every year for each PG. So it's a balancing act. Maybe this year another business group is doing more, the next year another one. So as overall, Nokia is then looking to reduce 50% by 2030. But everything included there from scope 1 to not all of the supplier operations are yet there, as the data quality is not as good as possible there yet, but included everything from scope 1 and 2, and then all products and logistics and final assembly suppliers.
Great. Thanks a lot for your wonderful session. So this is the last invited talk for this particular session. So let me hand it over to Dikshita.
Yes, sir. Thank you. Thank you, ma'am. It was a really great talk, and it was our pleasure having you with us here. We have a small token of appreciation from our side. Thank you, ma'am.
Thanks a lot from IEEE Bangalore Section and BTC organizing committee.
And thus we come to the end of session 2 of BTC 2021. The session 3 will begin at 6 p.m. Request everybody to join using the same link. Thank you everyone for joining.
Thank you so
Thank
much.
you.
Thank you, ma'am.
Thank you all for joining. See you all in the evening.
Bye bye.
Okay, so I think once again I will extend warm good evening to the participants from India and good morning to people who are joining from the other side of the globe. So I am Devdeep Sarkar. I am from ISC, and I welcome you all to this Young Professional Global Summit 2021 at this IEEE Bangalore Technology Conclave BTC 2021, which is our affinity group, Young Professional Affinity Group at Bangalore, is hosting in association with the IEEE Bangalore Section. So, I mean, as you mostly know by now, that the BTC has kick-started today, and it features young achievers in domains of technology and entrepreneurship. And the plan is to, in a way, enthrall you with a two-day virtual experience. And you can see the type of events that are going on in different sessions. So in this YP Global Summit, we have two actually aspects. One is, I mean, we are going to have the illuminating keynote talk by Professor Dipanjan Gop, whom I am going to introduce formally in a moment. And the second mega event will be the fireside chat with the IEEE Bangalore tech icons, although it's virtual. So where we'll learn from the experiences and deliberations of the tech icons, and like to get the guidance from young professional perspective in terms of building up their career. And I think Neha and Soma madam will take care of that fireside chat. So before even we begin, let us take a brief moment to appreciate the efforts that has been taken up by our entire BTC team, and also especially for this particular session, the YP Execom members, starting from Neha, Ketan, and Chengappa, and Gitangsh, Samarth, and who have, I think they have contributed a lot and spent hours to make this entire organization successful. So I probably, like, in this short time, I could not name many of the student volunteers and all the people who have worked from the backdrop, but have silently worked to make. So let us appreciate them a bit before we start. So do we have, I think if Gitangsh is here in the, I can't probably see our YP chair at this moment. So anyway, Neha, you would like to say something before we start?
Devdeep, you can continue. I will take it in
Okay.
second half.
Okay.
Yeah.
Okay. You can take it. Okay. So anyway, so let us start with the first part of our event, where we have Professor Dipanjan Gop, who will be giving the keynote talk. And I will just read out his bio before I share the podium and hand over the podium to him. So Professor Dipanjan is an associate professor in electrical communication engineering department at ISC Bangalore, and my senior colleague here. And he received his PhD and MS degrees in electrical engineering from the University of Washington, Seattle, and BTech in electronics and electrical communication engineering from the Indian Institute of Technology, Kharagpur. So Professor Dipanjan is also co-founder and CEO at Simyog Technology Private Limited, which is a spin-off from ISC and focused on the design and the design of tools for automotive electronics and many more applications. And his research interests lie in the areas of computational electromagnetics and electronic design automation. And he is also the founding member for Nimbic at Nimbic, acquired by Mentor Graphics now, a spin-off from the University of Washington, Seattle. So this is the brief bio. So without further delay, I would hand over the podium to Dipanjan, and please proceed with your talk. Thank you.
Thank you so much, Deepthi, for the long and kind introduction. I will just share my screen. So in this context, I wanted to basically share some of the experiences that are in our ongoing journey of entrepreneurship. Right, as Deepdeep mentioned, I'm a faculty at IISc, and with a few students of mine, we co-founded a company called Simyog, where we focus on emissions of a different kind, right? I noticed that Bangalore Technology Conclave 2.0 is focused on clean technologies. So we are looking at a clean electromagnetic environment. And I want to For the first few minutes, I want to take the opportunity to talk about the kind of problems that are coming in terms of emissions, electromagnetic emissions, in primarily in automotive or also other systems as well. And then for my young for the young people, some observations from the journey, ongoing journey of entrepreneurship, and of course then to answer your question. So what's happening today, right, is that the IC sits in a PCB, in a printed circuit board, and the printed circuit board goes and sits inside a system like an automotive, right? So I mention this all the time that if you look at an automotive, right, around 20 years back, you would see that not even 5% of the automotive would be electronics, hardly anything electrical, maybe less than 5% of the bill of materials would be electronics or electrical. Right? Today, it's around 30 to 50%, and in future with electric vehicles, it's slated to go up to around 70%. So in our lifetime, we are seeing a transition of a primarily mechanical equipment into an electronics and electrical equipment to that extent. And this is not just happening for automotive, right? Entire IoT and sensors and all that. Even a toaster has a lot of electronics now these days, right? So all systems are getting electronics embedded in them. This brings a challenge of electronic verification, right? And which typically, 10 years back or 20 years back, you would look at the IC companies like the semiconductor companies like Intel and TI and others doing electronic verification primarily, right? Now, a lot of these system companies also have to worry about electronic and electrical compatibility and other issues. So what is the issue, right? What happens is that, so if you look at this automotive, right, there are around, let's say, 150 to 100 embedded systems, what we call electronic control units inside a high-end car, and they would be all hidden in the upholstery where you can't see them, but they are connected to each other by cables, what we call harness inside the automotive. And automotive is just an example. If you look at the electronic landscape, at the bottom or as a horizontal is the semiconductor industry led by Intel and TI and others, right? And on top there are the systems companies, automotive, then aerospace and defense, then medical, then industrial, then IT and communication. These guys, right? Electronic compatibility is becoming a key aspect of their day-to-day design. When you make such an embedded system in a lab, and it may actually function very well when it is working alone in a lab, but when you put it in an environment like a system, because of the noisy electromagnetic noisy nature of the environment, it starts malfunctioning. I'll give you an example. So this is this is, let's say, a Cypress touch sensor, right? And a lot of this you will see. The idea is I'll have a video that plays here, right? So, right, the idea here, I'll play it again, right? If you press a button, one LED is supposed to glow. When you press another button, another LED is supposed to glow, right? Nothing spectacular, but such capacitive touch sensors are used pretty much a lot in pretty much all industries. Now you see what happens is that when you take it to a laboratory and inject some artificial noise, right? This is an electromagnetic laboratory, the EMC laboratory we call them, right? And you're injecting some noise on the cable that brings this cable that's connecting it to the other equipment, let's say. Then even without anybody present nearby, right, or anybody pressing a button, the LED turns on, as if there is this is called a false touch principle or false touch phenomena, and it's an EMC phenomena. You can imagine that in a safety critical device like an automotive, this can be a big issue, right? Where will this noise come from? Why are we artificially injecting a noise? Well, the noise is everywhere in the system, right? So for example, this is another laboratory test of a touch panel. Such panels you will see a lot inside the automotive, like the dashboard where you touch and all that. Such touch panels also work on capacitive principles in this particular case. And because you have electric currents running down a long path, they start behaving like an antenna and radiate. And this radiation can couple to your other devices and can cause safety critical issues, right? And that's what we wanted to look at. This issue is actually, after the battery technology, this is one of the key issues in electric vehicles as well. What happens in an electric vehicle, as many of you will be very familiar with, there is a DC-DC converter, right? So first of all, there's a battery that's like operating at 300 volts or 400 volts battery, right? And then typically the inverter, right, which is driving the motor. The motors are typically induction motors, right? AC motors like Tesla kind of not the Tesla company, although Tesla company also uses an induction motor. So that you need an inverter to convert this DC-DC to convert this DC voltage into AC to drive the motor. Plus, you need a DC-DC converter to to transform this voltage into lower voltages to run the electronics, right? Electronics runs at 12 volts, the motor at higher voltages and so on, right? So the problem here is that if you look at the power electronics domain, then we are going for faster switching rates, right? Even 1 megahertz of switching is not unheard of these days, right? And why do we do faster switching? Because we want to make the components smaller, right? The filter elements can be smaller if you switch faster. And the unwanted implications of this is that the DC-DC converter and the inverter are all radiating, right? They're all spending out, just like your phone is sending out electromagnetic waves, which can couple to your antenna, cause problems, which can couple to your touchscreen and cause problems, and so on, right? So this is a challenge that we are as electronics and electrical engineers need to tackle for the future. This is a problem that is going to be quite pronounced even when optical communication comes into the picture. The power supply will still have this issue. So this is one example that we worked with one of the OEMs in Bangalore itself, right? And what was happening is the DC-DC converter, right? The green lines are the low voltage and the red lines are the high voltage lines. The green line, there's some noise getting generated because of the switching of the DC-DC converter. And when operating the DC box is actually coupling that noise to the high voltage line, and that's causing a problem on the what we call LIS, and this is actually your wall charger. Imagine, a noise being injected by let's say you connect your car for charging, and some noise gets into your your house power supply. Then there'll be a problem with other devices, right? So there are some standards and all that you have to follow to do that, and the car companies and the automotive electronics companies are striving to meet that. Well, have you heard of such problems before? Well, there are some that comes out, right? So for example, in 2014 in US, primarily in US, there was a huge callback of a recall of Toyota vehicles. It was showing unintended acceleration problem, that without pressing the accelerator, the car is accelerating, and it was later found out that EMI is a major issue for that. With electric vehicles, you may have heard these funny stories of Ford cars stopping near a place, near a particular Walmart and stuff. In fact, Tektronix listed, EMI/EMC as one of the key challenges when it comes to realizing the Internet of Things. More electronics being packed together in close proximity is a recipe for such problems. If you look back, this is not a really new problem. This has existed in the military domain since 1980s, right? We wanted to pack a lot of electronics on the rocket head, and those, but the difference is that they were not mass produced, right? So now the challenge is, how do you design properly such that the thousands of units that you generate come out without a problem, right? So the way the industry handles this, I'll talk about that in a bit. So this is the crux of the sort of the academic way of looking at the problem. The area is called electromagnetic interference and electromagnetic compatibility, EMI, EMC in short. And the way it is divided is that it is divided into a 2x2 matrix of sorts. One is radiated, one is conducted, which means the emission is coming through air or it's coming through copper. And then a goodness of a duty, right? So emission and immunity. Emission means, let's say, as a device, how much are you shouting or how much are you obstructing others? And immunity means, as a device, if others are shouting, then can you still go on doing your work? And in here, of course, shouting is an analog of electromagnetic shouting, or the noise that the electromagnetic other devices are bringing in the electromagnetic environment. So this is how the industry handles it today, right? There are lots of electric vehicles on the road. How are they handling it? Is basically the OEM will tell the supplier, the electronic supplier, that make your pressure sensor, but before you can sell it to me, you go to a lab and standardized labs. They are called AMC standards. Lots of them are there, and you test under these standard conditions by injecting noise, etc., that it's still working fine. Get the certificate, and then you can sell it to me, right? And today the challenge that comes in is that 50% of the devices that the electronic manufacturer is making is failing the first time around, and 30% of the problems in the verification is coming from EMC. Basically, you imagine you have your product ready, it's working very well, functioning absolutely as you want it to function. However, you cannot sell it because it's failing EMC, right? And that's one of the compliance tests that comes into the picture, right? And that's the challenge that we wanted to solve as a team. This is us at EC, EC Fountain at ISC 4 or 5 years back. So we started a company called Semioc Technology in 2017. The mission was basically to bring in agile for hardware. Like if you look at semiconductor companies, they use a lot of simulation tools to verify their designs right at the beginning, right at the before the tape out, so that there is no problem as such. When you tape out, it will function exactly as you designed. However, such is not the case for system level, and that's what we are trying to bring in. So the idea was that you have these physical laboratories that's there. Why don't we make this, virtualize these laboratories, right? Make it in simulation, make it as a simulation tool, such that the designers can run it before a product has been made, right? Advantage of that is you can today, for example, a lot of this work, I would say 96% of this work happens after a product is ready. You have to take this product to the laboratory, you fail 50% of the time, you fail, you go back, find an expert, get some advice, redesign not redesign, but put some fixes in place and take the hardware again, and then hopefully you pass, fingers crossed. Otherwise you try it again the third time, and that's adding like 12 months of extra time to your time to market, and that's causing huge problems when it comes to some projects are getting cancelled. I know that several such projects are just ending up in the dustbin because you can't proceed further, because it will need a complete redesign, which is at that point of time better than continuously doing this. So so we came up with a simulation tool that actually helps the designer check all of this in the early design stage, such that early design means very early, you'll have some time towards fixing this, right? And so our mission was basically, in the industry terms, it's called a shift left strategy. We have developed or in the middle of developing the world's first virtual EMI EMC laboratory. We focus on diagnosis, like if you fail, then what do you do? I mean, some suggestions to the designer that this is where you could change stuff. And design for EMC means basically do it early in the design stage, right? And the way, without going too much into the details of how we achieve this, we use, of course, physics-based solvers. These are all computational electromagnetics and circuit solvers. And then also, you know, in one of the key missing pieces today, electromagnetic solvers have been there for 30 years, but what has been the key missing ingredients are some of these models, like, you know, how does the IC contribute to this system, right? So we make machine learning based IC models. That's a discussion for another day. At the end of the day, if you combine these sort of techniques, then you can, you know, you can predict the current density. And then once the current density is predicted, you can actually predict all these radiated emissions and all that. In this picture that you see, the red line is sort of the emission levels. The black line is what your device is doing. As long as you're below that, you're fine, right? So coming back to the touchscreen problem that we talked about, this is something that we worked with Cypress. The black line is the noise that, you know, reaches the IC, and the red line is, you know, how much noise the IC can tolerate. So you can see that the measurement failures we are able to actually predict using simulation. So that's our goal in terms of emission as well. We are able to correlate quite well with laboratory results that enables a designer to pass the first time around in compliance and sell the product right at the time when it's ready. Right? These are some of the customers from the tool and some of the press that you know, we've been involved in. So, you know, finishing up, right? I mean, these are some of the observations from a journey, right? And this is particularly, you know, directed towards my student friends here in the audience, right? And Bangalore, this slide is maybe a little bit older. The percentage is probably more today in terms of the this is the amount of funding received for startups. So you are definitely in the right place. I think none of our predecessors had this advantage. You know, that the VCs are actually looking at deep tech companies in Bangalore and in India is a new thing, right? And at the right time. And I think that's very clear from the number of unicorns that we are generating in the ecosystem in India as well. I mean, throughout India as well. I think, you know, a lot of these are sort of area specific advice, but one thing that I found that's very relevant for from our experience in the last 5 years is that there is a disconnect of what you think the users will actually do and what the users actually do. Actually, this is not my statement. This comes from Steve Blank. I just realized this. And so, you know, as quickly as you can move from the technology aspect to the product aspect, there's a big difference between a technology and a product and a company. So, you know, it's important to plan it well. I'll give you an example. This is my last slide. So this is some cool technology that we built using virtual reality. And the idea was that the virtual laboratory should be, you should be able to feel it, sort of a thing, right? And you can actually go inside and look at a PCB. In 2D, it doesn't look that well, but if you're really wearing that virtual reality glasses, you get an awesome feeling, and you can look at current density and all that kind of stuff inside. Very, very attractive from an academic sense. I mean, I loved it. I loved developing it, love using it even today, right? But from a user perspective, right, when you're thinking about designers that are actually trying to tape out their design tomorrow or send it for fabrication, they don't have much time to do this, right? This is this is a great academic teaching tool, but may not be a great success when it comes to directly selling. Of course, maybe there are customers for this among different communities, but for us this was not the right investment of our energy at that point of time. So it's important that that part of it is what I would like to advise you on, that you get the customer feedback very early, and I'll try to make it a little bit faster so that you can see the current density and all that we are interested in from an academic perspective, right? So yeah, I think and as usual, with this last slide on suggested viewing and reading, I like to close my presentation. Thank you to the entire organizing committee, the panelists, for inviting me for this talk, and I'm happy to answer any questions you may have. Thank you.
Yeah, so thanks very much, Dipanjan, for this exciting talk. I mean, the final like slide. I mean, where you showed the animation. That was quite interesting, and I did not see that probably in your earlier presentation that you gave in the EC webinar series. So this was new for me, I think. Yeah. So, so do we have any questions from any of the participants or panelists? You can please feel free to put in the chat box. I mean, then we can take it. Before, I mean, while that is done, I have like one or two questions, Dipanjan, that I would like to ask. One is, you mentioned about the clean electromagnetic environment, right? So, how to like quantify? I mean, is there a way to quantify that part? Like, when would we say that it is clean enough?
Yes, I think, as you're, so there are two parts to this. One is clean for human, one is clean for other electronics, right? So the clean for human, I think there are standards on SAR and other aspects, right? I think meeting them is quite, interestingly, right? If you look up, I found out that you're supposed to hold your phone 1 millimeter away from your ears. Nobody does that, right? So those kind of things are there. But the work that we are doing, we are actually more focused on the the effect of the environment on electronics, and then there are a plethora of standards. I mean, more than I can even recollect, right? Both in terms of emission and immunity. Now, interestingly, I mean, an interesting thought for my for my friends here is that I recently heard one of the automotive companies come and ask me, "Hey, do you do lightning tests?" I said, lightning tests I have heard of for aircrafts and all that. Why is it relevant for you? I said, no, we are making flying cars. So an evolving journey, right? But there are a lot of standards, right? I'm not involved in some of these standards committees, right? But I do follow some of the standards that are there. It's typically in the form of EMC standards and then SAR for human health.
So, and another question, I mean, slightly non-technical, but still I would maybe like to hear from you is some of, like, if you would share some of the early experiences or early challenges that you might have faced while establishing Simyog. I mean, you started it some time back. So maybe just, I mean, a small glimpse towards that journey.
The challenges is only increased, Devdeep. So, I think it is nothing compared to some of our predecessors that went through, let's say, 10 years back. Right now, the ecosystem in Bangalore and India worldwide is much more conducive to people wanting to do something, in this area, right? So nothing compared to what has happened before. But I think the challenges every day, I feel the challenges are increasing. It's basically about scaling and product. I think the jump from technology to product. I knew it was going to be challenging, but it has been more challenging than I estimated, right? So how can you have dumbed down? I mean, there has to be a lot of IP and technology underneath, but the user should not see it, right? So that has been, I think, one of the key areas.
True. Yeah. So do we have like any of the like maybe panelist or any one in the participant?
Yeah,
feel free to, I think, unmute and yes.
Could I just ask a question rather than typing it up?
Yeah, sure.
So this tool or virtual lab that it kind of reminds me to the early days when I used to do PCB designs and then chip designs. And I remember, encountering some of these EMC problems. Those were the days when the first 8-layer board, I think, in India was done by us at CDOT. Okay, and we did not realize the kind of going from 1 megahertz to 10 megahertz clock on the board, what kind of EMI/EMC issues would come up, and it took us a while. It was called black magic in those days, right, to solve the EMI/EMC at the PCB level. And then similarly, I remember doing a chip, and we had massive with multi-layer metal, okay, and so then the similar problems crept up which we had encountered at the PCB level. So there is a lot of science to this now, in the EDA tools. And I expect what you're doing is probably you're trying to create the same thing at a subsystem level and embed it into these EDA tools, right? Is that the
That's right,
direction in
madam.
which you're heading?
Yeah, yes, that's right, madam. I think, if what is the comment? I mean, the general perception is that, if you're simulating something smaller, right, just at, let's say, the PCB level or parts of the PCB level, people would believe in simulation because they have seen simulation and measurement match. One of our challenges is that in this domain, because, a small 1 nanofarad inductance here and there coming from the cable, coming from a connector can change your emission level. So there is definitely, I mean, I'm a big believer in simulation. But in order to capture all this sort of room level phenomena, that is what becomes challenging, right? And you're absolutely right. It is basically scaling the ability to simulate from an IC to a PCB to now a sort of subsystem level. And also the OEMs are looking at full car level problems. So that's definitely one of the challenges. And I would say that, I think number of people who believe that simulation really works in EMC has increased. But still, I would say they would form 10% of the experts of EMC would believe that this could be simulated. So this is interesting.
Yeah.
Right,
Any other questions? Yeah. Okay. If not, then I think let's thank Professor Dipanjan once more for sharing his valuable time with us and giving this nice presentation and also answering our questions. So I think we have this virtual memento kind
Thank
of
you.
thing. So
Thank you.
yeah. So
Thank you, Devji. Thank you, all the organizers. My pleasure. Looking forward to your fireside chat.
yeah, sure. So okay. So we'll then
request, can we have all the panelists switch on their cameras for a photograph?
Sure. Yes.
Atit, please help take screenshot. Alok sir, okay. Ashok Das sir, Chengappa, Rajek. Okay. Thank you so much.
Yeah, thanks all for joining in the virtual photograph session. I think that's what we have to get satisfied with due to this virtual event and all. Anyway, so I think we'll move to the fireside chat section with tech icons. And as you can see, I think the vice chair of IEEE YP Bangalore Affinity Group, Neha, will take over the proceedings. So I'll briefly introduce her. Neha Kumari, BTech in Electrical and Electronics Engineering, is currently Deputy Manager with Reliance Jio and leading the testing of 5G devices. And she's a passionate technologist with 6+ years of experience in device engineering, and she has worked on 4G, IoT, and narrowband IoT devices. And as I said, she is our current YP Vice Chair and Young Professional Technical Coordinator in IEEE India Council also, if I'm not wrong. And previously, she was with IEEE Bangalore Section YP Treasurer and also won the awards, several awards. And we also worked together in Connect, and she received, I think, the Champions Award as the sponsorship chair. So she dealt with a lot of tasks there. And so I will not lengthen it, and I think I will hand over the podium to Neha, and you can introduce the tech icons. Thank you.
Thank you, Devdeep. Good evening, ladies and gentlemen, and young professionals. Thank you for joining us today. Today's session is extremely special to us. Amongst us, we have some of the great industry veterans. They are just not experts in their respective fields, but also hold a special place in IEEE Bangalore section. They are our IEEE Bangalore section tech icons. Thank you so much for joining us, especially Pamela ma'am, you're joining in quite early in the morning from California. So thank you so much. A little bit about the Tech Icon series. IEEE Bangalore Section Professional Activities Committee takes pride in sharing the Tech Icon series, which aims to ignite the educational, technical, and professional aspirations of student members and young professionals by learning about the career journeys of successful technologists. We have been hosting this series for past few years, and in today's chat, we have been able to invite some of our tech icons to share their knowledge and experience with our young professionals. My co-moderator for today, Dr. Soma Pandey, is the heart of the series and is an active volunteer of IEEE Bangalore Section Professional Activities Committee. With more than 20 years of rich industrial experience, she has mainly been working with IoT, embedded systems, AI/ML, and she is currently General Manager at Geo Platforms Limited on engineering IoT sensors. She has been the member of IEEE for the last 13 years and senior member for since 2016. And she has served several IEEE volunteering positions, be it in WIE, ComSoc, or be on the Exicom committee of Bangalore section. She has also won several awards, IEEE ComSoc Women in Engineering Champion Award and IEEE Women in Engineering Outstanding Volunteer Gold Award by IEEE WIE. Thank you so much, Soma ma'am, for co-moderating this session with me, and welcome. Moving on to our tech icons. Our first tech icon for today is Pamela Kumar. Can we have a slide? Thank you. Pamela Kumar, Director General, Telecommunication Standards Development Society, India. Also the founding chair and current president of CCICI and Bharatiya Chair Visiting Professor at UIET Punjab University. An alumnus of PEC Chandigarh, Rutgers University, USA, and IIM Bangalore. Pamela ma'am brings with her an experience of 35 plus years in R&D roles at AT&T, Bell Labs, Texas Instruments, IBM Labs, HP Labs, and Center for Development of Telematics, where she has led many nascent projects into breakthrough business, notable amongst in the design of single chip solution for 2.5G feature phones at Texas Instruments India, which enabled the development of 1,000 rupee phone, leading to the second telecom revolution in India. Pamela ma'am has held various honorary positions, be it the Vice Chair of 3GPP PCG, member of the IEEE SA Nominations and Appointments Committee, member at large IEEE Standards Association Board of Governors, Chair of IEEE Charles Stenmas Awards Committee, General Chair of IEEE ANS Conference and ComsNet Conference, and Coordinator Industry Relations for IEEE Region 10, Chair for IEEE Computer Society, and Vice Chair of IEEE Bangalore Section. She holds 3 patents granted by USPTO and has 5 applications pending in the networking accelerators domain, and she has been a keynote and invited speaker in 90 plus local and global forums. Thank you so much, ma'am, for joining us and being amongst us. Our next tech icon is Dharmendra Kumar. Can we have his slide? Dharmendra Kumar holds a bachelor's degree in aerospace engineering from IIT Chennai and master's degree in aerospace engineering from IISc Bangalore. He started his career at Vikram Sarabhai Space Center in 1990 to 99, and from 99 to 2012 he worked at different organizations serving GE aircraft engines, Pratt & Whitney Canada, Airbus, Rolls-Royce, Toshiba, Siemens, Hitachi, Hyundai, and so many. He is currently working at Reliance Jio as the Vice President since 2013. With his he coordinated the aerothermal design of GSLV. He also has been part of the team which laid the foundation of reusable launch vehicle program, multi-domain exposure, aerospace, gas turbines, steam turbines, and so many more. At Reliance Jio, he is involved in end-to-end management of various electronic products, be it feature phones, smartphones, point of sale, printer, tablets, and he has exposure to the development of a wide range of products. Thank you, sir, for being amongst us, and welcome. Our next tech icon is Alok Nath. Dr. Alok Nath is a corporate vice president of Samsung Electronics and chief technology officer of Samsung R&D Institute India in Bangalore, where he is responsible for Samsung's IoT data platform and advanced service. Dr. Day is considered one of the most influential CIOs, CTOs of India. He's the recipient of the Alexander Graham Bell Prize in Canada. He has also received the IEEE Memorial Awards for Distinguished Contributions in Electronics and Communication, IDC, Insights Award for Innovation in Telecom, and the Zinnov Entrepreneur of the Year Award. He is a senior member of IEEE and a fellow of IETE, and Indian National Academy of Engineering. Dr. Day promotes science and technology linkages through IP creation, startup collaborations, and innovative solutions. In addition to more than 30 years of industrial and research experience, including Bell, Nortel, and ST Ericsson, where he was country director, he served as a visiting professor with IIT Roorkee and IIT Delhi from 2005 and 2011. Dr. Day holds a BTech from IIT Kanpur, Kharagpur, and ME and IISc Bangalore, and PhD from McGill University, Montreal. Thank you, sir, for being amongst us, and welcome. Our next tech icon is Vidya Hungod. She is currently with JP Morgan as the head of AI Technology India. She is a passionate technologist with 18 plus years of software technical and engineering management experience, delivering flagship products in US and India. Prior to JP Morgan, Vidya has helped Reliance Jio Platforms team in cloud journey as part of digital transformation, built and launched B2B enterprise product in Indian market, channelized engineering effort to achieve massive scale of onboarding 7 customers every second, moving up the needle with 380 million plus customers. Before Jio, she has worked on products like TurboTax, launched from San Diego, and led QuickBooks Online, geographically distributed teams, bringing in double-digit growth year on year on SaaS B2C product, also built Android application team from Bangalore. Vidya is a co-author of the chapter Digital Twin, Empowering Edge Devices, a keynote speaker, panelist in many tech conferences, including IEEE International Women in Engineering Conference, and one among 25 top tech women leaders of 2018 in GHCI. She is also an innovation catalyst, coaches IMB, NSRCL startups when needed over weekends, and was Agile board member at Intuit Point Consulting, 4 business units. Vidya has a Bachelor's of Engineering in Information Science and Engineering from Bangalore University and Master's of Science in Computer Engineering from San Jose State University, California. She resides in Bangalore and in India with her family. Thank you, Vidya, for being amongst us and welcome. So now I would like to hand over the stage to Soma ma'am to begin with the fireside chat. Soma ma'am, you're on mute if you're speaking.
Thanks. Thank you, Neha, for such a nice and wonderful introduction. We'll quickly move on to the chat. It's my pleasure and it's my honor that I am in company of such august panelists and audience. And as Neha has introduced and all of us have seen that we have a very diverse panel. Our experts are ranging from cloud engineering to aerospace to telecom and IoT. So nearly all the aspects of engineering we have covered in today's panel, and looking forward to a very, very interesting discussion today. Moving on to, so this, we will be focusing mainly on the expertise of our panelists. And I begin with Pamela ma'am. So ma'am, you have a very, very rich experience in telecom domain, and you have been in telecom industry as part of TSDSI and earlier also. My first question is about the emerging trends in telecom industry in India. So as you see that presently the telecom industry in India is the second largest in the world with 1.17 billion subscribers and 6.5% contribution to the GDP. So how is India impacting the global telecom scenario? I'd like to hear from you that how do you see India emerging in the global telecom scenario now?
Thanks for inviting me to this panel, and that's a good question. Let's just jump right into the discussion on that. So the way I see it, in India, I would say that we have had three revolutions in telecom. The first revolution, if you look back at the 80s and early 90s, we had less than 3 million lines of landline technology in this country, and we used to import equipment and install maybe 100,000 or so lines per year because that's all we could afford. Okay. And you would book trunk calls, and that was the model of communication. Then I think the first revolution happened when we formed CDOT, and we designed our own indigenous telephone exchange, which drastically brought down the per line cost of the network to install these equipments. And we achieved what we called that you could walk and talk, right? You could, within walking distance, there would be an STD booth and you could go and make a call. We brought in about 50 million lines of technology, and each call would be about a rupee or something like that to make a phone call. And we said that for a country like ours, maybe that's the best you can do in communications. And on demand, you could make a call and you could talk to people, But then, lo and behold, we had the mobile telephony, right? We got untethered, and we became free. We wireless with the wireless telecommunication, and throughout here, even in the CDOT days, I think there was a considerable amount of innovation, building an indigenous exchange, but it wasn't that we were setting the trend, right? The digital exchanges had been there since the 70s, and we brought it in only in the 90s, even though it was indigenously designed. Then 2G, 3G, we brought in a technology which had been designed, which was already standardized, deployed over the world, but we created a new business model, right? And we were able to deploy at affordable costs and reach, and it's all history and we know it. Although we put in this technology a few years later than the rest. The 4G story, we know how Reliance Jio created cloud native 4G and created the next third revolution, as I say. And now we are on the cusp of the fifth revolution. And how do we classify this the fourth revolution, right? The fourth revolution of what I call the 5G era. So if you look at the 2G, 4G, 2G, 3G, 4G deployments, I call it the lying down hockey stick, right? So technology was developed elsewhere in the world, and India started playing around with that technology. It took us a while, of 5 to 8 to 10 years, to figure out what's the right way of bringing it in India, the business model or any other changes. And once we figured that out, then the demand went exponential, because there is a huge latent demand and there are really no barriers to it. What we have seen in these eras of 2G, 3G, 4G, that every man on the street in the remotest village in the country just loves technology and embraces. It doesn't matter what is the level of education, what is the age, what is the gender, what is the language. People just love technology and embrace it and learn it and it makes a huge difference to the quality of life wherever we bring technology. So technology for socioeconomic development is the core, but we delay it to figure it out once technology is developed for rest of the world, for the developed economies, with a profit mindset, to bring it to a development mindset and make it affordable, make it reachable, make it consumable. We put the Hindustani tadka in it, as we say, to make it more palatable for Indian conditions, right? So that's been the model, and it's a long journey till we adapt these recipes for India. What we are doing in the 5G era for the first time is actually participating in the standards development, and we at TSDSI, I think, have been at the helm of this. So when we were sitting in ITU and 5G standards were being discussed, there was this usage scenario called the rural broadband, and for rural broadband they were talking about 500 km/h bullet trains in Chinese villages, and they wanted uninterrupted 5G throughput. And then there were these guys from North America and Europe talking about 125 km/h expressways going through their villages. They're zooming in the cars and they want uninterrupted 5G. Whereas in India, we have 75% of our population living in the villages, right? We want to give 5G to them. They may be walking, or they may be in a vehicle at 30 km/h. That's fine. And the villages are spread out at distances ranging from 6 kilometers to 10 kilometers between gram panchayats, and we want base stations placed at 10 to 12 kilometers apart and giving 5G to every citizen. So we had to introduce a new usage scenario meant for rural connectivity in our country, and ensuring that 5G reaches the villages first. That's our mindset. That's what our socioeconomic development needs, right? And along with that, our innovators have developed technology, and we have then introduced a technology specification which has been ratified by ITU and recognized as 5GI, that we call it. And we are very keenly working with the telecom world to make it part of the mainstream 3GPP 5G, so that there is at the world level, a harmonized standard. So this is a new journey, and we've learned to play the game of standards, to bring our requirements and our innovation. We've not completed it, but this is a first big paradigm shift. And now that, so we entered into the 5G discussions very late, when the requirements were just getting frozen. 6 months before the requirements were getting frozen is when we entered the discussion. The discussion which had been going on for almost 3 to 4 years before that. For 6G, we have entered the discussion from day one. The first meeting in ITU on trends and technology and vision of 6G, there was a major contribution from from the Indian community. So we are on an upswing in telecom, and in the next few years you'll see some big changes. Our startup community, our researchers from across the various players in the ecosystem are coming forward, and I'm sure we'll be making a big mark in the years to come.
Wow, that was a great insight into. So I presume 5GI means 5G India.
Yeah, the I can be interpreted, it can be incremental or India,
Wow.
it's.
That's nice, really
but
nice.
but what is
So,
5GI is deployable across the world. I mean, and it's useful
yes,
across the
but
world.
it is
It's not
coming from
really,
India.
it is
That
just
is
that.
really wonderful. Oh, excellent, very nice. So thanks, ma'am, for this very interesting information, and I'm really proud of India. So we move to our next panelist, Dharamji. And Dharamji, you are coming from a rich background of aerospace industry, and you have worked for so long in this domain. I will like to hear from you that, as you know, that India is an emerging commercial and defense aircraft market, and it is expected to become third largest in aerospace industry. So how do you see the future of India in this domain? How are you going to see? Because now with Tata acquiring Air India and so much happening in aerospace domain, both commercial as well as defense, both areas, how do you see the future of India?
Thanks, Soma ma'am. Can you hear me?
Yes, I can hear.
Yes. So, thanks for putting in this formidable company of Pamela and Vidya and Dr. Dipanjan and all that. And actually lovely. It's a very, very, very warm feeling, and probably it's warmer since it is virtual, I would say, because I can see all of you in a different way, and all of you seem to be sitting right here in my drawing room. you know so let me take that question. So see, aerospace, I would go back to 84 when I joined IIT Madras for BTech program in aerospace, and it was very interesting, but a little bit depressing as well, that the seniors who used to there was some sort of very mild form of ragging at the organization, sorry, at the institute, and they would say, okay boss, you have selected aerospace, so where would you go? It would be HAL, it would be NL, and one of these places. And compared to the situation today that I work for Reliance, right? So let me take you some of these the aspects of the journey that the aerospace industry in the country has taken, and where we stand today, and what are the great opportunity that we have in that area. So see, if you look at like the aerospace and defense market in India, it is around year 2030, it is estimated to reach around $70 billion. Okay, so that is the kind of volume we are looking forward to. And then to add to the journey, actually government has introduced some of very I would say great facilitators in terms of Make in India program, and then we have the National Civil Aviation Policy and all that. And then, as I said, actually compared to the days actually when 84, now we have the players like Tata, Mahindra, L&T, and Godrej and all that, who are very, very aggressively participating in this area of work, right? And actually, if you look at even the government, the defense sector. So the compared to the days, early days, where actually they would buy, the MiG and this and that, so many aircraft they used to just buy. This shift now is, gradually it came to that we should have local manufacturing as licensed manufacturing. And then actually we have also come to where actually our Indian companies are participating as partners, right? So that is the kind of shift we have come. Now, actually, see, in every domain of engineering, aerospace, is not an exception. And then actually, we have huge talent pool. We have actually, I would say somehow actually the kind of background that we all come up with, there is struggle and there is, that kind of intense effort that all of us go through in our life. That Indians actually, I'm not sure, personally, I'm not convinced even Chinese, whether the Chinese can beat us. And you see that, some of the great, the organizations and their CEOs and MDs and the heads of all those organizations, they are from India, which is not surprising. And see, if you just walk across, even in a city like Bangalore, and then you see the kind of community that exists here. So actually, in the area of aerospace, when we talk about MRO, that is maintenance, repair, and overall, actually, which has become global now, right? So actually, the industry, though it exists in different parts of the world, in the same way, the MRO also has become global. And then actually, we have several advantages. I said the huge talent pool that we have. And then actually we have the cost competitiveness. Typically we charge less for our services, right? So, these are some of the things that bring a competitive edge to us. And, that is how we can take leadership role in all of these things. But then actually, if you see, there is that kind of opportunity, right? And in fact, even 70 billion that I talked about, that is not the end of it. Probably you can add several multiplying factors to that. But then there are challenges, right? So the opportunity exists. You won't get it unless you go through certain challenges, and there is certain preparation that we all need to go through. So let me take you through some of the challenges that we have, some of the major challenges rather. One is capacity building, right? So, the team which travels to China, even in our product alliance, and the kind of discussion that they give of the infrastructure that exists there, versus what we have here, sometimes we feel that we are not up to the mark. The reason here is that, see, if you talk about a field like aerospace, the capacity building, actually, it calls for very, very high level of investment. And not only that, to add to the pain, actually, it requires a long waiting time before the investor can get any significant returns from his or her investment. So that's a challenge. Now, other side, what we look at is, the different continents and countries, American, European, other, see, they have started, or rather they have been doing their consolidation, and, they are strengthening themselves. And now we have to face all of them as competitors, right? And then actually what happens is, we all know about China. I know the kind of policies and, all that they have, how they're able to attract foreign investment and foreign orders. See, there is actually, if we need to attract, or if we want to attract, the capital flow, what we call, that would require, a lot of things, like there should be ease of doing business and all that, So that is again a challenge. And then actually what we see that, in the the way actually we have tried to attract the foreign investment. See, a lot of big players like UTC, Lockheed Martin, Rolls-Royce, and all that, they have set up their own manufacturing centers in India. And, they have created their own supply chain, or rather they are creating their own supply chain. So any third, any new entrant, whether be it, like Quest and all that, actually they face, that these are big players, and, they have set up the local setup as well. So we have to look for areas of opportunities actually in different way. So I would come to some of that. And the other challenge what we see is that, see, the raw material that is required for the industry, steel, aluminum, titanium, and all that. Typically, like what has happened is the kind of vision, we had in our early political leaders and social leaders they had. So they have created a good base, HL was set up a long time back. But then if you look at the raw material side, actually even today we have a dependency on import to the extent of 70%, right? So, various reasons are there, and how we have not been able to focus on in-house R&D and all that, but that remains as a challenge. Now, some of the actions that I would like to, talk about is like, see, the policy, somebody like our beloved Prime Minister, Mr. Modi. See, the way he is attracting, the foreign countries and the heads of states, and some of the things that he has done. So we need to continue with some of those policy liberalization, and then actually, and and again actually see procurement lead time. Like see what happens is typically government, we know that we blame the government that things are very slow, and if you look at some of the big programs, the procurement time is in the order of 7 to 8 years. So now actually that has to be cut short, right? We cannot work at, and by the time you procure, then the technology becomes obsolete. Other point which I want to bring up is in a country like China, actually, it's also a big country, right? In fact, in terms of the geographical area, it is several times bigger than India. But then actually what they have done, not just in aerospace, in many other fields, that they have done centralization. So, there is a single, I would say envelope within which all contributors have been brought in. So that is something, again, we have to try here as well. And then, we have a few SEZs like in Chennai, Belgaum, Hyderabad and all that, but we need more of them, right? And then actually what has happened is that, see, we are always looking at, Pamela ma'am, she knows that we are always looking for the lowest bidder in any government tender. See, that is not always a right thing to have. So rather than having, saving a few dollars on the immediate basis, we should look at for the long-term benefits, infrastructure development and what you get out of that investment. And, I already talked about the rationalization and all that. The other industry, like even if you look at IT and IT-enabled services, the kind of benefits and all that they have got, in aerospace, we are yet to see that. So these are some of the challenges. So as I said, actually the opportunity is huge, no doubt, but then challenges are also huge. But actually the saving grace is that we are a country of very, very talented people. And not only talented, we are very hardworking people, let me say that. So with all that, actually, we already are a very, dangerous group of people who can grab most of these opportunities. Little bit of support is required from, somebody, some visionary like Modi ji and all. But then we are there, right? So that is the kind of, situation that we are in, and, there is no limit, and we can go anywhere. Yeah, ma'am.
So that was a very nice take on the future. So centralization, then cutting the imports and cutting down the procurement time. Yes.
Yes.
That is going to be the key factors to drive the bright future of our aviation and aerospace industry. So that was very nice input. Thanks a lot, Dharamji. Thank you so much. So next question is to Alok ji. So Alok sir, I see that you have been working in the domain of telecom and IoT for quite some time now, and you have very rich and very long exposure to these domains. So my query is that as you are aware that IoT is in both industrial IoT and consumer segment IoT, both the areas. Now, while industrial segment is driven by business values, because most of the times when IoT is applied in industry, the main idea behind is on cutting down the expenses or getting more value addition in the business area. Now, if you see about the consumer segment, then the key factor to drive IoT in consumer segment is the personal interest of the consumer. So mainly like health and wellness or connected homes or these kind of IoT domains are you have to have the end user or the customer should be having an interest to use these. Now, in Indian market and consumer scenario, how do you foresee the growth of IoT, and how is it relevant to a customer or end user in Indian scenario. What is your take on it, sir?
Thank you. Thank you. First of all, IEEE YP, organizing this in the evening. So thanks again, Soma and Neha, for hosting it and anchoring this. I was with rapt attention hearing Pamela and Dharmendra. You talked about IoT, but from Samsung, in the 4G LTE with the Reliance Jio, we've been able to help in building these solutions, whether it is on the device side or in the network side of it. And currently working on the 5G. And, this week there is this TSDSI deep tech dive, and I was giving a keynote on the 5G for private networks, which actually connects as a 5G as a service, but also the IoT. I mean, as you are asking the question, could be connected through that through various verticals. And we have a lot of different products that connect to that. But let me come to your question on the IoT specifically that you asked. So for me, IoT is Internet of Things, but I kind of jokingly call it integration of technology. Yeah. Because it's about app, it's about cloud. Now we are talking about edge computing, it's about connectivity, it's about data platform, it's about building services. So if you ask what skill set you require to build it, it will be very different. And so that's what we do it. Coming to your consumer electronics, yeah, obviously Samsung has been having digital appliances. We kind of categorize into three classes. One, I call it elephant class. In the home, you might have a TV or a fridge, and these could be acting and some of these digital appliances that are sitting there. The second category, it's like a horse class, which trots with you, which is like your mobile phone, your watch, your earbuds, and things like that. And then third classes would be more of, the rodent class, the sensors on your windows or in carpets or wherever it is, which can sense it, put some signals, and helps in the overall ecosystem to build. So that's a smart home if you take all of these components that are there. Now we have a smart things as a platform. We acquired a company in 2014, and then last 7 years around that, not exactly that, but over that we have built. And as my corporate VP responsibility, been building this data platform for IoT globally, not just for India, but overall responsible. And through that, we kind of see that today we have 200 million devices connected in smart things worldwide. And a good fraction of it is also in India. Now, when you do that, we need to build this platform to be very stable. So there are many challenges that come. So let me just throw some light on this. One of the things is, as people are buying more and more devices, today we see about 5 devices many people have who are connecting. But even if I take even 11 to 20, these kinds of numbers are there in some homes. Obviously not in India too much, except some of the people, those who are experimenting with that. But this is a kind of thing. Now, as more and more devices come on board, I have to find a way that becomes easy onboarding, because the number of devices are going to grow, and also the population that are going to be actually adopting, they would not be that tech savvy, right? They just need to connect and it should get connected. So if you can just somehow pair, and then the smartphone can take you to the cloud, to the Wi-Fi credentials, then it could be nice. Other thing is continuous authentication, right? This is a kind of problem that I just am this device, but again, I change the device, I have to authenticate again. So whole day goes in authentication itself, right? So we can't afford that. Therefore, how do you know that it is me who is using that same device? One time you can do a very secure authentication, but a couple of times you can do a loose authentications. Even 50–60% is most likely that it is you. Then we talk about how do you enable this. When I'm cooking in the kitchen, I can't use a touch phone, right? So I need to talk. So where do you do voice enablement? Where do you do touch? This is again a very interesting area, and the devices need to have the right kind of interactions ability to do that. Then I talk about smart automations. Some automations, is kind of when I wake up, can I get my coffee ready, or at least, turn on the coffee machine, or the geyser should be turned on. Some simple things. So IoT is about this, if this, then that, right? So then that is the automation part of it. But if this can be quite interesting and you can bring in some intelligent activity there. For example, if I want to detect, have I woken up? Now, problem is it may look simple, but you might turn and toss in the night. And if your geyser is turning and tossing accordingly, then it's a problem, right? So therefore, if you are really waking up, that detection is a hard problem. And this is where AI comes, and deep learning that we try to apply can be there. So it can be a simple conditions, but it can be also a very difficult and interesting. And that's how we bring the AI to the IoT, and we call it AIoT. This is one such example, but you can do through voice, video, data intelligence to do that. So as we are progressing into the IoT, today's problem was more of the interoperability. How do you make sure any kind of devices, something on Sigfox network or LoRa network, some Zigbee or Z-Wave, if you connect them, that it will work. And the way we have been working on various standard bodies, and I chair Open Connectivity Foundation in India, we try to embrace many such different networks that are there and bring them and build a middleware so that we can pull them into the IoT gamut of things. And many, many more devices are coming. And very interestingly, some of the applications like consumer electronics, you asked, like if I want to do a movie mode, right? If you're at home, the idea is, I'm doing all the time, whenever I'm sitting for a movie, maybe I'm putting my curtain down, I'm putting the TV on, and maybe some romantic light or whatever, some three things are always happening. So why can't I combine that and do this? Now that's a defined thing. But also as AI progress, you should be able to even detect some patterns that I am doing. And therefore, you could recommend to me saying, can you do this? Would you like to combine these things? Right? So this is the kind of things in which we are applying. And we see some tractions in India. Obviously, smart manufacturing has been already adopting in every places in some sense. But in the COVID time, we saw in lot of warehouse and logistics, the online as it grew, I think people have started adopting even in India very heavily on the IoT. And in smart home, we see a couple of specific applications very interestingly. In the other time, it was more about surveillance. If somebody is coming to your door and both of the people are working, nobody is at home, could you detect, is it really a courier boy, or is it a dog or a cat or an intruder? How do you differentiate? That's the video analytics that you could do to detect. From there, when people are at home, we see, this vacuum cleaner, robo vacuum cleaner that's coming and actually looking around. And this is becoming a hot selling product during the COVID time that we see. Obviously, people like us otherwise have to do the work. So it's better to buy one and free ourselves up. So these are some of the kind of things. And in India, we are seeing smart building. It got a little slowed down during the pandemic time, but I see a lot of builders are coming forward. There is platform that is ready. And hopefully, I think the new building that as people are trying to sell, the real estate, this is becoming one component that can I give you a smart, intelligent home with few devices connected, and then you can augment that over time. So I could go on, but I think I will pause here. Thank you.
So that was a real lot of information and lot of interesting information. So you say that if we have easy onboarding, and if there is a smart automation, and if we have interoperability support. So by the way, as you said about interoperability, we are also struggling a bit here, like trying to figure out how we can replace a Wi-Fi sensor with a Zigbee sensor. If supposing tomorrow, and it should happen seamlessly, and it should not affect the end customer. So yeah, so these are challenging problems, but yes, as you say, if it is resolved, and post-pandemic scenario is really going to, looks like it is going to be better and better, and it has really been good in one way for IoT domain. So because of social distancing and things like that, there has been a lot of traction. So thanks a lot for such a great insight in IoT domain, sir. And I'll also like to now move to our next panelist, Vidya. So Vidya, hi. You have. I'll just take a question from your expertise area, which is cloud engineering, and you have a tremendous amount of expertise in reliability engineering, cloud engineering. So the very much talked about topic recently is the crash of the Facebook server, which all of us have faced. And in fact, that night I was struggling terribly with trying to put across a message which was very urgent on WhatsApp, and it was just not going through. And I thought that maybe my internet connection is down, and I'm going and checking, and I'm asking, did we renew the subscription, and did we pay for the broadband connection? All those things. So now the thing is that this crash has somehow shown that how vulnerable big tech are and how dependent we are on big tech. So on the same context, can you share your opinion that how we can avoid such failures, or what can be done to mitigate such instances?
Thank you, Soma, and the rest of the panelists in this group. Thank you for inviting me here to talk about it, and also giving a controversial hotspot question and putting me on that. Yeah. So I think this is my individual opinion. Let me put that forward first, right? Having said, many companies have gone through lots of failures, and data centers crashing down and customers going through a huge downtime experiencing that. But one of the things that really stood out and put Facebook into trouble is putting everything in one box, right? Which you really don't want to do. They connected Facebook Messenger, Facebook and WhatsApp and Instagram to top it all, everything which is heavily used by consumers like us. Having said that, one of the things for sure was they didn't anticipate the broader gateway protocol versus DNS, like where you use the domain name server only for address, but not for really using it as a roadmap or a protocol to reroute the traffic, right? So if you get into the nitty-gritty details, there's tons of information on net for sure. People can figure out what went wrong. Of course, final statement that came out was stating that they had to restart a server due to configuration issues. Beneath, if you really go through the analyst's view, there's a lot more than that, right? For sure. So one thing they typically say as an old statement or the adage, right? You either pay for the product or you become the product. I think in this specific example, for sure, we are all products because we have given our data entirely into their hands, and no doubt, of course, our data is being used across, right? Not knowingly where it is being used, right? That's a ridiculous thing. So if I have to state candidly, of course, I want to move away from the centralized way of doing things, how they're operating. I think India has taken its stance, and also many other countries, they're fighting through the government acts and things like that. But we as consumers, we also can do our bit to not put everything in one share, as they say, right? You don't have to put everything into Google or everything into Facebook. There are alternatives for sure. So like if you look at YouTube, right? everything gets tracked. Of course, same is true with Gmail also. There are other alternatives that are there we haven't even looked at, right? So for example, for YouTube, you have Vimeo, which doesn't really track through cookies what actions you are doing, right? And DTube is a good competitor for YouTube for that matter, right? They use blockchain technology, most trustable one so far that we can see. Yeah, and minor things like, I have the default browser as Google Web, right? Google Web browser is my default browser. So after having gone through all these tracking records, I go shop in one store, it immediately knows where I have parked my car and, every nitty-gritty details, how many minutes I have spent there. In order to avoid, I have moved couple of things on my own to Firefox is one that is also relatively better, right? And Opera is another one which does not track your session cookies. You can at least turn it off and you will know they'll ask permission before they turn it on and track, right? I think what has happened primarily is we haven't even bothered to look whether there are alternatives. The Facebook crash that has happened has given each individual at least to think through what next, what can I do, and what can government and filing penalties and act can do, right? My quick suggestion for all the folks who are listening is there are alternatives for browser, alternatives for YouTube, alternatives for caching mechanism and things like that, which we go by default, right? So those things we can definitely change. And even for the Google search, right? Bing is also from Microsoft. Of course, that is also part of the big tech problems and big tech companies. But DuckDuckGo is another one which really is worth trying it out. I think you should give it a shot on they have both, web version and also mobile version. So we should be good there. I'm using that. So I'll keep it short, Soma, but yeah, in a nutshell, I would say we should do our bit intentionally moving away from the centralized one to a decentralized one, taking few of the actions that I just now said, and leave and also go hand in hand with the government to file the act if that is going on and signing the petition and things like that.
So yeah, that was a really, really good security tip we should all follow. And yeah, we have never tried to look for alternatives, probably because most of us are already there on like Facebook or WhatsApp. So when we have to connect, practically all of us should shift to the other platform. Then maybe it will be still.
I think Telegram was a good one. I think people really quickly at least adapted to that. Yeah.
That is there.
That came out of action as a fear rather than willingness, I would say.
Yeah, but if China can do that they have their own system and method for all the social networking, definitely we should also do something like that. Sure.
So we know, right? The coup is coming as alternative Atmanirbhar thing from India for Twitter. So we should try it out. Yeah.
Yes. I moved away from them, but I am in coup. But yeah, there are a lot of options. We should do that, and we should not put all the eggs in one basket. That is a good summary. Thanks a lot, Vidya. And we this as we are aware that our today's panel is theme of the panel is clean technology for sustainable world. So I wanted to take up a few questions relating to the theme, and also it is an urgent demand of today's climate change and global warming scenario, which is right over here, like it is on our doorstep, and things need to be done to it has to be addressed and corrected. Of course, there are talks going on about zero net emissions in 2050 and things like that. But I feel 2050 is quite far away, and what needs to be done is right here, right now, today, because climate change is already here and it is impacting every single person on this planet. So in line of this theme, I will I'll first, very important question to ma'am, because so it relates to, it's coming from myself. I am coming from a telecom company, and there is lot of discussion going on around green telecom, sustainable telecom, and even DOT and TRI are also laying emphasis on it for quite some time now. So, ma'am, Pamela ma'am, my question to you, can you throw some light on these terms and what India can be doing in this domain?
So I think I'm audible, right? Yeah.
Yes.
So I think we need to step back a little and think about the role that telecom is now playing, as Aloknath Dey and earlier Mr. Dev also mentioned that Mr. Kumar, Dharmendra Kumar also mentioned that the role, the big thing that's happening today, the 5G era and beyond, is about taking technology into all aspects of our life. And one of the big things is that we are now in the virtual world. What does that mean? What does that mean? We saw in the pandemic era, we are working from home. So that is all making us more green, right? We are traveling less. We are doing a lot of things virtually, which otherwise would, increase the carbon footprint. And a case in point that I want to make is that if you look at the carbon footprint, per capita carbon footprint of North America, that is 1,672 watts.
Wow.
Okay, per person. And for India, it is 87 watts. Just see the difference. Now, if every Indian wants to live the same lifestyle, the same quality of life that people sitting in the US have, is the cost going to be to increase the carbon footprint to 1,670? If we do that, the world will fry, right? So yes, green technology is becoming green. There's no answer to, there's no, we all want that lifestyle. We all aspire that, okay? And it's becoming more and more visible to us how that lifestyle works. Everybody wants it, but we have to think about ways of accomplishing. And as I said, the pandemic and telecom is showing one aspect, is a very big aspect of reducing the carbon footprint, where a lot can be done without traveling, right? That's a big thing that can be done. But then I think that there's this traditional talk about green technology, sustainable technology, looking at telecom itself, right? Telecom has become all about the data centers. Now these huge data centers running, the amount of power that they guzzle, okay, we should be designing green data centers. We should be reducing the carbon footprint emanating from these data centers. Let's look at e-waste. I think that's where it's a big red when it comes to telecom. And with guys like Samsung and Jio here, I mean, we should confront them and say, hey guys, why do I have to change my phone every 3 years? My Samsung Galaxy 1, my Samsung Note Galaxy 1 is still pretty good, but you just don't allow me to put new software in it. You don't allow me to change the battery and make it start working again. Why are you doing this? Why are you creating so much more waste? Okay, so e-waste is a big culprit. Okay, and I think we should make it a mission, maybe a national mission to really make a big change with respect to e-waste. And the third area which I'm beginning to think, the big term that is doing the rounds, is this dematerialization, right? So can we do things without using materials? Can we achieve the same function or the same objective? And eSIM is a case in point, right? So rather than having SIM cards, right? Look at the payment industry, right? You had notes, and then you had checkbooks, and then you had plastic cards, and now you have Paytm. okay, or Google Pay or whatever, right? And so I think the more and more it's a big mindset change, and as you said, it's needed now. It's very urgent, and if we don't do due diligence on this, on all aspects of what we are developing in telecom and the role that telecom and IT can play in all aspects of our lives to reduce the carbon footprint that we are creating is what this is all about. Right?
Yes, very true. So very good idea that we should move away from our plastic cards and go more for ATMs. And yeah, green data center is very much in, it is the need of the hour. All the telecoms should go for it. And in fact, all the big tech and cloud companies should go for green data centers. Yeah, that's very important. Thanks, ma'am.
But more important is this. I shouldn't have to change this every 3 years.
Oh, yes. Recyclable phones. So if that
I
is
use this
when
sari
you
for more than 20 years, right?
Yeah.
Right? I don't throw away my sari for 20. Even my mother's or my grandmother's saris are still there, 40, 50, 60 years. Why do I have to throw away my phone every 3 years?
Yes, and we Indians are actually very good in recycling, and actually we will continue with our phones if we are allowed to change the batteries. That is very true, actually. Yeah. Thanks, ma'am. For
So I hope Alok will address this when he talks.
Yeah. You have put him in tight spot. Aloji, you will have to think of a good reply for that one. So my next question, of course, since ma'am has put across, I'll go to Alokji and Alok sir. So how do you see IoT enabling clean and sustainable technologies?
So I have learned not to be afraid of such confrontations, and I happily accept this. From Samsung, we have done already Galaxy upcycling, and I'm not going to talk about this today because our topic is different, but it is exactly this point of UN sustainability goals and the SDGs that are there, and how you can reuse the phone. See, we need our business that we want you to buy new phones, but I would like to help you to get the old phones, do something that is interesting for you. So that would be my proposal. And I would love to also, as IEEE ComSoc Bangalore chair, can we do an e-waste topic discussions on TSDSI and IEEE either in November or in December? We will bring other people and let's do a small 3 hours workshops on this. Sure. I would happily invite. So that's the response on that. Now, do you have questions?
Yeah, so my question was about how do you see IoT enabling clean and sustainable technology?
Oh, yeah, sure. But I was thinking I sent quickly a video to Neha because this is evening time and we are just talking serious topics. Neha, would you be able to play the video?
Adit, can we have the video, please?
Okay, look, 2 minutes.
Yes.
2 minutes video.
Yes, of course.
You okay? You need a minute? Cool. Okay. Listen up, people. I know a thing or two about extinction. And let me tell you, and you'd kind of think this would be obvious, going extinct is a bad thing. And driving yourselves extinct in 70 million years, that's the most ridiculous thing I've ever heard. At least we had an asteroid. What's your excuse? You're headed for a climate disaster, and yet every year governments spend hundreds of billions of public funds on fossil fuel subsidies. Imagine if we had spent hundreds of billions per year subsidizing giant meteors. That's what you're doing right now. Think of all the other things you could do with that money. Around the world, people are living in poverty. Don't you think helping them would make more sense than, I don't know, paying for the demise of your entire species? Let me be real for a second. You've got a huge opportunity right now. As you rebuild your economies and bounce back from this pandemic, this is humanity's big chance. So here's my wild idea. Don't choose extinction. Save your species before it's too late. It's time for you humans to stop making excuses and start making changes. Thank you.
So thank you. I think that sums it up. We need to take those actions and for the next generations for sure. And your questions coming back to this was just a breather to see, and really it's a nice capturing. So I think the IoT, when you talk about green tech, clean tech, it's all about clean energy, environment, sustainable, and it's long-term things, health of environment, but also health of people. See, we cannot do things just thinking about environment, then people are not motivated enough. So there has to be a win-win equations into this. And, this is where we think about whether it is renewable energy, the battery, the energy density, we are packing it up closer. You have a lot of sensors, BLE, Bluetooth low energy, and many protocols that are coming, which is consuming much less energy. Because the whole idea of IoT is not about you consuming more power in monitoring than actually you are saving, because then you end up minus, So how do you do the sensing very minimally yet profoundly is a area of research that is happening, and the receiver sensitivity and many things around that. And then we talk about smart city, and Pamela knows the TSDSI has done this one M2M adopted as standard for India. And we are also working on OCF on the smart home and building to be able to exchange data. But for example, in the city, if there is a air quality that is going down, if it is monitored there, measured there, I could actually pull that data, and at home I can turn the air purifier, but I don't need to do it for all the time. But how do I know? So monitoring and actually activating could be done interestingly. So similar to that, if you are talking about delivery, which route to take, you can do a lot of optimization. The garbage collections, if there is no garbage in the can, why do you go there? These are small things, but there are a lot of algorithms that are in place, and people have been working on this. And, we were talking about, Vidya mentioned about the whole data and how data could be product, but the big data is everywhere. And whether it is weather shift, we talk about energy consumptions, emissions, atmosphere, water conditions, whether water is getting leaked or not. So I think IoT is all about measuring, monitoring, knowing what it is. Because if you don't measure, if you don't monitor, you can't improve the situation. So that's a first step. And then wherever you can automate, then you do automate, right? In some cases, human interventions would be needed. And it's perfectly fine, and you can gradually go. And then obviously we can see, very IoT focused. If I have the data and the blockchain kind of adjacent technology could be also connected, and I could share that data to someone in a trustworthy way. And that's what I mean by win-win, because I shouldn't be afraid of giving. If somebody pushes me Why are you not giving data? I don't have a mechanism to be knowing whom am I giving and how are they using. But if I have a technology to assist, I would be definitely loving to share that data and helping them to also automate or improve the situation. So I think these technologies would come, and I'm sure we can keep on talking about agriculture sensors, the soil sensors. They all have utilities, and it is touching every verticals. And then AI and IoT, or 5G and IoT, or blockchain and IoT, they could be combined to be able to give good results. So I hope I answered partly, and hope you enjoyed the video. Thank you.
Thank you, sir. The video was really very interesting and very enjoyable. So low energy sensors is your take, and we should automate whenever we can. Yeah, that is true. And in one way, we have been able to do it to some extent due to the pandemic. Like even in the video, it was told that post-pandemic you have a time to you have like it gave us time to take a step back and see that there were actually changes in the environment also observed at that time, and there were filling up of the ozone layer, and there was it has helped rejuvenating the planet a bit. So it will be nice if we continue that way for some more time, like as Pamela madam also told earlier. So thanks a lot for that, for the answer, sir. And I will, this next question is to sir, Dharamji. Dharamji, since you have been in product design and development, and you have very long experience, rich experience in the product design and development, varying from aerospace to even here in telecom, in geo and consumer electronics. So what do you feel can be the best practices for clean technology in electronics product development?
Yeah, ma'am. So, first let me talk about the, the volume of the problem. What is the order of magnitude that we are talking about? And, as someone coming from the devices team, Geo, I'm talking about what I team does, but actually how we should do better, right? So that is how I look at it. And see, Pamela ma'am's actually the point on the electronic waste. And if I look at data which is not very recent, in year 2016, worldwide, 46.6 million metric ton of electronic waste was generated, right? And in the same year, if I look at the population, which was around 7 billion, it comes to around 6.25 kg per capita. So that is a kind of, what we call electronic waste. This is just one of the types of waste that, we as human beings are generating on this planet, right? And then see, if you look at the electricity consumption, the ICT, the information communication technology as such, it contributes about, it takes about 5% of the global consumption. And then actually, we talk about, madam talked about, we don't want to, basically update our mobile phones, but, but what exactly we do? And, the kinds of, the features that we get, or even actually, how the old phones become irreparable, level on the battery or something like that. So in fact, actually the question, which is very, very true question, I would say, is actually the 8 billion population that we have in the world today, how many devices do we really need, right? So, we are going to add, I don't know, several billions of them, and, we have IoT and all that coming up in a big way. See, even for geophone, something like the, geophone product, actually, last 3 to 4 years, we have produced more than 100 million phones for the Indian market. So, but then actually, though we aspire, we want to add gadgets and we want to add features, but then, can we do it in a better way so that ultimately the impact is not so severe? And in fact, that would also help us to do something more than what we are doing today, right? So if you look at actually, see, one of the areas that we have to see, all of us globally, we have been trying is to use as much as possible of the recycled material, including plastic. So, it is happening, but, not to a very, I would say, good extent, right? And then actually, see, if we look at new materials, actually, a lot of research is going on material technology, that is a very, it is a continuous development. See, we have to look for materials that would cause less of impact on the environment and even actually, tackle water scarcity issue. So, a small chip that you see sitting on the PCBA, the component that we deal with, it takes almost like 50 to 100 liters of water to give it to that finish. And then actually, see some of the things that we have to look at, like even miniaturization is one thing, right? So the smaller the device, of course, obviously it calls for less of materials. And then product life, right? So product life, the way actually madam said, and when someone madam said that we want to use our current devices and old devices. But so if we, if we can do all that, then definitely we are going to load the planet less and less. And then we have low and non-waste technologies and all that. We have what we call 3R principle: reduce, recycle, and reuse. And the whole design philosophy actually, that is very, very important. That see, we had a lot of optimization parameters, right? We want to reduce the cycle time. We want to reduce the cost and so on and so forth. But then actually, see, we have to start looking at in terms of what we take from the environment and what we give back to the environment, right? So this actually has to sit in the mind of the designer when he or she chooses a process or technology or material or whatever it is. So that conscious thought actually, because see, we are going to add. So whether we like it or not, we're ambitious, over ambitious, we will be adding millions, billions of devices. That would happen. We may end up seeing a problem. But it is hard to rather than it will have to bring in some wisdom and bit of better sense that how we do all that in a way that the impact at the end is less. And in fact, actually, like see, when we talk about fuels, just to give an analogy, so we have fossil fuels, right? So which actually depleting, and we have the per liter petrol price going up every month. So, the other aspect what I want to bring to everybody notice is that, see, when you burn a liter of petrol or kerosene or diesel, what waste it generates versus actually, what we talk about cryogenic fuel, right? So we have hydrogen and oxygen, liquid hydrogen, liquid oxygen. The end product is water, which is harmless. So can we do something that actually whatever at the end remains, what cannot be recycled is harmless, right? Because you dump, but dump is how much do you dump, and after dumping, what it leads to, how it degenerates further and creates more problem on the planet. So all that, see, ideally we should not have any waste. So if you can do that, consume less of material, consume less of electricity, and at the end leave nothing, right? So that is what we have to look at. And that is how we can grow probably, without regretting and without being too much careful about what we are doing. So, we need to attempt that. Yeah.
Somaji, you're on mute. You're on mute.
We can't hear you.
Thank you, Dharamji. Sorry, I was on mute. Thanks a lot for giving this interesting insight into how to think about the green design right from the design phase to manufacturing phase of the product.
At every stage, actually, we have to have that, conscious thinking at every stage.
For a product, and also keeping miniaturization and very interesting that to be ensuring that whatever waste is generated from the product should be a green waste and should be either compostable or recyclable. So
Yes.
thank you so much, sir, for this very interesting insight. My next question goes to Vidya, and sorry Vidya to keep you waiting. It seems Vidya has to go for another. She has another meeting online. So just one last question to you, Vidya, that the AI and ML are emerging trends in post-pandemic world. So how do you see them contribute to clean and sustainable world?
This goes really hand in hand with what Alok said, right? So primarily from sensors or IoT. In fact, I like the way how we put it as integration of technologies, right? So the data that you guys collect from the IoT sensors, from the AI technology, we can literally manipulate with the step-by-step process, looking at how clean the data is. If not, we do the data wrangling on that. Make sure the purged data is good enough for us to build models and give, right? For AIML, primarily, it is all about the vast data set that we have, and especially in a good structured way, that would be more meaningful. In a specific scenario of the sustainable or the renewable energy space, right? So building the smart grid is something everywhere everybody has started, but you can't build a grid and assume that your back of envelope calculation has been so well done that you can pump in energy or the power at one go, right? You have to have capacity planning baked in, or else your offloading of power energy that comes in, it can really pull back the whole grid down, right? That's where AI plays a really significant role, I would say, and lots of use cases for sure, like be it in biodiversity or be it in ocean technology or air purification. Is a lot more spaces where I can think of AI is already playing a vital role. And in fact, IBM has done this sunshot exercise where they have increased their efficiency by 30% using the same IoT sensor data, satellite images, and also sky cameras that has been launched. And using the AI algorithm, primarily the reinforcing algorithms that they have used, huge 30% increase in the efficiency, right? So sorry, I have to take leave now, but thanks a ton for the opportunity, and we should do our bit. And I take an oath that I'll do my bit in whatever way I can to keep this, next gen growing and coming along. Thank you.
Thank you so much, Vidya. Sorry to keep you waiting, and we little bit overshot over time here because of. So it was very interesting discussion, and we got so much absorbed in it. So thanks a lot for giving your time and spending time with us, and looking forward to having more interaction with you. So we will meet again, Vidya. Thanks a lot. Thanks from Young Professional team, and we just a small memento for you from Young Professionals team. So please accept our gratitude and thanks for being here with us and spending time with us. Thank you, Vidya.
Thank you. Thank you.
So moving on to the next question. It's over to so basically I think Vidya was the one in this round, and my next I hand over the baton to Neha to take up questions relating to young professionals and IEEE, because we look forward to our tech icons to being a mentor for our young professionals, and they look up to you. And there Neha will be asking some couple of questions to our tech icons relating to that. Over to you, Neha. Thank you.
Thank you, Soma ma'am. It's such an interesting session and so much tons of information coming to us. So really thank you once again for joining us. My first question is to Alok sir. Sir, every year we have more and more engineers getting added in our community, and profession like software engineering and telecommunication, big data, aerospace, AI. These are some of the favorite paths which the youth, eventually takes up. How do you see the young professionals contributing in the area of clean tech?
Okay. I think it's not a question of, see, CleanTech, that awareness itself is kind of relatively new for all the people, because we are seeing, our environment is affected, and COVID time, I think all these animals coming out, and, the sky was blue. So it gave a thing that how much we spoiled that. So I think this awareness is coming from theory and practice, and the need and the warming that is happening. So I won't blame anybody not doing their bits, because if you didn't have the awareness. But now that we got it, I think how do you move forward is the point. And IEEE, 400,000 global members, and even in India, I think 50,000 plus members that are there. And Bangalore section has been the largest one. And, we are even in ComSoc close to 400 plus people that are working. And we do organize many sessions. Recently, we did a 5G for student 10-hour sessions. I think my message would be, it is about different domains. So whether it is AI, whether it is 5G communication, whether it is IoT, people need to, willingness to do something for environment is good. That's a first step. But to do, it's a serious study, it's a serious contribution. So I would like to invite young professionals to take a deeper subject, whether it is materials. So it's not about just that I want to do. So one is an awareness and deployment. And if you are a social activist or a social scientist, that's a good path. But for many of the others, those who are engineers, it is a deep work. And it's much deeper than if I have to make an emoji onto the phone, right? That's much easier job than devising what can replace lithium ion battery, right? If that is not available for India, or it's polluting in some cases with certain other contaminants, then what does it come? So it is a much deeper research beyond the first level. First level could be this. So what brings sustainability? So I would like to invite the young professionals to be aware and great and do the social service, but to solve it, we need to join force into research, engagement, development in whichever ways. AI can go from predictive to prescriptive or recommendations. If you are an AI, if you are an IoT, I can do the low power sensors and sensor designs. If you are in material science, you can bring that. But you have to do that research to bring out this. And that's what we need for the country. And India needs even more, because we want cost-effective solutions. Many other countries might find one solution that is expensive, but they can live with that and that can solve. But for us, it's a double things that we have to hit. One is finding the materials, and then obviously, is it going to be an cost-effective solutions for whichever way we look into it. So I would love to encourage this young community to come forward, spend time in books, in meetings, in things, not just the conferences and listening. So I always kind of say that knowing is just knowing, but only doing is doing. So this is my phrase, knowledge is power, and good to know, but knowing will not solve the problem. You have to do it. And I, again, invite everybody. I'm sure the people here, they are very serious ones. And those who need to listen, maybe they are not here. But that's the message, knowing is just knowing, and only doing is doing. I'll pause here.
Thank you so much for that awareness, social service in solving the problems, and doing more research as to how we can, come up with better solution. I completely resonate with cost-effective solutions, working in IoT. So that was quite, something which we look forward to from the young professionals. Thank you, sir, for the answer. My next question is to Pamela, ma'am. You have long years of relationship with IEEE, and I myself had the pleasure of, listening to you first at GHCI, and then I interacted with you in one of the IEEE conferences. So, in your experience with IEEE, how do you feel that industries can engage better with the IEEE young professionals? Beyond these webinars or the panel discussions that we have?
So, I would want to reverse your question. I think the question needs to be posed to the young professionals. What do they want from the industry or from industry veterans? How is it going? They are the ones who are defining the future, right? The platforms are all enablers for them. What is it that they need? What do they feel will help them? What are their aspirations and dreams? And how can we play a role from, how do they want to engage with industry? And there are different ways in which you can do that. Okay, a case in point is your Chengappa. Okay, I don't know where I met him, but he's latched on. He's just latched on into various activities that I've done and stayed with me in CCICI in roles, and I'm sure he's getting some value out of it, that he continues to engage, right? Okay, so we are all available. I'm sure I would be more than happy to be a mentor to anybody who feels that that I can add value to their journey. Okay, in my own personal capacity. In TSDSI, there are so many things that we do which we can make available to the young professionals, like our TTDD conference, for instance, right? We do have a MOU with IEEE, but I'm not sure that the information was circulated to the young professionals about the TTDD events. And your young professionals could easily have joined and benefited from it. We can make the ITU meetings available to you. Okay. If your company is a member of TSDSI, we can make all the 3GPP and 1M2M meetings available to you. Everything is virtual today, right? For your growth and your development and your technological, and there's so many opportunities, so many initiatives happening in these bodies that you can partake of, right? So, so really the question is, I would really put it in the reverse direction. I would say that the young professionals, you need to, what would you like to do at Reliance Jio, right? Go and tell Dharmendra that, okay, this is what we want to make happen. And I'm sure he has enough influence out there. And so between you, Soma and Dharmendra, they can make it happen, right? And Loknath can make things happen in Samsung for young professionals. And there's a lot that I can do, and we have all these other people, but you guys need to come up with your wish list, your plan, and let us know what you need, right?
Absolutely.
Does that make sense? Does that make sense?
Absolutely.
Then create a roadmap. Decide that top 3 things the young professional community wants for next year, and let's work on it together.
Done, definitely. In
Even
fact,
if you have taken, I just like to echo this point, because this is very vital, and we go in many places. The mentors are ready, and let's say this event itself, and if you have the video and some people could not join, would you play amidst a youth professionals? Maybe start them up, replay it, let them listen to this, so that this message is reached. Otherwise, it stays with a set of people who in any case would know this, right? Thank you.
It's a great message, Pamela ma'am. And, really, actually, we should be open to their inputs, and, we should try to, do whatever we can do so that, our course is also, improved, right? Actually, we probably would retire more satisfied, right?
No, there's no retirement. You keep us busy, right?
Yes, I mean, it's wonderful. It's wonderful. I mean, it's a very, very powerful message that you've given.
So we want to make them successful. We want to find a way to stay engaged with the young people. So we are all there. You guys need to decide what you
Incidentally, our chairman, great Mr. Ambani, he says that whenever I talk to my kids, I was not like this. I could never say like this to my dad. And every time what I get to hear, Dad, you won't understand. I'm trying to tell you is you won't understand. And that is how actually I keep myself learning. That's what he says. I mean, it's a great message. Yes, thanks, ma'am. Really great message. Yeah.
Thank you so much. I in fact do resonate with Dharmendra sir, because many a times I go up to my managers or leads. It takes some time for them to resonate with our ideas, because we have different approaches, different way of doing things. So, but still, yes, things are improving. We are getting a lot of encouragement, support. One of Somaji is a great example. She always pushes youth and young energy in different directions. So yes, definitely we will reach out to our mentors. So thank you, ma'am, for that.
Neha and Soma ma'am, I think we'll have to try to get Pamela ma'am into Geo.
More than happy to come anytime you want me to.
So, sir, moving on, my next question is to Dharmendra sir. Burnout has become a buzzword amongst the youth. I find many of my friends taking sabbaticals and going on long vacations to, just to, come out of the situation or function better post that. So, with so many years of industry experience, what advice would you give the young professionals, who are facing cutthroat competition and who needs to meet their career aspirations?
Right. Actually, I would like to tell a small story, which one of my teachers told me when I was in my primary classes. And, that was a message which was given to me, very useful and a strong message, and which I would like to share, probably that a small contribution that I would like to make this evening to all my young friends. So let me tell that story. So, it goes like this, that, there was a guru, we have guru parampara, right? So we have, one of the gurus in our system who had a lot of disciples, and the guru actually taught a lot of life skills and also, what we call martial arts, right? So one of the things that he taught was fencing, fighting with a sword. So, obviously the training and the course and everything came to an end, and all had to depart. They give Guru Dakshina and all that, they depart. And then actually one of the disciples, somehow actually he got a thought in his mind that actually at the end of the training, he became better than his Guru. Okay. And, it didn't stop there. He went on announcing, and in fact, he did schedule a fight, a fencing session with his guru to prove that he was better than his guru. And he announced that on this date, at this time, at this venue, there will be a fencing, event. And he announced that I would prove that I'm better than my guru. Okay, all done. Guru somehow, in all his simplicity, he accepted the challenge. And he said, fine, let us see. Let me see what I have taught you, right? So it is a test for me as well. And, then actually between that day and the day when the fight was supposed to happen, there were, several days, several weeks probably. And Guru understood, after all, he's Guru. And he understood where this thought is coming from. So then he did, very interesting. He announced that, well, I will come on this day and I'll fight with a sword which will be 1 meter long. Okay. The disciple heard that, and he announced that if my guru is coming with a sword which is 1 meter long, I would come with a sword which would be 2 meter long. And it went on for several days, of course, several weeks, till the day of the fight arrived. And, there was probably something like a stadium where Guru and his disciple, they all gathered with a lot of big crowd. And then actually, what we saw, that actually the disciple landed there with a long sword, probably several meters long. And Guru, actually, he was just hiding somewhere in the crowd. And, what people noticed that, he was hardly having a sword with him. So, how he is going to fight? Then actually, with great, in a very simplistic way, he pulled out. He had probably just a, half a meter kind of, you may call it sword or knife. That's all he had. And the fight was supposed to start. And to everybody's surprise, what happened is that the disciple had, almost like say 15 or 20 meter long sword. And he had great difficulty in even handling the sword. And he ended up bruising himself. So then actually finally he understood that there was a mistake, and the guru somehow actually proved a trick, something that he is wiser than him. And then guru came to him. He said, "My son, I know you are very good at fencing, and probably you could have defeated me as well. But then what happened is I taught you how to hold your sword, but I didn't teach you. I forgot to teach you how to hold your self-confidence." So this is the message which I want to give to all my young professionals, all of them, that actually if you look at, there is no competition in life. So long as you are steady on your feet, you know what you are going to do and you know how you are going to do. Please keep your feet steady on the ground and then do whatever you want. Nobody in the world can shake you. And see, the beautiful part is that, see, the competition as such itself is not bad. When we are good at competition, we love it, we enjoy it. The trouble comes actually when we do not know how to go through that process. And one actually, effort that we have to make actually is to maintain our steadiness. And as years go by, actually, I see all the virtues that we can have ever, we can imbibe as professionals. All the virtues are actually included in the one term called steadiness. So please maintain that. Do whatever you want with all your heart. I assure you, nobody will be there to be able to even attempt to cut your throat. This is my assurance with whatever experience I have as a professional. It will just not happen, and you would go places. There won't be anybody or anything that would ever stop you. So please keep your feet steady on the ground. Thank you.
Yeah, if I may, I would like to add that don't join the rat race. It only proves that you are a rat. Okay? Stay out of the rat race. Work for clean technology. What a big objective in life, right? There's so much. Follow your passion, and you'll go places.
Thank you, sir. Thank you, ma'am. Keeping feet steady and having the confidence. Yes, definitely. We youths need that, and we should wear that every time. Thank you. I know
there is no competition. Let me add. Jio is doing well, but Sunil Mittal is still alive, right? He's still alive, and he would be. Okay.
Thank you, sir. So I know we have passed the time of the fireside chat, but I do not want to leave this question. And this last question is to Sobha ma'am. We are at Geo together and we participate in various events. Reliance has a wonderful community for the women. So, ma'am, what do women are breaking the glass ceiling and finding themselves, moving up the ladder and, they are standing headstrong. But yet they find some resistance. What would be your advice to the young women professionals?
Again, she's muted.
Ma'am, you're on mute.
Thanks for asking this question, Neha. So, advice for young professionals, most important that, as Dharamji said, that applies even more to the young women professionals, that they should have that confidence. The self-confidence is very important. I have seen I've been taking a lot of interviews and I've been interacting with a lot of young girls, upcoming techies who have just passed out or who are 2 or 3 years into into technology and as a working as a professional. And what I have seen is that they are not at all sure that they will be continuing with the job, or they will be even continuing in the same domain is a far off thing, even continuing in the job also, or continuing in the same place also. And the reason that they have been seeing is I may get due to family commitment, which of course we understand. If they are unmarried, it is due to maybe they will get married. So that one point is always there in their mind, that if they're taking up a job or if they're taking up a profession, they may have to leave it, that like they come ready and prepared for that in mind. So I will like to advise all the young women out there, please, for God's sake, think about yourself for once. Follow your career, follow your ambition, follow your passion. And of course, family is there, commitment is there, but it is there for both the spouses. It's not your sole responsibility. The family will not stop running if you family will not stop happening, or things in events, or children going to school and things. All this will keep happening even if you are not there or busy with some other engagement. So please, you have to stop feeling guilty about it, and please don't compromise on these situations, and think that your career or profession, your passion, your everything is as important as your male spouse or male counterparts. And don't pursue your career as a time pass, like joining up till the marriage happens, and then I don't know if I will continue, depends on my husband, or I may go to the other place and then I will see if I get a job. Please don't do that, because this shows a very, very unprofessional approach. And the person who is hiring you, they also feel, that's a sorry figure. So this is my very important advice to all the young girls and professionals out there. And I think time is changing, and situations are changing. I have 2 daughters, and even in my daughter, I have seen that she is very particular about not to mix the career and family at all. She is very, very professional in that matter. I'm quite proud of it, and I want all the young girls out there to please follow that. Yeah. Because as you said, the breaking of glass ceiling, so the attitude has to come from both the ways. It cannot happen that we keep pulling the women techies up and up, but they don't want to climb up. That has to, if you take yourself seriously, the world will definitely take you seriously. So you have to start respecting yourself and start taking your work seriously, and automatically it will come to you. Your respect, your knowledge, everything will come to you. That's my advice.
Thank you so much, ma'am. Thank you. That again, it was quite a resonating statement that you made. Yes, we are getting as professional as possible and learning from such great women veterans out there. Thank you for showing us light, and thank you for pulling us up. Dharminder sir, Alok Nath sir, I'm sure you guys push women more and more in your organizations. So we are really appreciative for that. So thank you so much. So with this, we would want to conclude the chat for today. Any of the panelists want to make any concluding comments? They may. Okay. So we would want to thank Pamela ma'am with a small token of appreciation for being part of the discussion. Thank you so much, ma'am, for being with us.
Thank you.
Thank you so much for joining up so early from California. Really appreciate it. We want to thank Dharmendra sir for joining us and giving us some insightful thoughts. Thank you, sir.
Thank you. Thank you very much.
We want to thank Alotnath sir. Thank you, sir, for being amongst us. Your inputs have really given us a lot of motivation. Vidya is thank you, Soma ma'am, for co-moderating with me and giving me so much insightful information as to how to conduct the fireside chat. So thank you so much. Now I hand over it to Devdeep.
Yeah, well, I mean, it was a very enriching panel discussion, and I'm sure I think all the attendees, and especially the young professionals there, would make use of the advice and the information that was disseminated. I mean, and of course, as you mentioned, Neha, thanks to Soma madam and you, I can see. So you should also appreciate the memento that is being presented, virtual memento, for beautifully conducting this session. So although we overshoot a little bit of time, but that was worth it. I mean, we had a lot of interesting information and discussion that actually happened. So before I think we go to the formal vote of thanks, I can see Prashant Mishra ji here among with us. I mean, he's the organizing chair of the BTC. So I would request Prashant to speak a few words before we formally conclude. So, yeah. You're on mute, Prashant. Can you unmute yourself? Okay, I think there is some issue. So, Neha, can you ping him a bit? And
yeah, while he joins back, can we have Moinam? We can see him. He's our chair.
Yeah, Moinam is also here.
Hi, can you hear me?
Yes, Moinam. You're
Okay,
audible.
cool. Yeah, so again, thank you to the all the members of the Young Professionals Bangalore section, specifically Neha and Devdeep, for being a part of the organizing committee for this event. It was very beautifully done, and yes, I heard a lot of our panelists talk about starting collaborations with young professionals. And to be very honest, as a chair-elect and the chair of the next year, I'm very happy to hear that, and would obviously take your word and would get back to you and will trouble a lot of you so that we can try to give the young professionals a bigger domain or a bigger platform to get in touch with esteemed professionals like you. And I think it would be a teaching process from both the sides. And again, thank you all the panelists for being here, and I wish you and your family safety and this COVID times. Thank you. Over to you, Neha.
We have Prashant.
Thank you very much. Thank you.
Yeah. We have Prashant sir. Sir, could you give us a few concluding statements?
Yes. So good evening, everyone. Sorry, I've just changed because it was touching 8, so I just had to change in the morning. Sorry for that. But I was setting the session. Thank you to all the tech icons who joined for the session. Thanks to Dipanjan for accepting to deliver a keynote here. And thanks to the entire YP team. I think the YP team has been instrumental in working so well with the larger BTC organizing team and pulling off this event in such a wonderful fashion. In fact, I think the session was so well carved in terms of not only covering the topic of clean tech, but also covering the other other aspects in terms of what can YP learn from tech icons so that they can take forward and apply them in a professional life. So thank you to all the tech icons. Thank you to Dipanjan for the keynote, and thank you to the entire XCOM team. Thank you very much, Neha. Very well done. Thank you.
Thanks, Prashantji. Finally, we get to see you.
Yeah, thank you, Madam Soma. Madam, thanks for all the support. I think, this tech icon is something you have been spearheading from the beginning of this year, and I think this is a vision you had with giving all the tech icons a platform to speak out and connect with Bangalore section members in that. So I think what you had aspired at the beginning of the year, that came true today. So thank you for putting that thought process forward. Thank you.
Thank you, sir. Devdeep, over to you.
Yeah, okay. So I think thanks for the words, Prashantji. And I would formally conclude the session with the vote of thanks. So, I mean, starting from the keynote speaker to all the panelists who shared their valuable inputs and suggestions, I thank you all on the behalf of our YP team. And of course, the entire BTC organizing team, the YP Execom members and the moderators who made this YP Global Summit, the different aspects of that possible and organized in a very professional way. So thanks to all. And last but not the least, I would extend the thanks to all the student and YP volunteers who actually contributed from the back end to make the thing run smoothly. And especially, I mean, Chengappa, I think, is handling every session very beautifully. And also Neha and Ketan. So everyone, so thanks a lot on behalf of the YP team. So I would like to formally conclude the session. So be part of the, I think tomorrow also we have a lot of activities in BTC. So I request everyone to join there as well. Thanks again.
Thank you, Devdeep, for a wonderful anchoring session. Thank you. Thank you.
Happy Diwali to all.
Thank you.
Yeah.
Thank you.
Diwali, yeah.
Thank you. It was wonderful being here in this session, and look forward to more opportunity or more.
Okay.
sessions.
Happy Diwali.
Next week is Diwali, and please
Yes,
enjoy Diwali and burst crackers. Don't worry.
No burst crackers or burst crackers?
Burst crackers.
we
Afterwards,
we are talking about e-waste, right? So no
That's
waste
clean
here.
technology. We need to do clean crackers. We need to have clean crackers.
green
I
crackers.
hope they
Green.
exist in the market.
Virtual crackers, which make the noise but don't make the smoke. They make the noise but not the smoke.
Yeah, that's a good idea, I think. Right.
Okay.
Yeah.
Good night.
Okay. Bye.
Thank you, everyone. See you. Bye-bye.